Yeah.
I've been so busy preparing all the presentations.
No, it is. I think people, you have done so much work. I think it is important that people know about it. And actually, your lecture and score was very good the other day.
Ah, okay, great.
Was
Thank you. Yeah.
fantastic. And in fact, this some of the papers on your, the geogrids and payments. In fact, Mr. Bagley is here. Bagley, actually, Professor Jehan has done so much work on payments.
Yes, we are aware. In fact, I'm rather flattered to be co-chairing his lecture.
Actually, the thing is that I have see the Indian Roads Congress. There are two things that they're doing, but the kind of work here. Actually, the other day conveniently there are certain things that didn't understand. I purposefully sent a set of papers from him and how that method is used, because the advanced method he has been doing continuously. It's not that his work is continuous. So there was another thing, that how do you calculate the resilient modulus of a geocell section and whatever
Okay.
he has done. No, not that. Not only that. Beyond that, the thing is that the radial the thing is that the radial strain distribution in the pavement, that locking interlock, that was a beautiful thing, which is not considered in Indian Roads Congress. I sent a bunch of papers that you have been biased about planar and these sort of things, but you should understand that there is a different understanding. You should understand this. And I sent a paper to Rahul, but the way our friends do, they have a way. I don't want to put too much into that, but I purposefully sent. I like those papers. Yeah.
I give a lecture at the Geotechnical on payments.
Yeah.
Professor Sai, how are you?
Yeah.
Good.
Good morning.
If I will
Professor
give
Dehan?
another one. Yeah, how are you?
How are you? Good morning. Good evening. Sorry.
Yeah.
This is why I try to give a different talk. I don't want to give the same talk.
Correct. No, it is perfect. Even this is also quite interesting, whatever you're going to talk. And because, see what is happening, most of them, the construction issues are here. The challenges are more in construction and lack of understanding of the reinforced soil principle itself. That's what I see. A lot of failures in India. I mean, that was what I see.
Okay. But my talk was mostly on design.
Special. I know that. There's special things, special conditions of design. I know that.
Yeah.
Professor.
Good morning, Dr. Jehan.
Good morning.
Professor.
Good morning.
Professor Suresh, your background image is showing inverted.
Inverted?
No. Yeah.
Good morning, Suresh.
And one more thing, sir. Professor Jehan, sir. Professor Jehan, sir.
Workshop.
Yeah. You change.
Good morning.
You have IGC virtual background also in your mail, sir. Kindly.
Yeah, I don't think I have the conference background. You send me the conference background?
So
before
yesterday we have sent a mail.
Oh, I didn't.
With virtual background of IGC 2020. If not, I'll forward again. No problem.
Oh, I didn't realize. Okay.
Yeah, Professor Satya, it is looking fine to me, but is it reverse?
Here it is showing
mirror image.
It is.
Sir, you need to stop mirror image.
Yeah, I think Suresh, it is like that.
I'll change it.
It's a different.
It is looking fine to me. I don't know.
No, it is reverse.
It's a mirror image. That's why it's looking fine to you, probably.
Okay.
Yeah, I'll change that.
Yeah. Sir, you can uncheck the mirrors from virtual background. When you're setting up virtual background, you can uncheck that mirror my image. If you do that, you will be able to have it in the correct position, sir.
Okay, sir. Thank you. I'll do that.
You're welcome, sir.
Morning, Satish.
Okay, let me see. How can
Morning, Professor Jivirao.
How can I change the background? Or edit profile picture? No, change the picture. Yeah.
Good morning, Professor Jivirao, sir.
Let me see. Is it okay?
No, sir.
Why not change?
No, sir. For Suresh, it is still same.
Now it is. It is showing mirror
just have
image
to
to me,
select
so it
virtual
should be okay
background.
for your others.
Good morning, Professor Babu.
Good morning, Professor Mahendra Singh.
Professor Suresh, good morning.
Hello, good morning, sir. How are you?
Professor Jehan, good morning.
Good morning.
Good morning.
Bagli Sahib,
Jivirao sir,
namaskar.
good morning.
Good morning, Professor Mahan Singh. Good morning, Professor
Namaskar,
Sarita.
sir.
Good morning.
Namaskar.
Namaskar, sir. Good morning. It's very cold out there. Yeah, I guess early in the morning. Roorkee, it's
Yeah, sorry.
close to 4 or 5.
Must be around that.
Yeah.
3 degrees last night.
Wow.
Good morning to all of you guys. You should come to Canada. It is minus 11 here now.
I know. And you're managing it shirt.
Oh,
Good morning, Professor Saeed.
yeah, hi.
Hi.
I'm home, so you have the heating. Should not,
Yes.
be a
You know.
problem. Yeah, but if you go out,
It's
then I
impossible,
will
yeah.
have a real problem.
Mm-hmm.
My son is in Toronto, so
Okay.
yeah.
I have a problem change the visual background.
Yeah, you can go ahead. I think it's okay.
I already downloaded, but for some reason I cannot change it.
Professor Gandhi just now called. Sir, he's going to join via Zoom now. He requested me to resend the link. I sent the link to his WhatsApp and he's going to join in a moment, sir.
Can you all hear me? I think there is a problem.
Yeah, I'm hearing.
But is there a problem? What's coming on the screen?
Maybe somebody is sharing the screen.
Oh, maybe. Because over here at the moment, power supply is a little erratic. And if the router goes, we are done for.
Okay.
Professor Vilatkar, good morning.
I'll get my
Manchkan
data
Srinivas
done.
here. Good morning, sir.
Very good morning. Very good morning.
Good morning, GV Rao Saab. Good morning, Sai Vanapalli, sir. Good morning. Good morning, good evening.
Good morning.
Good morning, GV Rao, sir.
Jivirao sir, namaskar. Mahendra Singh here.
Thank you. My bandwidth is very poor actually. How are you, Mahendra?
Fine, sir. Fine.
Fine.
Good morning, Professor G.V. Rao Vilatkar here from Roorkee.
Yeah. How are you, Vilatkar?
Fine.
Nice to see you.
How are you?
Fine, getting along.
Oh, so
It's nice to see you, sir.
yeah, hail and hearty.
Yeah, long time.
Same as you used to be.
Long time, a decade almost.
Hello, Professor Gandhi. Professor Gandhi, you are muted. You have to unmute.
Yeah, very good morning, Professor Rao, Mahendra Singh ji.
Namaskar.
Same to you.
DLS Babu.
Good morning, sir. So nice.
Jihan.
Good morning.
Good morning.
हाँ लैपटॉप अच्छा ठीक है हाँ
Hello, Professor Srinivas.
ठीक है
Sir, good morning, Mahendra Singh ji. Namaskar. Namaskar. कैसे हैं?
Fine, sir.
Sir, Babu sir.
Yeah.
Gandhi sir has joined and Shahrukh ji has also joined. We'll start, sir.
Please, I think chairman and co-chairman are there. And we have about 43.
Yes, sir. I think.
Yeah.
To be on time.
Yeah, one more minute if you wish.
Okay, sir. I'll
9595. Yes.
Okay.
Yeah.
Okay, sir. Yes, sir. Okay, sir. Definitely.
GVR sir, you look same even today. As you were there at IIT Delhi.
Is Anand Pupula on the call on this?
I think yesterday was his lecture. Maybe he wanted to grab 1 more hour of, I don't know, too early for him. I'm not sure. like, so he was there yesterday.
Good morning to everybody, sir.
Hi. Good morning, Abulu. Professor
Good morning,
Abulu.
sir. Very good morning.
Good morning.
Morning,
How are you doing, Professor Abulu? Manchikanti here.
Nice to hear from you, sir. I'm fine. How are you, sir?
I'm good. I'm good.
I'm your student, sir.
Long time.
Yes, sir.
Professor
Nice
Sai,
to hear
it must
from
be
you.
night hours in Canada at the moment.
What time?
Yeah.
Sai, what time?
It is 10:35 here.
Okay.
So 10:30. So you have to, you will be, means late night. You'll be.
Let me tell you, Professor Sai's commitment is very, very high. He just the other day, I know we had that Indo-Canada webinar
Workshop, yeah.
Workshop. He didn't sleep. I think I know for one of the one of them, because he had to be continuous. I know that a couple of days. It was amazing to me.
So we'll start, sir. Babu sir.
Pardon?
Babu sir, we'll start.
Yeah, please. 6:50. Yeah.
Okay. Sir. Good morning. I am Professor Manchikanti Srinivas, and on behalf of organizing committee of IGC 2020, I heartily welcome the chairman, Professor S.R. Gandhi, co-chairman, Mr. Shahrukh Bagli, our esteemed past president and president-elect, past president, our beloved JLS Babu Garu, Professor JLS Babu.
15 days more is there still. Okay.
And yes, and President-elect Samaria sir also, and keynote speakers, delegates, and other esteemed guests to the plenary session 5 of the last day of IGC 2020. Now, without further ado, I take pleasure in introducing Professor S.R. Gandhi to the audience. Professor S.R. Gandhi obtained his BTech Civil Engineering degree from Saurashtra University in 1977, MTech in Soil Mechanics from IIT Madras in 1979, and PhD on the topic, Piles Socketed in Weak Rock from IIT Madras in 1985. He worked as faculty in Ocean Engineering Center at IIT Madras from 1982, and since 1990, he was a faculty member in Geotechnical Engineering Division in the Department of Civil Engineering at IIT Madras till October 2016. Since 24th October 2016, he is director at SVINT Surat. His research areas include design of pile foundations, ground improvement, field instrumentation and monitoring, and design of ash ponds. He has carried out 3 major sponsored research projects funded by Department of Science and Technology on densification of fly ash and reinforced earth embankments. He is an active foundation consultant to various government organizations and private industries for design and construction of foundations. He served as executive member of Indian Geotechnical Society Delhi for 2 terms. He was the organizing chairman in Conference 2006 and Deep Foundations Institute India Chapter Conference 2012 held in IIT Madras. He served as chief editor of Indian Geotechnical Journal during 2005 to 2010 and also served as associate editor of Sadhana Journal. He was institute chair professor of IIT Madras. Welcome, Professor S.R. Gandhi. Next, I take it a great pleasure to introduce Mr. Shahrukh Bagli to the audience. Mr. Shahrukh Bagli is Chief Technology Officer with Strata Geosystems India Private Limited. He graduated from IIT Bombay with a civil engineering degree and continued there for his post-graduation in soil mechanics and foundation engineering. He has been associated with IGS since 1971, and he has been the chairman of Mumbai chapter and is life fellow of the society. He is also fellow of Institution of Engineers India. He has more than 47 years of experience in geotechnical and civil engineering, of which past 9 years has been devoted to geosynthetics. At Strata Geosystems, he has brought innovative applications of geogrids and geocells to the forefront, including reinforced soil vertical containments for hazardous waste landfills, check dams from geocells, and the use of two-layer elastic theory for the analysis of load-bearing systems incorporating geocells. He is a member of committees for flexible pavements and bridge foundations of the Indian Roads Congress, Bureau of Indian Standards Technical Textiles Committees, Executive Committee of IGRIP, an initiative of IIT Gandhinagar, Board of Studies of Mukesh Patel School of Technology Management and Engineering of NMIMS Autonomous University. Mr. Shahrukh has been honored with many awards, couple of these. Lifetime Achievement Award for 2015-16 of the IGS Delhi chapter. The Mancherji Adalji Joshi Memorial Trust for Outstanding Contribution Award 2017 for Excellence in Geosynthetics and Environmental Preservation. Appreciation Award for contributions to the Indian chapter of the International Geosynthetic Society. Welcome, Mr. Bagli. Now, I request the chairman and the co-chairman to conduct the session. Thank you.
A very good morning to all. It's a really pleasure to participate in the Indian Geotechnical Conference 2020. I am sorry I could not participate last 2 days because we were busy with our 18th convocation, which was held yesterday, and I missed most of the events. Professor GLS Babu, immediate past president, the present president, Professor N.K. Samadhya, Professor J.T. Sahu, my co-chairman, Dr. Sarok Bagliji, the eminent speakers we have in this plenary session 5. We have Professor G. Han from University of Kansas. We have Professor M.N. Viladkar from IIT Roorkee. And we have Professor Kumar Pichumani, who is with AECOM India Private Limited, earlier with L&T, and he was also faculty at IIT Madras. We have one more lecture today from Professor D.V. Ramana from IIT Delhi. And since we have a limited time of 1 hour 45 minutes, of which we will be taking already taken about 20 minutes for this preliminary introduction. So I suggest that these whatever 85 minutes or 90 minutes we have, each speaker restricts their talk to about 20 minutes. And may I request Dr. Bagli to have the time management and give a warning or instruction at the required place. Dr. Bagli, is it okay with you?
Sure. And since you're putting a time limit of 20 minutes, at 15th minute, I'll just warn the speaker.
Yeah, right. So I think all the 4 topics are of interest, and all the colleagues, speakers have a vast experience in the subject. And I'm sure that the participants will have a very interesting lectures to follow. I will just start with the first lecture. I request before I request Professor G. Han from Kansas University, US. I have pleasure in reading out his, giving his brief biodata. He is Professor of Geotechnical Engineering in Civil Environment and Architectural Engineering Department at University of Kansas. He received his PhD degree in Civil Engineering from the Georgia Institute of Technology in 1997, Professor Han is the sole author of the book titled Principles and Practices of Ground Improvement and has published more than 400 peer-reviewed journal and conference papers. Professor Han is an ASC Geo Institute Board Governor, a council member of the International Geosynthetic Society, the current chair of ASC Geo Institute of Soil Improvement Committee, and the current chair of TRB Transport Earthwork Committee. He served as an associate editor of the ASC Journal of Geotechnical and Geoenvironmental Engineering and ASC Journal of Material in Civil Engineering. He is editor of Transportation Research Record. Professor Han has been invited to give more than 200 keynote invited lectures and short courses around the world, including the State of Practice lecture at 21st Annual George F. Sowera Symposium in Atlanta, Georgia. In 18th, during the 18th UK IGS lecture in London, 2018, and keynote lecture at the Geo Americas International Conference 2020. He has received numerous awards from professions, including but not limited to the 2011 Samset Prakash Prize for Excellent Practice of Geotechnical Engineering. The 2014 the International Geosynthetic Society Award, the 2017 ASC Martinez Cap Foundation Engineering Award, and 2018 ASC Kansas City's Section Engineer for the Year Award. So I am sure that with so much of accomplishment, you are all eagerly waiting to hear from Professor Han, and I request Professor Ji Han to deliver his lecture. Professor Ji Han, please.
Good morning. Thank you very much, Chair, for your kind introduction. It's my great honor to give this lecture at your conference. I also like to thank Professor Randy and Professor Babu, and I saw Professor Rao on the screen, and he sent me a message as well. I really appreciate it. I have a lot of friends in India, and I also like to thank Professor Anand Pupala, one of the best friends in US, and we have worked together so much. I prepared the presentation for 35 minutes, but I will try to finish within 20 minutes. My topic will be on the limit equilibrium analysis and design of geosynthetic reinforced field walls under special conditions. So here basically is the outline of my presentation. I'll start with the introduction, give you some background. Then we'll talk about the limit equilibrium, and then I will focus on the unified design method for field walls and the slope under special conditions. At the end, a few concluding remarks. Then I'll start share with you the Asian reinforced field wall built in China about 1,000 years ago. But this is basically built with natural material and use like a tree branch, use the grass, basically place layer by layer. As you can see here, those are the layers. And between that, basically is the field material. Okay, but back 1,000 years ago, Chinese people already know how to build a retaining wall with reinforced technology. Now, the modern reinforced field wall with steel reinforcement, typically we refer back to 1960 by the French architecture engineer called Henri Van Damme. And he developed a technology that basically uses steel reinforcement. As you can see, this is reinforcement layer by layer and with field material between. And the different from the Asian technology, he added the facing here, okay, to protect from rain erosion, wind erosion. But this is the one of the earliest retaining wall built with this technology. As you can see, this is facing. But the problem after you add the facing, where the water can go out, if you cannot discharge the water, will create a poor water pressure behind the retaining wall that will destabilize the retaining wall. This is why it's important. Behind the retaining wall, you need to have drainage layers. Okay, those are stone layer, basically drainage layer, discharge the water, reduce the poor pressure. But we also can use geosynthetic. That's the one I want to focus on today. The picture show you here, basically with the uniaxial geogrid, and also place layer by layer with backfill material between. And this is using a modular block technology. You also can use a panel system, connect with geosynthetic or with steel reinforcement. But how do we design a retaining wall? Typically, we treat this as a rigid block, and then we say, there's external stability with earth pressure. And then we have a lateral sliding, overturning, bearing capacity. We also need the design for internal stability. Basically, this is a failure plan. Typically, we use a Rankine or Coulomb failure plan. And then in front of the failure plan, we call the active zone. And this is a basic passive zone or stable zone. And we also have earth pressure, basically transfer the load to the reinforcement. And the reinforcement will carry the load, basically stabilize this wedge by tension. But typically, we require the tensile strength of geosynthetic and also require the anchorage from the geosynthetic. Now, at the front, also, we need to have a connection to make sure everything stable. Okay, but that is a basic design used called lateral earth pressure distribution method. Now, if we look the slope stability is a Bishop or Spencer method. Let me start with the Bishop method. For unreinforced case, you probably know use a circular slip surface, and then we basically calculate the fact safety based on the resistance moment divided by driver moment, right? How do we consider reinforced slope? We have a reinforcement here, then we have a tensile resistance. Then we add that into the calculation. This is the soil moment resistance, and this is tension from geosynthetic. Then multiplied by the arm, they get the basic resistance from geosynthetics. Okay, but we also can use the Spencer method. We can get like a wedge failure plan instead of circular failure plan. I will mention both methods in my presentation. Okay, now let me talk a little bit about analysis versus design. A lot of time we consider they are same, but really there's a little bit different. The analysis typically say based on the refer to the calculation of performance index for stability purpose. Typically we talk about fact safety. But based on the assume the non-layout tensile strength of geosynthetics. For example, like this one. We typically have a slope. We know the slope height, the slope angle. Then when we place the geosynthetic, what kind of length, spacing, tensile strength. Then we run slope stability to calculate the fact safety. Okay, that is the approach called analysis. We can have a different length, we can have a different spacing, we can have different strengths. Really, you can basically try the error process to reach the fact safety. You can have a multiple different answers. Okay, if you change your length, change the spacing, you can get another answer. Now, for design, it's a little bit different. Design is referred to calculation performed to determine the layout or tensile strength of reinforcement to meet the performance requirement. For this case, I use a retaining wall. Typically, we know what the requirement for retaining wall, fact safety, internal, external, and tensile failure, those kind of things. A lot of time we know the spacing based on the facing block of panels. We know the spacing, we know the required fact safety. Based on earth pressure, we can determine what the tensile strength is and what the length. Okay, step by step, there's only one answer. There's no multiple answer like slope stability. But there are two different methods we use in our practice. Okay, now in most countries' code, how to divide the retaining wall and the slope based on the angle. If this angle is greater than 70 degrees, that's a retaining wall. If this angle less than 70 degrees, this is slope. However, the two methods used for those structure design very different. As I mentioned earlier on, this uses lateral earth pressure method. Basically, this distribution. Based on this distribution, as you know, the lower layer carry higher force because you have a triangular distribution, and this one will have a lower force. Now, if you use slope stability, if you have enough length of anchorage, all the lengths will have the same tensile stress requirement based on the fact safety. Okay. Now, people may argue the limit, the lateral earth pressure method also limit equilibrium. Just try to differentiate between those two methods. I call this a lateral earth pressure method. This is a limit equilibrium method, okay, for slope stability. Now the problem is, how does the earth structure know when it becomes a wall or slope? But this is basically artificially divided by people, not by earth structure itself. Okay, now this is the one earth structure actually in India, close Himalayas. And some of you may recognize this one. And as you can see here, this is very steep walls and then getting flat with slope. I'll show you the cross section. This is for the airport, basic scheme airport, and the runway. And this is basically retaining structure here. Okay, this one also subject earthquake 6.8 magnitude performed very well. If I show you the cross section, you see that the change in the angle here. The bottom, if you base on the 70 degree, this is wall. On the top, this is the slope. How do we design? Which method we should use? Is a wall, lateral pressure method, or slope stability method? Okay, that would be challenge. Okay. Now, there was some research done by others, like Allen, Bethard. They measure quite a lot of retaining wall, basically instrument that measure the tension in the geosynthetics. And they also monitor the slope. This is a greater than 85 degrees, this is less than 70 degrees. Actually, the distribution of tension with that, if you compare those, look very similar. There's not much different. Now, magnitude-wise, slope maybe require less tension. Okay? But here basically show they have a very similar tension distribution. But ASHTO this year, 2020, this is why my talk is very, very new. Actually, now suggests 4 different design methods for retaining wall reinforced slope. This is called coherent gravity wall method for steel reinforcement, stiffness method for geosynthetics, simplified method. Basically, this is a lateral earth pressure method for steel and the geosynthetic. The last one, limit equilibrium analysis, geosynthetic reinforcement. But this method also can be used for compound failure. Okay, but that is the one I want to focus on today. We have done quite a lot of research on this topic. Now this method has been included in the ASHTO new design specification. Okay, Professor Yang did some comparison with different methods. As I just mentioned, that this is basically a lateral earth pressure method, ranking or Coulomb, and this is the limit equilibrium method, and this is the finite element method. This is the K stiffening method. But this is a measured tension from geosynthetics. Actually, limit equilibrium method come out pretty close to the finite element to the measured data. Okay, a little bit overestimate from here. The limit equilibrium method has performed very well. This is for retaining wall situation. Now, today I want to talk about 4 different special conditions. One called tier walls. Basically, there's a one low wall, there's a steps, and another wall you can have more steps. Okay, and another case dealing with back-to-back walls. You have this side wall, this side wall. This is mostly used for bridge abutment. And another case dealing with called limit space. This one may be like bedrock. We build the narrow geosynthetic retaining wall in front. And then this is like a secondary reinforcement. You have a primary reinforcement with a stronger, longer one, and then a shorter one. Okay, basically try to improve the connection between the facing and the reinforcement. How do we design for those kind of situations? Okay, that is challenging. The typical retaining wall design method cannot directly apply to this. Okay, now before we talk about those methods, let me show you the relationship between wall and slope. I call it progressive failure. Let's start with this vertical one. Let's say if we apply the load at the rest, okay? If at the rest means there's no movement, right? This earth structure will be stable. How about if I reduce the load less than P naught or K naught, and the soil start to move, and typically it will move gradually from the facing in and in, and there's 0.3 H. For some of you designed for retaining wall, you are made familiar with this 0.3 H. This is typically used for steel reinforcement design, because steel reinforcement is stiff and they only allow small deformation. This is why the failure plan will develop around this surface. Now, if we keep reduce the load up to active pressure, then this basically ranking failure plan will develop 45 degree plus 2. But this is the failure plan we use for geosecondary reinforcement because it's flexible, allow more deformation. Now, how about if I keep reduce the load less than kPa? Of course, this will not be stable because Pa is the minimum load to maintain the stability. That this wedge will slide down. Okay. How about after slide down, then even though you don't have a force to push this one, this wedge is still not stable because this angle is greater than friction angle of soil. This continues slide down and up to this point. Until the slope angle is equal or less than friction angle, that becomes stable. As you can see here, this is really the progressive process from a wall gradually going to steep slope and going to flat slope. They are really the same earth structure, just at different angles. Okay, this uses the Libby equilibrium method for the wall. This is the Libby equilibrium method for slope. Okay, now let me show you whether this is real in the physical real situation. This is the wall facing here. Okay, this is the line 0.3 h happened, and then this is the line basically 45 degree plus by 2. For real retaining wall structure happen like this. Gradually, as you see, the failure plan gradually. If you allow the movement, eventually the whole thing will just keep going down. Okay. Okay. But actually, we already have used those two together. If you use the numerical method, for numerical method, typically we don't distinguish between wall and slope. There's one technology called shear stress reduction techniques, right? You divide the cohesion by fact safety, divide the friction angle by fact safety, and then you plug it into this numerical method. And then you run the stability until the point reach your limit equilibrium. The fact safety is the corresponding fact safety, minimum fact safety. So it doesn't matter this wall or slope. We have been doing that already. The numerical method is applicable to both wall and slope. It is a unified method. We don't need to distinguish them. Okay. I've been working with Professor Dovlin Shishky at the University of Delaware, back like now it's 16 years ago. We start with the vertical wall and we use different method. We use the Bishop method to dealing with vertical wall and the ranking numerical method. Now, numerical method ranking, actually the failure plan very close. Now, all those cases, the fact safety equal to 1 by the limit equilibrium. Now, the Bishop method is a little bit away from this surface. But then if we use Spencer method, then actually it's pretty close because the Bishop method is always circle. You cannot get exact failure plan. If we dealing with slope like 70 degree, actually they match pretty well. Bishop method and the numerical method. Okay. The numerical method, limit equilibrium method had lead to similar results. Now, how about tear wall? That's a special condition we talk about. Now, as I said, really it's difficult to use the ladder earth pressure method to design tear walls, but Federal Highway modified the method, okay? Consider 3 different conditions. Let's say if the offset is very small, they treat it as a vertical wall, just one wall. If the offset is larger than the failure plan, they basically say they are independent walls. Now, in between, they have some way to handle, basically linear interpretation between that. But this is basically based on the concept, okay? Geometry derived whether this is real or not. But we checked out that use numerical method and the Bishop method, okay? From this case, as you can see, for the 3 tiers, numerical method, the Bishop method show exact failure plan. It's not exact same as that. Let me show you more about the results. But here, basically based on the Federal Highway Design Guideline, okay? But this is like a full one wall, and this is like an independent wall, and then between they're linear. But based on the case, we had 2 different soil. One with a low shear friction angle. I'm sorry, this is 1 tier, 2 tier, 3 tiers. Actually, we find out at 0.8 h, actually they become independent. And also require strength lower than the Federal Highway Design method. In other words, the Federal Highway method based on the concept is not the exact right. Overestimate interaction distance and also require tensile strength situation. Okay.
Professor, 5 minutes, please.
Oh, okay.
I'm sorry. Before I get carried away, I think I should warn you.
Yeah. I that's fine. I prepared for 35 minutes. This way.
Okay, fine. Okay. Carry on, please.
Okay. But this is a back-to-back awards, and also Federal Highway based on the concept they divide into 3 different conditions. If this is space is small, that basically there's no external force. If the space is getting larger, and they will be independent. Okay. But we did the analysis as well with numerical limit equilibrium method, and we find out actually the numerical method, limit equilibrium method, especially with Spencer method, they match pretty well. Okay, and even you don't have the space in between, you still have an external force. Okay, now for this case, the limit equilibrium method does not do very well as a numerical method because the limit equilibrium method only can analyze one side of failure. But in reality, you have to have 2 sides. But here basically show you some difference. Federal High, basically the interaction very small, but in reality, their interactions are much larger, okay? For both soil. I just move fast down here. Now, how about a limit space situation? And this is a limit space. Basically, if you have a bedrock and then in front there's reinforced fields, and we use the limit equilibrium method or numerical method to back calculate the force required to maintain the stability, and it match pretty well. Now, one thing I want to point out, that people may think that this is reinforced very narrow field material. You may expect the earth pressure very small. Actually, it's not. This is like even 1/10 of the field of the wall height. You still have like 50%. This is why for this retaining wall, they designed underestimate, okay, the force. Okay, this is dealing with the secondary reinforcement, and there's no design method, but this is a primary reinforcement. This is a secondary reinforcement situation. Okay, how do we design? No design method. Okay, now let me move on to the unified limit equilibrium method. The concept is very simple, just similar like a Bishop method or wedge. But if we want to maintain the stability of this wedge, the normal shear stress, then we need the tension in the geosynthetics, right? And then we have a formula to calculate force, and we assume effect safety equal to 1. And then if you have a more than 1 requirement, you divide by effect safety, and then we can check each failure plan. Then we can calculate what the required tension at the different failure plan. But that's for 1 layer. How about 2 layers? For 2 layers, we can calculate the same force and divide by each layers. Remember, for limit equilibrium, we assume the 2 reinforcement carry the same force. Then for this case, okay, same thing. I go fast. But you have 2 layers. You see, like this, okay? Now, then we design, of course, we need to satisfy 1 layer and 2 layers. Let's start with the 1 layer again, then 2 layers we have, then we plus together like this, okay? Now, we need to make some adjustment here in order to satisfy both layers, because this one is for first layers, this one's for second layers. Because the first layer already carry more load, the second layer, you don't need to carry that much load. But this is for second layer, you need to carry extra load. Eventually, you get this kind of requirement, okay? Okay, but this is called top-down design method procedure, continue from top to all the layer analyze. But now let's say based on the analysis, we need to require this tension. In order to meet the requirement, we need to make sure that the front, the back meet the requirement. From front, your reinforcement should be longer enough to prevent the pull-off. In the front, how do we do that? But we have to have a connection force. This is how we determine the connection force. And at the top, we need enough tensile force. But eventually, we get this kind of design joint, okay? In the front, the connection force, reinforced length, then total stress, okay? But this is the basic requirement to design for retaining wall. Now, the one I show you with a planar failure plan, but you can do circular, you can do log spiral, but it goes fast. Show you some example. This is the one with a vertical wall. You see the required tension in the GS there with the limit equilibrium. Now, one important thing for this method, we can determine what the connection force requirement, 40%. H2 always assume 100% because we cannot, based on all the method, retaining wall method, we cannot calculate. But only assume 100%. Okay. Now this is the case basically very similar to the retaining wall slope for the airport in India. Bottom of the wall, top slope, we can calculate based on this method, right? And this is the case dealing with secondary reinforcement. You see that the small reinforcement we can calculate tension, primary reinforcement we also can calculate tension. I'm almost done. Okay, and also you can check with the footings. If you have a footing on the top, this is without footing, this is with footing. And as you can see, without footing is 10 kilonewton per meter for each layers. With footing is 15 kilonewton per meter because you need to carry load. But this is basically the summary of this method. It is a top-down design method. But use a modified field friction angle, basically if friction divided by fact safety, and then determine minimal required tensile force to satisfy limit equilibrium, and then check the real pull capacity ensures the reinforced length, check the front pull to determine connection strength, and then select GSN that meet the strength requirement. Okay, but this is a unified method for slope in the walls to address internal, local, and global stability. Can analyze from almost all the situation. But if you are interested in this method, there's a Federal Highway publication, okay, published by Professor Dovniczewski. You can take a look at that. With that, I reached the conclusion remark. I'm sorry, I ran very fast. The GSN reinforced field wall slope, including those under special conditions with what we talked about, have been successfully used for many projects. The field wall slope have been artificially divided by a slope angle designed with different method, which result different reinforcement requirement for current situation. The field wall slope actually have the same failure mechanism, which can describe by the limit equilibrium concept. But the unified limit equilibrium method can be used to analyze the stability of GSM reinforced field wall and slope under different conditions without artificial division and modification. Thank you very much.
That was great, sir. You finished well on time. Thank you. And you covered everything. Yes, there are many questions, I'm sure. I will take that up later.
Okay.
Professor Gandhi.
Professor Bagley, would you like to give some quick summary of?
Yeah, sure. Why not? In fact, that would be great. In fact, Professor Han, I think you've really put everything in a nutshell in just a matter of hardly 20, 25 minutes. I really admire you, and I'm sure even Professor G.V. Rao would appreciate it, because together we are working on a code of practice in India for this very same topic.
Okay.
Professor Han, you've very well brought out the history of reinforced soil, including the Great Wall of China. I would even like to add the walls of Babylon also. Well, in any case, it will be a little biased from my side. Then you have really brought out the aspect of the difference between analysis and design. Yes, that was really wonderful. The difference between a wall and a slope, and how numerical analysis can unify the definition of wall and slope. You need not worry whether you've got a wall or a slope in your hand. And then, of course, the importance of the secondary reinforcement also. Very well brought out pictorially. Thank you, Professor Han. We really appreciate it. Thank you.
Thank you for your summary. Very nice. Thank you. Thank you for the opportunity. Okay. Let me stop sharing here.
Thank you, Professor Han, again.
Sir, can I seek one clarification? Hello?
Okay. Professor Rao.
What is the main difference between the latest edition of Astro and the other one, previous ones?
You mean Astro and the Federal Highway?
Yeah. The latest one.
Latest one, Astro, basically now include the 4 different methods, include the limit equilibrium method. Used to be, we don't have that method. We use a simplified method, basically the ladder earth pressure method. But that's a different, the Federal Highway and the Astro is different. Yeah. Astro is like a standard. Federal Highway is a government document. It's different. Yeah. I think Professor Rao may have a...
Thank you. You have covered everything like what we will request you to speak for. Okay. So next time, I think we'll invite you to give a much longer presentation so that we understand in depth what exactly is your ideas. Thank you. Thank you very much. We enjoyed the presentation.
I can send you papers. Meetings also.
Yeah.
Hello?
We could invite him for the code of practice meetings also.
Yeah, I think we should do that. We should do that.
Okay. Okay. Thank you.
Thank you. Thank you.
Okay. Shall we go ahead? Viladkar, and he's going to talk to us about some aspects of seismic soil structure interaction of life.
Are you able to hear me, Professor Gandhi?
Professor Gandhi is not audible.
Yeah, he's not audible.
His research interest includes the area of static and dynamic soil structure interaction, earthquake geotechnical
Dr. Gandhi is not audible.
Sir, Bagli sir, we'll request Professor Viladkar to make his presentation. Maybe at the end we can.
Okay, we can have his this thing, but I can assure you that Viladkar has got a very illustrious career behind him, and we are really proud to have him over here. So, Professor Viladkar, could you please proceed? And we'll again have to constrain you. I'll give you even 2 minutes more from according to my watch. Okay, go ahead, please.
I will try to share this screen, okay?
Yeah, please.
Link 3.
Is that okay? Mr.
Yes, sir. Presentation.
Hi, you are able to see in my screen, right?
Yes, we can, but go in the presentation mode, please.
Okay, yeah. So I will start now.
Yes.
Okay. Very good morning, Professor Gandhi, Mr. Bagli, IGS President, Professor Shiv Kumar Babu, President-elect Professor Madhya, Conference Chair, Professor Satyanarayan Reddy, all other senior professors online, and all the distinguished delegates who are attending this particular session. At the outset, let me thank the organizers, particularly the Indian Geotechnical Society and the conference chair, Professor Reddy, for extending to me this particular invitation to deliver this keynote lecture in this conference. I'm going to speak primarily on some aspects of seismic soil structure interaction of lifeline structures. Now, when we talk about lifeline structures, these are somewhat different from the conventional structures like buildings or dams. I'm basically talking about tunnels in the metropolitan areas which are used for the mass rapid transit system, the various water conductor systems in the hydropower projects, roadway and railway tunnels in hill areas. We have in India, for example, Jammu, Udhampur, Srinagar railway line. Similarly, the presently under construction Rishikesh Karnaprayag railway line, the proposed Bilaspur Manali Leh railway line project, and you are all aware recently the Prime Minister inaugurated the Atal Tunnel, which is basically a transportation tunnel or a highway tunnel. Similarly, we have the Jojila Pass Tunnel. But then apart from these tunnels for different purposes, we also have the gas and water transportation pipelines. And similarly, the bridges which cross the valleys in hilly regions. Now, these are the structures actually which are very long in comparison to their cross-sectional dimensions. You have got the pipelines which run over a length of a few hundred kilometers. You have metro underground systems which run over a length of few kilometers. And you have the railway line projects in hill areas which run to a length of about a few hundred kilometers. Underground structures were earlier considered as less vulnerable to earthquakes as compared to above ground structures like tall buildings, dams, which are built on the ground surface. However, the 1995 Kobe earthquake, or let us say the 1999 Chaicha earthquake in Taiwan, these have clearly demonstrated that several underground structures, they can suffer severe damages depending upon the various parameters at a site. And therefore, the underground structures cannot be treated as completely exempt to the effects of ground shaking. In India, there is a growing need at present to enlarge the infrastructure, especially in the hill areas, or we have got mass rapid transit systems, their networks in the metropolitan cities, all-weather connectivity in hill areas, particularly the northern and the northeastern states, and also connectivity in strategically very important areas from the defense point of view. So because of these, there is a renewed interest for studying the vulnerability of the lifeline structures to seismic loading. A large earthquake, in fact, causes direct damages in the form of excessive settlements, tilting, or severe cracking of structures, and sometimes even the collapse of structures. Whereas there are also the indirect damages in the form of fires, explosions, which result into potential loss of human lives and damage to the infrastructures, damage to the adjacent infrastructures. All this causes severe economic losses, especially in view of the time that is required to restore the functionality of various infrastructures. It is therefore essential to reduce the possible associated damages and also the consequent effects of these damages. Most of the tunnels, so there are some important observations on basis of the earlier failures which have taken place in case of such lifeline structures. Most of the damaged tunnels were located in the vicinity of the causative faults, causative geological faults. The ground motion, which is close to the active geological fault, may be characterized by strong, coherent, narrowband, long-period pulses. And this ground motion is severely affected by the rupture mechanism along the fault plane, the direction of rupture propagation in relation to the particular site in question or a project in question. And there can be also permanent ground displacements which result from the slip along the major geological fault planes. On basis of the study of damage to about 71 tunnels excavated in rocks due to earthquake shaking, and their comparison of the behavior with the estimated values of peak ground acceleration and peak ground velocity, suggests that collapse of the tunnels due to ground shaking occurs only under extreme conditions. It was found that damage did not occur so long as the PGA values are less than about 0.2 G or the PGV values are less than about 0.2 meter per second. Minor to moderate damages were observed when the PGA values approached about 0.5 G, whereas moderate to heavy damage was experienced when the PGA values exceeded a value of 0.5 G. And the tunnel collapse occurred only when it was associated with the movement of the intersecting geological fault. The strong ground shaking actually can cause also the liquefaction in saturated sands, and with consequences like sinking of the structures or shifting of the ground surrounding the tunnels, which leads to collapse of multiple underground structures. And the famous case is that of the collapse of a subway station during the 1995 Kobe earthquake in Japan. This liquefaction is also responsible for causing the landslides, consequently the damage to highway facilities. Landslides also generate secondary impacts, and there occurs a rupture of water and gas supply pipelines, and more importantly, the electrical transmission lines, which cause actually dramatic explosions and fires. This was what exactly happened during the 1994 Northridge earthquake in USA, when the ruptures of the gas pipelines occurred. The net outcome of this is that seismic analysis of underground structures is a complex task, as it involves interaction of several disciplines, including structural geology, the seismotectonics, engineering seismology, soil and rock dynamics, and also structural dynamics. And this area has remained by far somewhat neglected, primarily because of the conventional notion that the underground structures are not sensitive to earthquakes. As a consequence, design engineers often omit the evaluation of structural performance of tunnels and such lifeline structures under seismic conditions at the design stage. Let me just bring out some of the design considerations which should be followed while carrying out initial designs. The first one is that seismic response of tunnels and underground structures is considerably different from that of above ground facilities, because the overall mass of the structure is usually very small as compared to the mass of the surrounding soil or rock mass. The overall confinement of the underground structure by the surrounding soil or rock mass provides high level of radiation damping, and as a result, seismic response of underground structures is basically controlled by the induced ground deformations rather than the inertial characteristics of the structure itself. In case of underground projects, particularly in the urban areas, design and construction is more demanding because of the interaction between the underground project and the overlying pre-existing structures through their foundations. And these are the issues where the people go to the court of law to seek the compensation in case the above ground structure is damaged or affected by the underground activity. The interaction of these underground, lifeline structures is basically a function of the depth of overburden or the thickness of the overburden above the bedrock, and the nature of topography. Particularly in hill areas, the topography is very uneven. This results into what we call as a seismic amplification. And this seismic amplification was the cause of damage to bridges during the 1995 Kobe earthquake. And it was also the cause for damage to the underground tunnels and buried gas pipelines during the 1999 Chai earthquake in Taiwan. So therefore, the selection of realistic ground motion is very important from the seismic analysis and design point of view of these lifeline structures. The time history of earthquake has to match the expected earthquake in that particular zone or at the particular project site in question, and hence there is a need for what we call as the response spectra compatible time history. I'm going to take very briefly the case of Delhi Metro underground tunnels, particularly constructed in the early phase 1. And this is a typical cross-section of the DMRC tunnel in Delhi. Delhi lies, this is the geological map of Delhi city. You have got the Yamuna river running or flowing in the north-south direction. And you have got basically either the younger alluvial deposits or the sandy silt deposits below the ground surface in Delhi city. And in some portions in the north-south direction, you have got also the quartzitic ridges. The tunnel diameter is about 6.26 meters, and the depth of overburden above the crown of the tunnel is about 16 or 17 meters. The tunnels are provided with precast RC liners, and you know very well that Delhi lies in a seismic zone 4 as per the seismic map. The modulus of the soil mass varies from ground surface to with a value of about 7.5 megapascals to about 50 megapascals at a depth of about 60 to 70 meters below the ground surface. We tried to study the behavior or response of these tunnels subjected to Chamoli earthquake. I will explain as to why we consider Chamoli earthquake only. This plot shows the horizontal acceleration time history with a PGA value of about 3.667 meter per second square. That's the vertical acceleration time history with a PGA value of 1.557 meter per second square. This plot shows the Fourier spectra of the Chamoli earthquake of 1999 with a predominant frequency of about 1.67 hertz corresponding to the horizontal component and with a predominant frequency of about 11 hertz corresponding to the vertical component of the earthquake. So in order to develop the response spectra compatible time history, we tried to generate the target response spectra on basis of the IS code 1893. This was generated both for the maximum considered earthquake as well as the design basis earthquake for different values of damping ratios of Delhi silt corresponding to about 5%, 10%, and 15%. That's the typical response spectra for the maximum considered earthquake for zone 4 of Delhi for different values of damping, including 5%, 10%, and 15%. So I find that corresponding to the minimum value of damping, I've got a maximum PGA, which is of the order of about 0.6. This is the response spectra corresponding to the design basis earthquake, and I find that the magnitude of SA upon G is roughly half of that for the MCE. Then we have to select adequate time history. In fact, in Delhi, there is no record of a major earthquake. So the nearest earthquakes were 1991 Uttarakashi earthquake with a magnitude of 7.0 and a PGA value of 2.37 meter per second square. And the 1999 Chamoli earthquake with a magnitude of 6.8, but a PGA value which is much higher than the PGA value for Uttarakashi earthquake. This is 3.53 meter per second square. Now this Chamoli and Uttarakashi, these are the places which lie in zone 5 of the seismic map, whereas Delhi city lies in zone 4, and therefore there was a need to generate artificial time history for Delhi city. So taking a magnitude of acceleration from the target spectra and a phase from the input history, response spectra compatible time histories were generated using these three software packages, SPEC3 and WaveGen. These are the two packages which were developed in IIT Roorkee. And the third one is Seismomatch, which was developed by Hancock and his team in the year 2006. And the typical observation is that the trend of the artificial time history generated by Seismomatch software developed by Hancock is quite similar to the actual earthquake, except for a difference in the value of PGA. So this is a typical response spectra compatible time history obtained by the Seismomatch software corresponding to 5, 10, and 15% of damping ratio. So when I try to see the effect, I find that both for MCE as well as DBE, the PGA values go on increasing as the damping ratio goes on reducing. When I study the horizontal displacements of the soil tunnel system, I find that the Seismomatch software gives me a value of about 200 mm near the ground surface and very close to it at other points around the periphery of the tunnel, including the crown, the invert, and the springing points. And DBE also, the design basis earthquake, also gives me the same range of horizontal displacements. As far as the vertical displacements are concerned, all the three software packages or all the three response spectra compatible time histories for MCE and DBE give values which are very close to each other at all the critical points, including the periphery of the tunnel and the ground surface.
Professor, only 5 minutes left.
Okay. So The most important thing that I have observed is that the presence of tunnels below the ground surface or excavation of tunnels modifies the response at the ground surface, and therefore the structures lying on the ground surface or constructed on the ground surface, they are significantly affected. We try to consider the three-dimensional analysis also, especially because you all know that these lifeline structures like highways or underground highway tunnels or railway tunnels underground or the gas supply pipelines, all these are the facilities which extend over length of kilometers. And you can have a significant change in the geology over length of few hundred kilometers. You may have many geological discontinuities which can come into play, and therefore it is essential to study the 3D response of these underground structures, particularly the longitudinal direction or the actual direction of tunnels. So this is the typical response vector compatible time history corresponding to transverse component. That's the vertical component, and that's the response vector for the longitudinal direction. So when we try to consider these response spectra in all the three directions, I find that maximum horizontal displacements are affected essentially by the transverse component of the earthquake, whereas maximum vertical displacements are affected both by the vertical component as well as the longitudinal component of the time history. And the longitudinal displacements along the axis of the tunnels, they are affected both by, again, longitudinal component as well as by the vertical component, especially at the ground surface. Now, so what I find is that 3D analysis actually gives a higher value of horizontal, vertical, and longitudinal displacements in the soil tunnel system corresponding to all the three components. And 3D analysis in general gives a much subdued response as compared to any 2D analysis. Then we try to consider a significant parameter in the form of liquefaction, because you are involved with a geological strata which runs over a length of few hundred kilometers. It is essential to consider the aspect of liquefaction. Earlier studies have shown that safety of underground lifeline structure improves against liquefaction damage with increase in depth of overburden. Liquefaction leads to mobilization of high uplift in the soil tunnel system. Liquefaction also leads to increase of forces in the tunnels, and the acceleration response at different depths was found to attenuate significantly due to occurrence of liquefaction. We try to carry out numerical modeling of this liquefaction phenomena, particularly for these Delhi metro tunnels, and using what we call as the UVC model for the constitutive relationships. In terms of pore pressure ratio, which is basically in terms of the effective mean stresses, and the state variable R sub U, which is in terms of the effective vertical stresses. When I try to compare the pore pressure ratios which are developed or mobilized, I find that they are less than 1 corresponding to the horizontal and the vertical components. But when I go to the response corresponding to the longitudinal component, I find that both the pore pressure ratio and the state variable R sub U, they exceed the value of unity, indicating that longitudinal component of earthquake can cause liquefaction and therefore damage to the underground structures. When I study the effect of the depth of the water table, of course, as the water table rises, there is a tendency of or possibility of liquefaction taking place. And particularly in case of Delhi metro tunnels, when the water table rises from a depth of about 10 meters towards the ground surface, then there is a possibility of liquefaction. Existing level of water table is about 17 meters below the ground surface. When I study the effect of PGA values, I find that up to 4 meters per second square, the tunnels are safe. But if the PGA value goes beyond 4.0, there is a possibility of the occurrence of liquefaction. So my final recommendations as far as analysis and design of lifeline structures is concerned, the first one is that design engineers should seriously undertake at the design stage only evaluation of structures in clustered areas and in metropolitan cities where the underground activity is going on, particularly against earthquake. Secondly, the road and rail transportation tunnels in hill areas and other infrastructures like electrical transmission lines, etc., should not be aligned in the vicinity of the geological causative faults. This aspect can be taken care of right at the planning stage only. The third recommendation is that lifeline facilities with lesser depth of overburden are more prone to damage. As a consequence, construction of tunnels modifies the response at the ground surface, and hence in urban areas, especially in metropolitan cities, response of the above ground structures due to construction of underground projects needs to be thoroughly investigated. Otherwise, it gives rise to problems of litigation. The fourth recommendation is the effect of local site conditions, particularly the thickness of the soil layer above the bedrock and the uneven topography. This must be taken into account during the design of structures like bridge abutments in hill areas, and the alignment of the transmission line towers, alignment of highways, or alignment of railway tunnels in hill areas. It is also essential to generate the response spectra compatible time histories specific to particular zone or a particular site in question. In case of lifeline structures,
your time is up.
Just 1 minute only. It is essential to carry out to understand the 3D response, particularly because the longitudinal component of the earthquake can cause either damage to the below ground structure, or it can bring about liquefaction and consequent damage to the lifeline structure. The liquefaction in hill areas can also give rise to landslides and therefore damage the highway facilities. It generates secondary impacts and may cause rupture of water or gas supply pipelines and uprooting of the electrical transmission lines. Thank you so much, Mr. Chair and Co-Chair. Thank you for giving me enough time to finish my presentation. Thank you so much.
Thank you, Professor. You didn't exceed much.
Yeah.
Okay. Professor Gandhi, please.
Yes. Thank you, Professor Viladkar, for the very interesting talk. You have covered the stability of the underground tunnels, effect of liquefaction, and given a message that sometimes the horizontal acceleration could be more serious to the underground utilities as well as for the hill slopes.
Particularly in the direction, yeah.
Right. Now, while I was reading your biodata, there was some problem with the network connection. Am I audible now?
Yes, yes.
Okay, so I'll just complete that portion that I could not complete your biodata. I'll just quickly read out.
Okay.
Professor Viladkar, after completing 36 years of service in the Erstwhile University of Roorkee, now known as IIT Roorkee, later he has worked as an emeritus professor from 2015 to 2018. His research interest includes the area of static and dynamic soil structure interaction, earthquake engineering, rock mechanics, rock engineering, numerical methods in geomechanics, and computational nonlinear mechanics. He has been principal investigator in a number of research projects. He has served in various research capacities in Italy, UK, Hungary, and Hong Kong. Dr. Viladkar has been chairman of CED 56, the committee of the Bureau of Indian Standard on Hill Area Development Engineering, also on CED 48 committee on rock mechanics. He has been a member of BIS committee on selection and development of sites for buildings in hilly areas, and he is currently a member of committee on underground openings and field monitoring. Professor Viladkar has received number of best research paper awards and fellowship. The Indian Geotechnical Society invited him to deliver the 39th IGS annual lecture. He is also conferred the Kuckelman Prize in the year 2018, and he is an honorary fellow of IGS in 2019. Thank you very much, Professor Viladkar. And if there are questions, I think we'll get back to you depending on availability of time at the end of the session.
Thank you, Professor Gandhi. Thank you so much.
Right. Thank you. So now we switch over to the third keynote lecture. We have with us person with both academic and field experience, Professor Kumar Pichumani. He is going to talk to us on reclamation and ground improvement of soft marine clay for development of offshore terminal 4 at JNPT, Navi Mumbai. Dr. Pichumani is presently with AECOM India Private Limited. I will briefly read out his biodata. Professor Kumar Pichumani has 27 years of experience in the field of geotechnical engineering. It includes teaching, research, consulting, analysis.
Yeah, I'm joined.
Analysis and design in various aspects of geotechnical engineering. His experience includes foundation design for various types of structures in transportation and marine infrastructure projects. He has been responsible for various projects involving ground improvement of soft clay and reclamation fields. He has been involved in design of underground structures of metro projects, presently involved with Nagpur Metro, Kolkata Metro, and Chennai Metro. If you look at his appointment, he has been working earlier after PhD from IIT Kanpur. He worked with Kolar Goldfield, and then he was with IIT Madras as faculty in civil engineering, and then he joined L&T Rambol as a consulting engineer.
Dr. Gandhi, you're on mute. Professor Gandhi, you are on mute.
I have unmute. Are you able to hear me?
Now you are, yes. Now I can hear. We can hear.
Okay. Sorry. Do we have time? Shall I read it again?
I think it's not required.
You can continue, sir.
Okay. Okay. I think we will come back to your biodata. Everybody knows you. So you please proceed with your lecture.
Right. Thank you, Professor Gandhi. Very nice introduction. Nice to see Shahrukh Bagli also. Met him long time back. So it's good. I thank IGC, Professor Satyanarayana, to have given me this opportunity to give me a presentation, or a keynote lecture on the practical aspects which I have been involved with. Shahrukh, please let me know when 5 minutes are left. I have a small video which I would like to present. So
Let's
I will
see
cut my lecture.
how we are with the time. And,
sure.
And unfortunately, you're touching a topic which is very dear to my heart. So I don't know how I'll be able. It will break my heart to interrupt you.
Oh, that's okay.
I've been working in JNPT also. Fine, let's go ahead.
Yeah. So what, during the last 5 minutes, please let me know. I will show a small video, which is just 3 minutes. That captures the entire JNPT project from the design stage to the execution, which will be very useful for everybody. Okay. Is my screen visible?
It's blank. Yeah, now it's visible, but you'll go in the presentation.
Yeah. That's right.
There you go. Fine.
Okay. Right. So I have 20 minutes, you said, isn't it?
Yeah.
Okay,
and
right.
15 minutes, I will warn you.
15 minutes, you will warn me, right?
Yeah.
Okay, thank you. So this is my lecture on reclamation and ground improvement of soft marine clay at JNPT. So this is the terminal from the Google image. The red line shows the entire project that is to be constructed. The area was around 100 hectares. So we had a large amount of investigation done. This is just a glimpse of it, some 89 boreholes. Let's not go into details. So what I mean to say is a large number of investigations were done, appropriate investigations were done. So the topsoil, as you see, which is unit 1, is soft clay, very soft clay. So 0 to -4 is very soft clay, -4 to -12 is soft marine clay with SPT values of 8. Now, since these SPT values were low, these were the investigations this was done before at the tender stage itself or by the client himself. So this is how the entire clay thickness varies. You can see here the red shows almost 20 to 24 meters of thick clay, and the green shows far lesser depths, even 4 to 7 and meters of clay. So the variation of clay depths varied from 4 meters to 22 to 24 meters. So these are the Atterberg limits. If you see, it is liquid limit is between 70 to 110. Natural moisture content was 30 to 80%, and plasticity index was 60 to 120, indicating that the soil is the clay is very plastic. This was the undrained shear strength. As you see, you have the CPT plots, vein shear plots, all of them are over here. SPTs were not considered over here because we had much better tests. And if you see the strength of the soil within the top 4 meters up to say minus 3.5 is less than even 5 kPa. After that, it increases gradually. So the project consisted of construction of a terminal for JNPT, which is the 4th terminal on top of this soil. So the existing bed level was at 0. It had to be raised to +7. So 7 meters of completed fill. So that indicates that how much of consolidation settlements will take place. I'll show you all the details now. So basically the problem is of soft soil, compressible soil, and we need to have a reclamation with ground improvement. So as you see over here, the CV values were also very small, 0.85 to few values were more than 2, but predominantly most of the values were in the range of 1 to 1.5. Similarly, coefficient of radial consolidation 1.9 to 4. So most of them were in the range of 2 to 4. CH, which was done from cone dissipation tests, also showed values in the range of 3.5 to 4.8 meters square per year. The CR, that is CC upon 1 plus E naught, varies from 0.15 to 0.35. C alpha secondary compression was between 0.015 to 0.035. The pre-consolidation ratio over here, you see C alpha by CC was in the range of 0.033. Over-consolidation ratio on the surface was high. So typically the marine deposits were, because of tidal variation, this OCR is there. Beyond that, the OCR reduced over depth. This shows the design parameters. We'll need not look at it now, but to give a brief for this one, CC upon 1 plus E naught varied from 0.19 to 0.3, and CV was 0.8 to 1.7. So what we did was this entire stretch. So now if you see that rectangular portion, this is the length of 1 kilometer by half a kilometer width. This is the container terminal, and this strip of land went up to 4 kilometers length, which included the rail and road track. The width over here was 100 meters. So the entire area was broken down into number of zones. These zones were depending on the thickness of the clay, the properties of the clay, and the various loadings that are going to come on top of this. So if you see here, here it is zone 7, which is very small. This is where the building was going to come. Zone 6 over here, also there was a building. So the loading was different, and hence zoning was done there. So we had to do 3 types of analysis. So we were the consultants for the detailed design consultants for ITD cementation. They were the contractors executing this project for BMCT. That is the PSA. PSA's Indian counterpart, Port of Singapore Authorities, Indian counterpart was BMCT. For them, this was being executed. So the conditions were like this: slope stability. So we need to have a reclamation fill, and the edge of the fill will obviously be a slope, and hence the slope stability analysis, we needed to have a temporary condition factor of safety of 1.3, permanent condition factors of safety. Then settlement analysis, we had to have the this is the main residual settlement of less than 100 mm in 2 years, less than 150 mm in 5 years, and less than 300 mm in 20 years. So these are very stringent requirements for such soft clay. Then deformation analysis of the edge structures. Vertical deformation was 25 mm, and horizontal deformation was restricted to 75 mm. Now let us look at the slope stability analysis for the perimeter bund. So this is how the entire reclamation is going to be. Approximately 0 was the bed level, 2.5 was the seabed, the water level. It varied from, the tides varied from 0.75 to plus 4.4. So the mean sea level is plus 2.5. Plus 7 was the final level. On this, we had on the 1 kilometer that container area, the container stacks would be giving a loading of 50 kPa, rails will give a loading of 30 kPa, and the road a loading of 10 kPa. Then on the edges, you have revetments, which had to be designed for the earthquake and the static condition. You see the soft marine clay varied from 5 meters to 18 meters thick. CU was varying from 5 to 7 kPa up to the top 2 to 5 meters. Beyond that, the strength improved. Now, this is the construction sequence. One second. This is the construction sequence. So first you raise the level to plus 5.5 because the maximum water that would go up was up to plus 4.8. So the contractor said we will fill it up to plus 5.5 and then we will do all the ground improvement that is required. So the first challenge was to raise the level up to plus 5.5. Then the PVDs were installed. Then the next level, now depending on the design, we had to raise it to a next level of plus 8. Then depending on the loading, it had to be raised to a level of plus 12 or plus 10 or plus 10.5, depending on whether it is 50 kPa loading, the 30 kPa loading or the 10 kPa loading. That is the final loading that's going to come. So this is all the surcharge that was put. And then finally, the everything was removed to plus 11. You see this, so the whole area was divided into different layers, different zones. And the shear strength over here, as you see, is was varying in this fashion. The top 2 meters, 3 meters was around 5 kPa. See, here it is around 7.5 kPa. Now what happened? See the top, so the filling process was basically end-on dumping. So from the existing road, which was at plus 7, we started moving down into the reclamation area and started filling. So what happened is we need to fill up to 5.5. So 0 to 5.5 meters of filling is a sufficient loading, because of which soil displacement took place. The top 2 to 3 meters of soft clay got displaced, obviously because of the bearing capacity problem. This created mud wave. I'll show you a picture of mud wave. Then what happened was all the soil up to almost 10 to 12 kPa got removed, mud waved, and the shear strength of the bottom soil started from 13.5 kPa from minus 4 MCD. So you can see this figure. The before filling, you had the bed level, which is at plus 1, which is shown by the green triangle. And after filling, the entire level came down to almost minus 2, depending on how the strength of the clay was. It varied from minus 2 to minus 1. So almost 2 to 3 meters of replacement took place. Then we did confirmatory borings over there to check the shear strength. And if you see the circle which shows the confirmatory boreholes, the shear strength was close to around 15 kPa. So all soils which were less than that 13.5 to 14 kPa got mud waved. See, this is how the mud wave is. This black portion is all the soft clay which has been mud waved. This is the filling. The brown portion is the filling. And this is the mud wave. You can see that the level to which the mud wave has risen is almost to the level of the fill, which was at plus 5.5. So the mud wave itself had risen from 0 to almost plus 4. So 4 meters of mud wave had been formed. So then geotechnical parameters of reclamation fill, let me not go into this, which was used for the analysis. So the ground improvement methodology was PVD, surcharge, and raise it in stages. I'll show you how it was raised. So initially up to plus 5.5, then plus 5.5 to 7 or 8, depending on where the surcharge was, and plus 7 or plus 8 to the final surcharge level. Then maintain the loading until 95% consolidation was over, and then it is cut down to plus 7 for the finished level. So PVDs were installed. These are some figures of the PVD. Slope stability analysis was performed. So now there were two cases. One is under temporary condition, the factor of safety should be 1.3. And under permanent condition for static and seismic, the factor of safety had to be 1.5 and 1.1. So achieving a factor of safety of 1.3 in static, in the temporary condition, was the biggest challenge. Especially now when you have to raise it to plus 5.5 without any reinforcement, we said that this is impossible, and hence we maintained a factor of safety of 1, close to 1, until we reach plus 5.5, and after that we maintained this. So because of this temporary condition being very high, we needed layers, one layer or two layers of geotextile only for the temporary condition. Now these are slope stability analysis that were performed. Now the most important thing that we need to consider, see, you see this line over here, this is the final level or final structure that is going to come. But since the soil was very soft below, the entire soil below the slope also had to be reinforced or improved to such an extent that over the next 100 years, there would be no failure. Because of this, we had to have an overfill. So here you see there is a 12 meters of overfill. See this over here, 12 meters of overfill. In certain areas, there were almost 25 meters of overfill. So the PVDs were placed through this overfill. So much of extra fills were considered. Look at this. Here also there is an overfill. And at some levels, you have geotextile over here. So here there is a geotextile at plus 5.5. Here also there is a geotextile at plus 5.5. This was required because at plus 12, when you raise, the slope stability was not achieving a factor of safety of 1.3. Then these are all temporary conditions. So the different factors of safety are mentioned over here. Let me not go into all that. Then we waited for 95% consolidation. And then the overfill was cut back to the required geometry. So that is of most importance. See over here, the overfill was later cut back. So this is the final geometry. You had an overfill over here. If you can see my arrow, you had an overfill over here. All that was removed. Now the strength was sufficient enough to get a factor of safety of 1.5 for static and 1.1 for seismic. So this is how the drawing was. This is very clearly shown. This is the final surface that was required, whereas the overfill had gone up to this level. Okay, so all the overfill was put over here so that the final thing is reached. Final strength is reached within this area. Then we'll go into the settlement analysis, that is ground improvement. These parameters I have already discussed. The loading was up to plus 10.5 to plus 12. So PVDs were used. Now, while using these PVDs, we had a spacing of 1 almost in most of the areas. 1.2 was in some areas. The smear effect was very, very drastically shown because some of the designs, we had designed the PVD, we had designed the surcharge to be placed for 3 months, but in some places it went up to 4 or 5 or almost 6 months until the 95% consolidation was over. So let me not go into details of this one. I'll go into the instrumentation analysis and the back analysis, instrumentation and back analysis. So this is most important because we had to monitor whether the 95% consolidation is completed or not. So these are the various types of instruments. You had settlement gauges, we had piezometers, magnetic extensometers, and inclinometers at the edges. Some photographs of the setup. Now this is how the entire plan was. We had a settlement markers at every 25 meter spacing, and then this G, B, I indicates inclinometers, G indicates ground settlement markers, B indicates boreholes. All these were included, so many instruments were there. Almost 2,000 settlement markers. You can see the numbers over here over the entire 90 to 100 hectares of reclamation. So this is, you see spots at every 25 meters. Some instrument or the other were there. The detail A, B, C, D are a combination of different instruments. So from the this one, now a little bit of back analysis. So we had an existing settlement curve. We back fitted the settlement curve or did, what do you call, from the theoretical prediction, the settlement data that was observed was tried to fit by adjusting the parameters. So based on this, so we had 3 types of data. One is settlement gauges, then the piezometers, and magnetic extensometers. So these are plots from extensometers and settlement gauges. Back analysis was done by the alpha method, and CH of 3.75 to 4 was obtained. And here smear ratio and those were also obtained, ratio of the permeability. So smear ratio was 2.5, permeability ratio was 3 to 4. That first one was the curve fitting method. Then comes the alpha method using Hansbo's equation, converting it into a straight line. And these are the curves that we got. And when you do this back analysis, we got a CH value of 3.7, the smear this thing of 2.5, and KH by KS of 3. I mean, we kept these two constant and tried to adjust so that the curve fitted almost perfectly. This is again back. Yeah, 5 minutes?
Yeah.
Okay, so it's almost over. So range of values that we got matched with almost what we considered, although what we considered was a little on the conservative side. So this is the finished container yard, which has been handed over. This port is operational. This terminal is operational since 2017. Terminal 4 of JNPT, it is doing extremely well. These are the railway tracks. This is the building. So that is how, wait. So now what I'll do is, I'll show you the video. For audio, what should I do? Satyanarayana?
Sir, you have the options on the top, sir.
Yeah, share compound sound, computer sound.
Yes, exactly, sir.
Okay, right. So this video shows how the entire project was done. Is it audible?
Yes, sir. Yes.
Okay, fine. Paycom was the detailed design consultant for the contractor ITD cementation for BMCT project at JNPT, Navi Mumbai. The reclamation is the largest in the country, which is around 100 hectares. There were a myriad of challenges that were faced during execution.
The subsoil profile below seabed level comprised of 4 to 18 meter of very soft clay. You could imagine the top 5 meter was as soft as butter. Above this, a finished reclamation land must be created for the container yard and railroad corridor.
The greatest geotechnical challenge for Chennai team was to give the most simple but robust ground improvement scheme by installing PVDs that could be executed by a local contractor.
Slope stability analysis and deformation analysis were carried out. The entire project was completed within 27 months with elaborate instrumentation and monitoring.
That the project was executed to the utmost satisfaction of BMCT. I am sure my team would agree that this is one of the most fascinating projects for any geotechnical engineer. Okay, thank you.
Good.
Thank you, sir.
Thank you, Gandhi. Thank you, Bagley.
Yeah, I think as Dr. Bagley has mentioned, it is his favorite subject. I just want to add, it was a very interesting project, and JNPT is known for the mudslides, mud waves.
Yes.
And this is experience when the first international terminal came up there, and subsequently during the portcraft and shallow water berth which came up with a diaphragm wall, we have seen how the mud wave has displaced the piles of the approach jetty, and the pile tilted and they had to be replaced. This offshore terminal is still further challenging because you have gone deeper into the water, and the thickness of soft clay is larger there, and I think the size of the project is somewhat similar to what Adani Port is presently doing at Mundra, but that is not having a soft clay, fortunately, in the bed.
It is all sand. Yes.
Yeah, it's all sand there, and here the magnitude of settlement was almost equal to what was there at Kanla seventh berth, and instrumentation shows that settlement of 1.2 meter. There it was 1.35 meters. I think very challenging work, extensive instrumentation and detailed analysis done by AECOM. Congratulations for this project. I think I will Dr. Bagli to have some remarks on this.
Yeah, sure. I'll be too happy because I had 2 trysts with this type of soil, the marine clay of Thane Creek. We prefer to call it Thane Creek from the CRZ point of view. So pardon me calling it Thane Creek and not the Arabian Sea. Yeah. Well, I had the experience of Trombay, where the Tata power plant is, and of course Nhava Sheva, now called JN Port. Well, I've got some points, so I'll summarize a little. Well, Dr. Pichumani very well explained how the design of the jetty has been done, taking into account the vagaries of the marine clay, which is typically Bombay marine clay, as it is called.
Yes.
And he has also highlighted the importance of instrumentation, and you're very lucky that you are allowed to spend money on instrumentation, which is something which is in India, well, people don't want to spend money on instrumentation. You've also brought up 2 aspects of overfill. One is an overfill because of the replacement of the clay, because of the mud wave, and the other is the necessity for having an overfill to create that much of pressure to develop the pore pressures to release to consolidate the marine clay. There is one question I'd like to ask you, sir.
Sure.
I worked on this marine clay. You've mentioned some geotechnical parameters which could be well brought out in the laboratory on undisturbed samples. Now, I know that AECOM may not have been associated with the geotechnical investigation, but how were undisturbed samples taken in butter clay?
We were involved in the investigations as part of detailed design consultants. We had told ITD Cementation to do a lot of investigation. So to collect undisturbed samples, we asked various people. It was not a small signal. We inserted a larger diameter tube or 100 mm tube, as advised by IIT Madras. Professor Robinson did the radial consolidation tests on them. So we used 100 mm diameter core samples into the top portion alone, took it out, and then through that the central portion of the cylinder, the UDS was collected. So the tests were done on those samples, which were supposed to be quite reasonable. Same thing was done by Fugro.
Yeah, but I'm sure that your values were very conservative because of that.
Correct. That's why if you see, we took 1 meter square per year as the CEV value.
Yeah.
But if you see the cone dissipation test, it showed a much higher value.
Yeah.
Although we were not very comfortable in taking those values because we had to be conservative.
Probably you may have had to revert to tables of birth look, but then, well, that's a different matter altogether.
Correct.
Thanks a lot, sir. Thanks a lot.
Thank you.
Thank you. So, shall we move on to the next lecture, please? I think the 4th lecture today we have from Professor G.V. Ramana from IIT Delhi. Professor Ramana, you are ready?
Yes, sir. Very good morning.
Morning. I'll just quickly read out a few lines of your CV, though everybody knows you well. Professor Ramana is a professor and head of the Department of Civil Engineering at IIT Delhi. He mainly specializes in geo-environmental engineering, geotechnical earthquake engineering, waste mechanics, and ground improvement. Throughout his career, he has worked as a consultant and expert on various geodisasters, their mitigation, and remediation. He holds a PhD from Rensselaer Polytechnic Institute, New York, and I'm happy that he also holds an MTech degree from IIT Madras. Professor Ramna, very nice to have you here on this session, and we look forward to hear your keynote lecture. Professor Ramna, please.
Thank you very much, sir. And in fact, it is almost a pleasure. And all the credit goes to Professor Reddy. And I thank the IGS team for allowing me to give this presentation. And hope everybody is able to see the screen and I'm audible.
Yes.
Yes, great. So, Bagli sir, kitna time hai?
It is same 15 minutes, and Professor Dr. Bagli will give you a buzzer after 15 minutes. So you
okay, sir. 20 minutes, so I'll wind it up. So thank you very much, and good morning, everyone, distinguished what you call senior professors and the delegates. Very good morning. This is about a small project I got involved at Polavaram project. This place is close to my native place, and this is one of the large earth dams. What I mean large earth dams, it is not in terms of the height, in terms of the length. This is a quick view of the Google Earth image of the Polavaram Dam project for those of you who can't travel. This is the river Godavari. This is the constructed upstream coffer dam in place as of today, downstream coffer dam, and spillway structures are partially completed. And this is the spill channel in which we are going to have some trouble because of the clay. And this is a small video of the upstream coffer dam that is in place and which survived 2019 floods, for those of you who can't go to the site. And in fact, this is your upstream coffer dam, this is your downstream coffer dam, this is along which the dam is going to be aligned. Between the two hillocks, they give another name. There is a small portion of the dam here, but this gap 2 portion of the dam, which is primarily located in the river portion. It is about 1.75 kilometer long, and the height of the dam is about 45 to 50 meters along that stretch. So, yeah, as usual, I got involved here right from the geotechnical investigations. I was lucky enough. DDRP panel, Dam Design Review Panel, and Central Water Commission were kind enough to get me involved. Besides regular borehole drilling and a collection of undisturbed samples and some SPTs. These are very routine tests which we need to have. And beyond that, we did ECPT, electric cone penetration test, and cross-hole shear tests. And the borehole tests were conducted at 3 meter offset, and CPT center 10 meters offset from the cutoff wall constructed by Bauer in place. And we conducted 2 cross-hole shear wave velocity tests. One is 63 meter deep and the other one is 93 meter deep. So this is the cutoff. The red line there you can see is the cutoff wall axis, and significant number of tests were conducted. And ECPT, this is the diagram I have taken from Paul Main. For some of you, most of the geotechnical engineers are familiar these days. And some of you have not seen the equipment. This was conducted by Keller Company. And it is very routine. I mean, routine test in some geotechnical investigations, including the pore water pressure measurement. And based upon the geotechnical investigations, the main gap 2 dam, a part of that is sitting on sand region and a part of that is sitting on a clay of high plasticity. I will just show you the profile. This is the Google Earth image, and the dam is going to sit across here. And this is how the data looks like. This is from a bunch of the SPT, ECPT, and tests done by CSMRS and some other companies. The best part it is on the right side, you can see that towards the left bank, it is a clean sand. The percentage of fines are less than 3%. On the left side, we have 3%, it is CH, and the clay is highly plastic. For example, on the clay side, the plasticity index is about 40 to 50. And the liquid limit is as high as 70 to 80 at some locations. And natural moisture content is hovering around the plastic limit. These are the E-log peak consolidation test results conducted by CSMRS through undisturbed soils, which I'm not aware how they got it, but it also shows a high compressibility. And this is the channel, spill channel, which is towards the right bank. I hope you can see a small dump here. This is the overburden mine dump which these people are dropping there, and it induced a failure all the way down to the river. You can see the cracks here, the pavement broken. Now it is a very close-up shot where you can see it is being clearly seen. And this is a small video of about few seconds only. This has displaced here. This is due to the overloading on the top of CH clay. And ECPT test results, when you get electric cone penetration test results, we have to classify them using soil behavior type, not like a SPT test where we are going to get. So soil behavior type zones are used for interpreting the data and see how well the CPT data is able to capture the behavior. This is a borehole, and this is the soil behavior type from a ECPT test. So this clearly shows that this portion is sand and this portion is clay. So I still can't understand. We still rely upon SPT for our routine investigations. We should move on to CPT. This is another place where, I'm comparing a ECPT test and a borehole close by, and you can see a remarkably nice match. The only problem with CPT is we can't get a test for carrying out some liquid limit or grain size distribution curves. Then another best part is we did 2 crosshole seismic tests by Fugro. One is for 63 meter, the other one is for 93 meter depth. I'm showing the results directly at the 2 chainages. This is at chainage 480, which is 63 meters. The other results are on the lower side, which is at another chainage, but only 70 meters away. But the depth of the borehole there is 93 meters. There is a significant difference between these two. So we need to find why. So what we did is we had extensive set of SPT and we had CPT test data, and we compared the values measured with empirical correlations. You can see here very clearly that at the chainage 480, the measured value and the estimated value are very close to each other. Whereas at chainage 550, the measured value is significantly lower than the empirically estimated value band. So we decided to disregard the 550 meter depth. They repeated the test, but the values were not coming right. Most likely it is a 93 meter deep wow. So we disregarded data, and this is not considered further in the design. For finding the liquefaction susceptibility assessment, we used the standard procedures available. We followed the NCER guidelines, and the seismic parameters were given by University of Roorkee seismology department. They said consider a magnitude of 0.65 earthquake and 0.18 G. These are the values given by CWC and this one for finding the liquefaction susceptibility at the site. So we tried to find the liquefaction susceptibility using, we had 3 sets of data with us. We had SPT, we had cone penetration test, we had cross-hole shear wave velocity. This is a geotechnical engineer's dream. We can compare the values from each other. And another interesting thing is the percentage of fines in the sand are almost nil. It is a very clean sand. The percentage of fines approximately is about 3% in about a stretch of 1 kilometer. And these are the typical N values I found and plotted, but we can see that that's why I don't like N values. Even at 40-meter depth, these are coming very low, which is due to the operator or the way they are doing the test. So SPT, the reliability is slightly on the lower side, and at a 40-meter depth, getting a 20 is very unlikely. So for the liquefaction hazard assessment, average N value is used. We can debate about it, but what we did is we used a factor of safety of 1.5, whether it is going to liquefy or not, using the simplified approach with the developed procedures, all the corrections. So if we use a factor of safety of 1.5, the depth of liquefaction is coming around 16 meters. Is coming around 16 meters. When I went for using CPT, we had 27 number of CPT data, and in fact, we can do a PhD degree here. But what we did is we analyzed each CPT data, and then we averaged the factor of safety. I know this is very crude, but that's how it works in the site. If you start doing risk analysis, and if I start doing probability and everything, engineers won't like it. They would like you to give a solution. So when I looked at it, the depth of liquefaction is coming around 9 meters, considering a factor of safety of 1.5. But with the shear wave velocity, we got into trouble. So at one chainase, we are getting 24 meters, and the other chainase, it is coming around 6 meters. So 24 meter depth of liquefaction is due to the error in the measurements. That's what I believe. And we disregarded that value. So we recommended a depth of liquefaction of about 15 meters. But contractually, I think this project has a lot of history, and they said the minimum improvement required is 20 meters. It is required for 20 meters. So how do we improve the subsoil at the sand region? We decided to use vibroflotation technique. And to do this, what we did is, at what spacing should we use? What should be the capacity of the vibrator? And all these trial and errors were conducted. So at one location, we used a spacing of 2 meters center to center. And in another location, we used a 2.5 meter center to spacing. And we carried out pre-ECPT and post-ECPT, before and after. Because when the government wants to pay the contractor, they say, where is the improvement? So these are some of the pre-ECPTs that we used for in situ ground. After vibrocompaction, we carried out 4 post-ECPTs. Now, when you want to use this data, we get into what is the in situ density, unit weight from the CPT. Again, there are a bunch of correlations available in the market, and we used Robertson and Kawal. And this is the unit weight of the ground before treatment. It is about fluctuating between 16 to 18. And here it is 16 and then it is remaining sort of 17 and constant. Then after the post-vibro compaction also we had ECPT data. So we try to look at what is the average profile after this one. So it is going to be about 18 and 19. But it is very difficult to use these correlations. So this is the pre at 2 locations and this is the average post at the 2 locations. So there is an increase in density, but it should be converted to relative density. So when we would like to use relative density from the CPT data, there are quite a few correlations available. Kulhave and May in 1990. We used those correlations. So this is the relative density of the in situ. It is about almost 60%. So I don't think there is, the chances of liquefaction would be very low. But again, it is contractual obligation. So vibrocompaction was done and the post vibrocompaction, the relative density went up to 80 to 90%. Above 80%. So there is an increase in the relative density of the sand post vibrocompaction. This is the relative density before, and this is the relative density post compaction at one of the trial sites. At another trial site, this is the improvement in the relative density. Now, when we told the engineers that you have to follow this procedure, then they wanted, how do I do my construction quality assurance? How do I know that the soil has achieved this kind of relative density? And they told us these relative densities and everything, we are very worried. And what we know is cone penetration test gives me a QC value. So they asked us, give us a target QC so that the ground has a relative density of 80% or more. Then what we did is we went to the literature and looked at different correlations available. Schmeckman has given one correlation. Willett and Mitchell has given another correlation. Baldi has given another correlation. So we used all these 4 correlations and tried to tell the engineers what is the target QC which you can check in the field for paying the bill. Primarily that's what it comes down to between the contractor and the government agency. Now, this is the target QC required to get 80% to 90% relative density using one of these correlations. Using another correlation, Baldi's correlations, for 80% or more, the tip resistance should be more than this. These are all the post. So in these 2 cases, they are completely satisfying. And this is another correlation. And finally, we used Kulhave and Main. So these 4 correlations have different connotations, isn't it? They're not getting the same values, but finally, the engineer said, what should we do? So in the DDRP, they decided that the 4 of them, you should take the average and the measured QC should be more than this for paying the contractor. And this is the vibrocompaction being carried out by Keller at the site. This is the trial area where we did. And after that, you can see a crystal clear deformation of about 5 to 7%. This is a small video.
I think, Professor Ramana, there is some issue with the playing of the video. Would you like to skip it?
Yep, I will skip it. Yeah. So what we did based upon this is for the vibrocompaction works, I think ECPT is the best method to record continuous monitoring and to verify pre and post engineering behavior of the soil. And at the site where the fines content is less than 5%, I think getting a post relative density of 80% is practically achievable. They did the trials at 2 meters, 2.25 and 2.5 meters, and we decided for a spacing of 2 meters.
Some 5 minutes, please. 5 minutes.
Yes, sir. I'm going to wind up in the next few minutes.
Thanks.
So this is the typical ground improvement chart most of us are familiar with. So at Polavaram project, we are sitting on both of them. We are sitting on a CH clay and a poor sand. So it's a geotechnical mini paradise, and vibrocompaction has been implemented at the site for liquefaction resistance. And then we are going to do some vibro replacement for the clay settlements to be under control when we make a 45-meter dam. And thank you. And this all work, there are several people, and Professor B. Janakaramaya at IIT Tirupati significantly helped me in some computations. And Mr. Mohammad Rafi, who is associated with the project right from the beginning. Government keeps changing, contractors keep changing, but this gentleman is always with the project, is dedicated to that, from which I'm able to get the data, and Mrs. Keller, who sort of made me available some of the geotechnical investigation data. Thank you, sir.
Thank you. Thank you, Professor Ramana. Dr. Bagli, I'll take few minutes and then hand over to you for the summarizing again. Let's quickly have a review of all the four lectures. I'll be very brief. Professor G. Han talked about the RE wall with the two theory, whether you have a steep angle more than 75 degree where we take earth pressure concept, otherwise where alpha is less than 75, we go for slope analysis. My concern is that we have been observing still a lot of failures in RE walls in different highway approaches and even for various other applications, whether it is due to the problem in drainage or inadequate anchor system provided that needs to be looked into to minimize such failures. Very interesting lecture by Professor Hans. We had a second lecture by Professor Viladkar giving the earthquake effect on underground structures. He highlighted the issues related to liquefaction resulting in uplift on the tunnels, and he also talked about the horizontal accelerations sometimes being higher than the vertical accelerations earthquake. Thank you, Professor Viladkar, for this interesting talk. We had a detailed presentation on the offshore terminal by Professor Kumar Pichumani, where he has discussed detailed instrumentation. The Navaseva port area fortunately do not have much of waves and currents, being much interior from the main sea. Otherwise, the placing of the material itself is a challenge. If you talk about the Gujarat coast, the current is so high and tidal variation is so high that material placed will simply disappear unless it is protected by the stone fill first. So each site has some unique problem, and you have done a very challenging project. I would have been happy to see one or two typical measurement of either inclinometer or a pore water pressure measurement, how fast this pore pressures has dissipated due to the vertical drains. Thank you, Professor Pichumani, for interesting lecture.
Thank you, Professor.
Thank you. The last but not the least, from Professor Ramana, he gave an interesting presentation on the hydropower project at Pallavaram. Here it is interesting that over the entire length, half length has a major sand deposits where liquefaction was an issue, and it was effectively tackled by vibrocompaction. And he explained how ECPT, electronic cone penetration test, has helped in assessing the condition both before and after the treatment. The part of that is on stiff clay. So I was wondering whether there were any issues related to the differential settlement between the 45-meter high dam sitting on sand and then having partly a thick clay deposit. As far as earth dam is concerned, the differential settlement should not create much problem as it adjusts, but if there is a gravity suction in between, then the differential settlement had to be looked into. Thank you, Professor Ramana, for this interesting talk. Dr. Bali,
Yeah. Can I say a few words on Dr. Ramana's lecture? A wonderful lecture and really an eye-opener. And it really shows the significance, it points out the significance of having a proper geotechnical investigation. And I really admire your decision to ignore the wrong N values. I'll really use the word wrong N values at that deeper depth. And you've really used proper judgment to ignore it. And finally, you did have to do densification to a depth of 20 meters. And what I did like was your quality assurance and quality control using the electronic cone penetration and using QC as your norm, as your basic target, and comparing your efficacy of your vibroflotation through that target. Thanks a lot, Professor. It was really enlightening.
Thank you, sir. It's all learning from the seniors, sir. It was all input from, if my teacher is sitting there, Professor Gandhi and Professor Raju and all these people, they taught me. So it's all credit goes to the teachers.
Okay. Professor Gandhi and Bagliji, can we close the session now?
Sure, certainly.
Okay, then shall I give the closing comments?
Sure, sir.
On behalf of the organizing committee of IGC 2020 and Andhra University Visakhapatnam, I thank session chairman Professor S.R. Gandhi and session co-chairman Sri Shahrukh Bagliji. I also thank President IGS Professor Sivakumar Babu Garu for gracing the plenary session 5. I also thank the keynote speakers and distinguished experts, geotechnical experts and delegates for attending the plenary session 5. Thank you. Now over to IGC 2020 Secretariat.
Thank you.
Thank you all. Thank you so much.
Thank you.
Thank you very much.
Thank you.
Okay.
Thank you, Professor Srinivas.
Thank you, sir. Thank you.
Effectively conducting the session. So I take this opportunity to thank Professor S.R. Gandhi, my teacher at IIT Madras. Though he is very busy as a director at NIT Surat, he could spare some of his time for chairing this session. I thank Sri Shahrukh Bagli for co-chairing the session. And I thank the keynote speakers, Professor M.N. Vilatkar, Professor Jihan, Dr. Kumar Pichumani, and Professor G.V. Ramana for presenting very interesting and informative talks. So all the delegates have enjoyed your lectures. Our chat box is full of appreciation to all the lectures. So thank you very much, sirs.
Thank you. Thanks a lot.
Thank you.
Thank you.
Thank you.
Thank you, sir. Jihan, Professor Jihan.
Okay. Thank you. Enjoy.
Now we'll
very much.
Now we'll and particularly thank session chair and co-chair for maintaining the time. Though initially 3 keynotes were there, though 4th lecture was added, they have managed the time very well. so that corporate presentations are happening as per the scheduled time of 11:15.
Thank you for the compliment. Thank you.
Thank you. Thank you.
Thank you. Bye.
So next, now we will be having corporate presentations, two corporate presentations, one by Messrs. Garware Technical Fibers Limited, followed by Messrs. McAferry. First, I invite Mr. J. Raja, Geotechnical Engineer of Messrs. Garware Technical Fibers Limited, to make his presentation. Raja, please. Mr. Raja, are you there? Mr. Raja, are you there? Dr. Ratnakar, are you there?
Yes, sir, I am there. Can you hear me?
Yeah. So, since Raja is not responding, I request Dr. Ratnakar Mahajan to make presentation on behalf of Messrs. McAferry. Please, sir.
Yes, sir. Thank you very much. I hope the screen is visible to you, sir.
Yes, it is visible. You can continue.
Okay. Thank you very much. So, very good morning to one and all. I will be talking on the emergency slope repair solutions. Okay. So I am Ratnakar. I am associated with McAferry past 13 years and working as a technical manager. Before joining McAferry, I finished my PhD at IIT Bombay. McAferry, is 140 years young organization, present in all 5 continents, having presence in 100 countries through 70 subsidiaries. We provide solutions for various applications like retaining walls, basal reinforcement, rockfall protection, landfills, then your hydraulic works and erosion control, and so on. The importance of emergency restoration works are increasing day by day because the rising number of natural hazards such commonly encountered in hilly slopes, especially in Himalaya. And so you can just have pictures which are just showing the typical situations. So in this presentation, I will just cover what is the usual approach to treat these solutions. What are the requirements? What are the innovative solutions? We are going to discuss some case studies and then a summary. So the usual approach for emergency solutions is to cater a slope with basically a plastic sheets or sometimes beside the valley, or use of steel drums filled with soil, or installation of handmade, some steel cages will be put. Another approach is to go for heavy or time-taking solutions like masonry or concrete retaining walls. These are typical the solutions which are adopted. Now, when we look at this requirement of emergency slope repair, so when there is a slope has been failed, so typical requirements are like you need to have great functionality for erosion and instability, higher structural or mechanical performances. The material shall be lesser in weight. It shall be easy to transport and quick to assemble. And if possible, use local available fill. That is typically the requirements. So there is an innovative solution is referred as an ADOX solution. These ADOX units basically are flexible system made up of steel modular structure. There is a special connection of the stem. So this is a stem to the basically cross members. This special connection makes it flexible and allows the fascia to have multi-directional rotation. This makes it possible for it to adapt to soil pressures uniformly. Often ad hoc units are referred as umbrella units. There are a variety of units. The slide shows different units like the first one is a standard ad hoc consolidation unit that we saw in the previous slide, which we used in consolidation retention works. The middle one is similar to consolidation unit, but small in size, 2 meter by 2.5 meter, with non-biodegradable erosion control mats and double twisted mesh as fascia. This is useful for smaller consolidation retention works and promotes growth of vegetation. And the last one is the ad hoc snow unit for avalanche mitigation used for different heights like 2, 2.5, 3, 3.5 or 4. Our main focus today is on the consolidation unit. So for these units, there are three different types of foundations. Typically concrete slab arrangement, which is standard. Second is L-shaped units, L-shaped type of concrete slab. This is applicable where more resistance is required to be imparted by the foundation due to higher loads. And third is a foundation with an anchor. This can also be designed to cater to requirement of global stability issues. Also in some applications like debris flow or avalanche mitigation, this is mandatory to provide foundation with anchors. The concrete of ad hoc usage can be seen in the sketches like here. So with respect to the structural design of this unit, the design is done as per EN norms for steel construction and Euro Code 3, based on which the structural verification is done. The finite element model for verification of structural design is based on the field test validation within 5% variance, which is very good. This forms a strong basis of the design of these units. These units are very easy to transport. The storage and transportation of the system is very good. The pre-assembled units in factory are delivered in folded form to site, which occupy less space in storage yards, and its size make it and weight make it very transportable. Here we can see the unfolding of operation at site, very quick and easy. First, wooden logs are placed on the ground, on which the units are unfolded and operation of final assembly with respect to detachment of mesh is done. This case study of project of Peru, South America, where emergency restoration measure for a highway were to be carried out. The problem faced here was a collapse of valley side due to erosion. First, the excavator was used to carry out necessary excavation and placement of unit. This is the second project from the Kedarnath. So the Kedarnath is basically at very high altitude where any machinery cannot be taken out. So the ad hoc units were adopted. You can see the placement of these ad hoc units for the purpose of basically debris flow barrier. So you can see the number of ad hoc units. At that altitude, working of compressors was difficult. So all the units were transported manually because of its lightweight and pre-assembled system. It could be transported to such an high altitude and it could installed. Another project is from the Arunachal Pradesh at KNL done for the Border Roads Organization. So you can see slide. So coming back to the Peru project, where the excavations were carried out with the excavator, and then the adjacent units were placed with U-bolt arrangement, making it a monolithic structure. So you can have a look at this. This is the ad hoc unit. This is the foundation, and you just simply pour the soil here, and the movement of excavator is enough for compaction. And this is how exactly you can have the excavator put the soil. Note that dynamic loading from this 25-ton excavator within 1 meter face of being well resisted by the ad hoc units. So this is what the photograph showing restoration of the slide. And after some time, you can see here the work is completed and the structure gels with the environment after a few months, and it has very low visual impact. Some other case study from Peru. Here you can see the installation of the ad hoc units in different terrain, different kind of environment, where there was a requirement to stabilize and widen the existing road. So So here you can see there are the photographs after the construction. These are very easy to construct. Typically, 2 hours are enough for installing one redox unit. Within 2 hours, you can do it. This is another case study from Italy in the province of Bolzano. You can see the number of redox units being placed. This was a road and there was a slide. So here, even such difficult situation, accessibility is an issue. Redox can be successfully installed, which can be seen in the slide. The treated zone is about 50 meter in height, and you can see the street at the top. Redox are installed in multiple rows. Even situations where approach.
You have 1 more minute.
Okay, sir. I'm just almost at the last of these slides. Thank you. So here, approach to road village is very difficult, rural road, where you can install this redox unit. You can see here is a hilly terrain, and just this much space is available. It can be also used where maybe slide of retaining walls, waterfront structures, constructing this, or it can be used for debris flow barrier. Typically, they are used for the avalanche protection also. So you can see these redox systems, they are flexible, having great functionality for erosion instability. They are modular system with different possible uses. They have less requirement of excavation. Space constraints is not an issue. They're fast to assemble and fast to install. They're environmental friendly and very low visual impact. With this, I thank you all the esteemed participants for patiently listening. And you can note down my email address for any queries. Because of limited time, we couldn't explain in detail, but you can contact me anytime. You can follow us on our social media. Thank you.
Thank you, Dr. Ratnagar. So I thank Messrs. McAferry for supporting IGC 2020 in the present difficult condition created by COVID-19 pandemic. So I thank you very much for considering our request and coming forward to sponsor the event. Thank you very much.
Thank you. Thank you very much, sir.
Now I invite J. Raja of Garware Technical Fibers Limited to make his presentation.
Sir, share your screen, sir, not the window. Raja sir, are we audible?
Yes, sir. It is audible.
Your presentation is not online, sir. Sir, you can minimize this screen and open your presentation, sir.
So I think Raja has some technical problem. So maybe you can share the presentation to the participants, because next we have technical sessions to start, right? We have parallel sessions, 5 parallel sessions to go. So I take this opportunity to thank Messrs. Garware Technical Fibers Limited for sponsoring IGC 2020. Raja, I think Raja, can you hear me? Okay, he has some issue, it seems. So I thank once again both Messrs. Garware Technical Fibers Limited and Messrs. McCaffrey for making for preparing the presentations and sharing to the participants, and also for their support for organization of this event. So I thank all of you for attending the plenary session 5, and now I request authors of various papers to go to the respective links to present their papers. The others, depending upon their interest, may join links of their choice. So in this present link, the technical papers related to theme 8 will be presented. So we have a technical session related to theme 8, and I invite Professor A. Murali Krishna from IIT Tirupati to conduct the session.
Thank you, Professor Reddy. I think we'll wait for 2 minutes, just people to settle, and then we'll take up the things.
Okay.
Okay.
So welcome to Professor Ramanamurthy from NIT Warangal.
Reddy garu,
Sir.
excellent conference, reality in virtual mode.
Yeah, it was possible with support from people like you.
Yeah,
almost, many of our
really nice.
are helping.
Everything is going on smoothly.
Yeah, thanks.
So before proceeding to the event, so can you please, others who are available, first? Can you confirm in the chat box whether who are available out of these papers? One 95, 96. 99, 106, 112,
Sir, 143 is not in this session. Zero.
Good morning, sir. Ramanamurthy garu. Good morning, sir. Murali Krishna garu.
Good morning. Good morning.
Good morning.
And when Beg sir.
Good morning, sir.
So good morning.
Okay, Ms.
morning,
Madan
sir.
garu, Ramanamurthy garu, you are both are here. So let me start the session. I think couple of speakers also are available. So let me go. Okay, so welcome you all for the theme 8 on developments in ground improvement session. So this is the, I think, fifth session which is happening under this theme. And yesterday and the day before also we had some sessions on in the similar theme, which were coordinated by Dr. Rajalakshmi and chaired by different other people. So in this session, I'm Dr. Murali Krishna from IIT Tirupati, coordinating this particular session. So today we have with us Professor V. Ramanamurthy from NIT Warangal as a chairman of the session to conduct the session, and co-chairman Sri Madar Kumar, who is from Keller, India, ground engineering, to co-chair the session. So these are the papers in this particular session. So we have 15 papers altogether, and we have 1.5 hour time totally, but already with 20 minutes is passed on. So I think I leave to chairman and co-chairman to decide. I'm thinking about 4 to 5 minutes can be given each thing, then you can work out. So people, others, whoever are available as per this order of priority, you can be available, readily available. Okay, and I'll proceed further. So let me welcome chairman of the session, Professor V. Ramanamurthy. He's a professor in civil engineering, having 23 years of teaching experience, and his research interests include expansive soils, reinforced earth, and utilization of fly ash and waste material, something, etc. He has guided 2 PhD students and 46 MTech students. He had published about 80 technical papers in national, international journals and conferences. He received several awards and recognitions, particularly Meritorious Educational Excellence Award in 2003 and IGS awards, several IGS awards in 2003, 5 and 8 for different contributions. Particularly the Corps of Engineers Prize from Institute of Engineers India for the year 2008 and 2009. And one more achievement, remarkable achievement, special achievement is that his publication is recognized as the most popular publication in 2015 by the Institute of Civil Engineers London. This is one great achievement. I congratulate Professor V. Ramanamurthy on this one. So he has been the membership of several societies. Some of the things were mentioned here, and he visited several other countries, particularly UK, USA, and he organized several short-term courses and conferences. And he is very active consultant and handled about 20 projects to his career. With this, I welcome Professor Ramanamurthy to be chairman of this particular session. Now, let me welcome Shri Madar Kumar, who is a very renowned practitioner of geotechnical engineering, working from Keller, India, as a co-chairman of the session. Shri Madan Kumar, he is working with Keller Group in India for the past 10 years, and he is responsible for several engineering unit head as a unit head. He has been active in the design and construction of variety of foundation system for several major infrastructure projects. He had worked for 16 years at various levels in India and abroad as well. Some of the things were mentioned here, like L&T Rambol, DR Group in Dubai, Covi Consultants in India and Denmark, etc. So with a total accounting to 26 years of industry experience, he is very rich in practical experience.
His areas of interest include heavy foundations, especially board cast institute piles, diaphragm walls, and deep excavations. He had handled many complex geotechnical engineering challenges, and which made him as a special in his professional career. And besides his professional activities, he is very good theme speaker, and he has been the motivational and theme speaker in conferences as well as in institutions also. He has delivered a number of industry lectures in several esteemed institutions, particularly at IIT Guwahati and IIT Tirupati also he has delivered as per my I coordinated the things. And he is a fellow of Institute of Engineers, fellow of Indian Geological Society, and also member of GFI. It's my pleasure to introduce both the chairman and co-chairman for the session. I hand over the session to the both of the members to further continue the session. Thank you.
Thank you, Murali Krishna Garu, for your nice introduction. I welcome the authors. Before that, you all know that ground improvement techniques have gained universal acceptance. Then we have encroached our weak and unsuitable grounds, and each ground responds differently to its improvement, and hence different technologies were developed to suit them. And in fact, highly challenging works like construction of airports we could build on reclaimed soils only because of the development of these techniques. And across the world, many people are interested. And since the last 2 days, we were listening to the papers on wide range of works carried out by researchers. In today's session also, let us listen to some more authors. Madan Kumar Garu.
Yeah. Thanks, Andy. Thanks,
thanks please conduct the presentations.
Yeah, sure. Thanks, Dr. Murali and Ramanamurthy Garu. Thank you very much. And he introduced me very nicely. I'm very pleasure to be here today, and it's an honor for us. And let us start our sessions. So I could able to see from the chart boxes. So, paper number 95 and 96 are available.
Madan Garu, is it possible little louder? Your voice is little low.
Yeah. So today we have, I could see in the chat box. So there are something like 10 papers are there. And in the order we will follow. So maybe I can request 95 and 96, they are there. I'll invite Mr. Saqib Wani. So
yes, sir.
Other 95, you may please start.
So maximum time limit is 5 minutes we can mention, and after 4 minutes we can give a call.
Yeah.
Okay. So is the screen visible, sir?
Yeah.
Good morning, everybody, esteemed members and the committee members and my dear colleagues and friends. My topic is stabilization of artificial soils using waste marble dust. So this is paper TH0895. So we are affiliated to National Institute of Technology, Srinagar. I'll just move on to the presentation. The presentation layout includes the introduction, objectives and scopes, the materials, results and discussions, and the conclusion part. So with the introduction, as sir already told that about the soil stabilization techniques, like chemical stabilization, confinement, inclusion, and physical methods like vibration and freeze and power. So due to the economical aspects and other adverse effects of the environment of most of these techniques, so we tend to adhere to more sustainable.
Screen is not visible. Can you share the screen?
Yes, sir. I have already shared it, sir.
Madhankar, can you see the screen?
No, sir. It is not.
I could see his name. Yeah.
Is it visible, sir?
Now it's
now it is visible. Yes.
Okay, sir.
Yeah, please continue and keep time limit now. We are nearly past one.
So due to the uneconomical aspects, we have the adverse effects on the environment. Most of the techniques they do not adhere to the sustainable practices like
So in the present day world, apart from in some extreme cases there is no alternative, we tend to find those substances that prove beneficial in both reducing the carbon emissions and side by side enhancing the properties in comparison to the conventional materials like cement, lime, and all other harmful chemicals that we have been using. So previously, researchers have used waste marble fines to stabilize lateritic soils and recommended it as a low-cost soil stabilizer. So the objectives of this study is that attempt has been made to reinforce and stabilize the artificial soils made in the laboratory by mixing different clay, that's like kaolinite that we have taken, and the dredged soils, locally available dredged soils. So waste marble dust that's produced from waste these marble manufacturing units, and it really proves detrimental in terms of both environmental, including the health hazards. So the study aim is to stabilize the soil with different percentages of waste marble dust. And in such a case, we have studied the unconfined compressive strength and the penetration resistance, CBR characteristics of the soil. So the artificial soil that has been prepared by mixing in a batch of 25 kgs, whenever the testing took place, that's 60% of that was dredged soil and 40% was kaolinite. So this was made in the lab. And they have the different properties of the soils with the respective values. The unsoaked and the soaked CBR values is correspondingly 6 and 3. The UCS is 65 kP at an OMC of 17%. So we have conducted a study analysis of the waste marble dust that shows the constituents as silicon dioxide, lime, magnesium oxides, and all the constituents have been so these all tend to provide the pozzolanic reactions that are beneficial for the increase of the soils. So the results and discussions, I'm going, the effect of waste marble dust on the UCS of stabilized artificial soils increased from 65 kPa in the untreated state to 490 kPa at 14% of waste marble dust addition. So we have used 7, 14 and 21 percentages of waste marble dust. So we have got an optimum of 14% waste marble dust at a curing of 7 days. We have also provided a curing of 14 days also. So effect of waste marble dust on the CBR of stabilized artificial soils, which resulted in an enhanced value from 6% to 18% in unsoaked condition at 21% WMB, and the soaked increased from 3 to 12% for the same conditions, that is 21% of WMB. So here is the stress versus strain plots. As we can see, as curing and the amount of waste marble dust is increasing here, we can see this is untreated sample, and this is the 7% waste marble dust at the immediate test. So as the curing is increasing and the amount of waste marble dust is increasing, we can see the change from a ductile state to a more brittle state over here. This is the 14-day waste marble dust at 7 days of curing. So similarly for variation in CBR, we can see it is increasing in from 6 to 18 at 21% MTD, and the soak percentage increased from 3% to 12%. For 4 days soaking, that's 96 hours of soaking. So coming on to the conclusions, the artificial soil that they prepared in the laboratory by incorporating different silt and clay proportions proved beneficial enough to correlate the properties of weak soils. So UCS, as I already said, increased from 65 to 490 kPa. CBR increased. We could see a 200% increase in the unsoaked condition, and 400 increase for the soaked condition due to pozzolanic reactions, most probably within the soil matrix. So inclusion of waste marble dust in general provided proved beneficial in restoring the ecological balance of the area, and thus reducing the health hazards like choking and lung disease and all the associated hazards with waste marble dust. That's it. Thank you. We have another presentation, TH96. Can I continue with this? Sir, have I the permission to continue with TH0896?
Madhur garu unmute cheyandi.
Yeah. So, Mr. Sadiq,
it can be allowed, na?
Yes, yes, we should allow. That's what I am trying to say.
Okay,
So
sir.
he is a continuous. So you please continue,
Thank
Mr.
you, sir.
Pratik. Yeah, yeah.
So this is the extension. The second paper is an extension of the same artificial soils, but here we are using, we are studying the effect of pine needles. As we all know that this Himalayan region and the Karakoram region, they all have the pines, and the most abundantly cheer pine is found on these higher altitudes. So we have made an attempt. The title is a laboratory study on the effect of pine needles. So these are basically the shredded pine needles that fall onto the floor of the forest floor. So the layout does remain the same. We have the introduction, the objectives and scope, the materials, results and discussions, and the conclusions. With the introduction part, substructure on weak soil always tends to catastrophes, and due to unavailability of ground good construction sites, so we are left with no choices as a geotechnical engineers, but we use the available weak soils for construction purposes. The researchers have recently expedited the process of reinforcing the soil with many natural materials. Like we have banana root, square, jute, hair, sisal, palm and bamboo, and etc. So previously, researchers have also used palm leaf geotextiles to stabilize slopes, like Jan Kosukas et al. 2008. So fiber stabilized stand specimens demonstrated increase in strength with inclusion of 0.561% of fibers per weight. So they were in the length of 51 mm. Researchers have provided an insight on the application of natural fibers also for synthetic materials. So with our objectives and scope, we have made an attempt to reinforce artificial soils made in the laboratory. Then the pine needles scattered on the ground, usually in the mountainous region, as I already said, prove detrimental both in terms as a waste. And an environment, including the forest fires that can take place because of this material. So this study was to stabilize rather than reinforce the artificial soil by incorporating shredded pine needles, measuring 14 to 18 mm on an average. And then we studied the compaction characteristics and the CBR characteristics. In the previous paper, we used the artificial soils with 60% of dredged soil and 40% of kaolinite. In this paper, we have used 70% of dredged soil and 30% of kaolin. So overall, the properties have changed. So this is the in the photograph you can see the figure A that is depicting the pine needles that are still intact on the tree, and B shows the pine needles that have changed color and they have dried and it is scattered on the forest floor. So the results and discussions, the compaction characteristics, because of the low specific gravity of pine needles that was calculated to be in the range of 1.2 to 1.4, the maximum dry density, which was initially 17.5 in the untreated sample, it got reduced to 15 kilonewton per meter cube at an addition of 3% pine needles. So we got an optimum of 3% of pine needles. Similarly, for CPR, at a 3% of pine needle addition, the unsoaked increased from 7% to 15%, and whereas the soaked values showed an enhancement from 3 to 9%. So here I have only shown the variation between MDD and OMC and the CBR values. Here we can clearly see the reduction from 17.5 to 15 at 3% pine needle addition. Likewise for OMC, that is from 17.5, the 18, it is increasing to 20.5. The OMC showed an increasing trend, while as the MDD showed a decreasing trend. The unsoaked CBR and the soaked CBR values similarly with the addition of pine needles at 1, 2, and 3%, 14 to 18 mm in length. The unsoaked values they enhance from 7 to 15%, whereas soaked values they enhance from 3 to 9%. So overall, depicting that this material could be used for stabilizing or rather reinforcing the weak soils. So here also the MDD showed a noticeable decrease, and whereas OMC increased from 18 to 20.5%. So this was mostly owing to the high water retention due to flock formation within the soil matrix on the addition of pine needles. So CBR values increased for both unsoaked as well as soaked conditions. So finally, inclusion of pine needles can prove beneficial in restoring the ecological balance and reducing the catastrophes of forest fires only if the pine needles are utilized in bulk. So with this, I end my presentation. Thank you.
Yeah, good. Mr. Sadiq, you finished within time, both presentations, 8 minutes.
Thank you, sir.
Yeah, thank you very much. And this is a very interesting subject, using pine needles and waste material for improving ground, especially CBR values. So, Mr. Ramanamurthy Garu, do we allow question and answer now, or should we follow?
Sir, let us complete the presentations. At the end, based on the time, we'll ask the questions.
Oh, thank you. So that is the best part. Yeah.
Okay, sir. I'll be stopping my screen share, sir.
Yeah, please do that.
Thank you, sir.
So we have one more next paper in the queue. That is the geopolymer for pavement construction, a review by Rupashree and Baidya.
Yes, sir.
So can you please start, madam?
Yes, sir. I'm present.
Yeah, please.
Is it visible, sir?
Yeah, it's visible now. You can make full screen mode. So it is 11:55 now. Please try to finish in 4 minutes, and 1 minute you can use for conclusion.
Okay, sir. Yeah. Good morning, all of you. This is geopolymer for pavement construction, a review. These are the outlines of mine. And in going to introduction, the most common soil stabilizers used nowadays are ordinary Portland cement, lime, fly ash, and fly ash is also the most important raw material used for geopolymer formation. And this table showing that 10-year record of fly ash utilization, which is nearly about 55 to 75%, from which only 20 to 25% used for pavement construction. The most construction activities in India have been increasingly shifting towards new technologies like geopolymerization due to its low carbon dioxide and greenhouse gas emission and bulk utilization of industrial waste and replacement of previously used ordinary Portland cement due to its high carbon emission in the manufacturing process. Going to my objective, to find out environmental friendly construction materials for pavement work by using waste like fly ash to beat sustainability issues. Next, typical geopolymer. Geopolymer are inorganic materials generally prepared by blending aluminum silicate with alkaline solutions, and these are three basic forms by which it forms polymeric chain. And this is the exothermic reaction and geopolymeric reaction for the geopolymer. Next, coming to factors affecting the strength of fly ash-based geopolymer. There are various factors which affect the strength of fly ash-based geopolymer. First one, effect of particle size. That is the effect of particle size. That is the finer fly ash particles gives faster reaction in comparison with the coarser particles and also gives high strength. These findings given by Kumar and Kumar 2011, Somna 2016, Murmu 2019, and so on. And next, effect of geopolymer cured at ambient temperature. That is, in this ambient temperature cured condition, to get a relatively high strength geopolymer, there is a need of high concentration of alkali activator, which is given by Somna 2016, and longer curing period, which is given by Murmu 2018, and any alternate curing temperature like sunlight or heat, which is given by Qatar. Next, coming to effect of different curing conditions. Generally, it is showing that directly exposed to heat source wipe out all the moisture from the sample, which causes a high porous and less strength geopolymer. This is given by Nuruddin 2011 et al. Next, effect of low temperature cured geopolymer. In this figure 1, compressive strength of samples at different curing duration and with the curing temperature for 7, 28 and 60 days of curing period given. If we see the figure 1, that higher temperature that is up to 120 degrees centigrade require lesser amount of curing duration. This is showing. And if we compare figure 1a to figure 1c, here we can see that low temperature cured geopolymer needs high curing period to achieve high strength. And if we go figure 2, we can see compressive strength reduced continuously when cured at higher temperature for longer curing time.
So, madam, one more minute for you. Please try to arrive conclusion part.
Okay. Types and effects of alkali activator concentration. There is various alkali activator concentration which showing that increase in strength of geopolymer occurred when alkali activated concentration increases, but it up to a certain molarity above which the strength decreases. Next, this is the effect and manufacturing process. There are various manufacturing processes from which separate mixing is the most important one and giving best result. Next, immobilization of toxic metals by geopolymer. Fast-based geopolymer capable enough for the immobilization of more than 85% of trace elements. Then effect of water addition in the geopolymer formation. Excess addition or reduction in water content cause decrease in strength. Coming to my concluding remarks, the strength of geopolymer is directly affected by the fineness of raw material, and to achieve a particular strength by curing, the geopolymer at ambient temperature needs high alkaline activator concentration. With the increase in temperature, the strength of geopolymer increases. However, it depends upon the curing duration of the sample. The strength of geopolymer purely depends upon the factors like the chemical composition of raw material, sodium silicate to sodium hydroxide molar ratio, the concentration of alkaline activator, and silica to aluminum molar ratio and additive use. Thank you. These are my references.
Thank you very much. May I kindly request you to exit presentation, and then I request now next author. We have paper number 99, Black Cotton Soil Stabilization using terrazil for its expansive nature by Krupa and Pad.
Yes, sir. I will like to share my screen here.
Yeah, please.
Yes, good afternoon, sir. So,
good afternoon.
Yeah. Yes. So we will be using a nanomaterial called terrazil to reduce the expansive nature of a black cotton soils. Yes. So we are using nanotechnology because it have a more surface area, right? So due to the highly reactive nature, we will be having a very small amount to treat the large volume of soil, because in Gujarat region we have found very expansive nature of soil, that is the black cotton soil over here in a plenty of quantities, so that natural materials can be replacing the black cotton soil and we will be having a depletion in that, right? So we will be using black cotton soil. We have referred very much in depth literature reviews, and we have found that there are many literature that uses the nanomaterials, that is with the help of fly ash cement, to treat the soil and to increase the stability as well as the strength parameters. So we have taken 3 different soil, and in these 3 different soil, these are the properties that we have. All of the soils are classified as CH, and will have a very high swelling. And to reduce, we cannot use this material as a backfilling material for road construction as well for general construction. So we will be trying to treat this soil so that we will be having soil that can be replaced, that can be used as a backfill material, as well as the expansive nature of the material can be treated, right? So we are using terrazil, which is nanochemical that is going to create a layer over the soil particles so that the water absorbing material can be replaced with the water repelling material. So instead of absorbing water, it will try to repel the water, and we will have less amount of swelling, and with less swelling we can be used that soil as a backfilling material. So that this is the chemical composition of a terrazil, which can be provided by the Zydex industry in Ahmedabad. This is a laboratory test that we have performed to get the treated as well as untreated soil. So this is the sample preparation. We will be having a soil with us. We will be mixing it with a terrazil as well as water,
and we will allow it for 24 hours so that the soil can be matured and the particle can be the coating can be done in the soil particles, so that instead of water loving soil, it will water repelling soil. So as you can see in the right side of the images, the water simply floats as it does not interact with the soil particles, and we will be having water repelling soil with us. After the compaction, that this soil can be highly water repellent, so the expansive nature itself doesn't come in picture over here. And this is the liquid limit, plastic limit, and plasticity index that is going to be reduced. Here we have used three different soil: Bhavnagar soil, Rajkot soil, and Jamjodpur soil. And we will be adding 0%, 1%, 2%, 3% of a terracotta. And with the help of that, we will be observing that the soil is plasticity index is reducing, and we will be having a very good soil which is not highly reactive with the moisture content. Here are the free swell index that is also being reduced. As you can see, it is reducing from 77.77 to 27.27. So we will be having very much reduction in the free swell index also, as well as the optimum moisture content reduces and the maximum dye density increases. So the particles are getting clubbed together, so they have a higher density and lower moisture content. So it will be very good for the compacting into the field. As the expansive nature is also reduced, we will be having a very stabilized soil compared to the previously untreated soil. And after that, we will be observing that the UCA strength is somewhat reducing, but as we are using is at a refill material, that would not be very much concern over here. And we can use the cement or fly ash so that that can be improved. And after a higher concentration of a terracotta, it will be observing that the soil are shifting from its clay nature to silty nature. So UCS mold is not, we are not able to prepare the UCS mold as it is getting broken down. Thank you, sir, for your time, sir.
Thank you very much.
Thank you, sir.
Thank you very much, Mr. Parth. You finished in very perfect time, and also interesting sample preparation. I see very interesting, and results also promising. The free swelling index is reducing up to 3% by using terrazil mix. So a good study. So may I request you to exit your presentation, and then I request next presenter. Ms. Vaidehi and Mr. Ali. So compressibility characteristics of Gurugram treated expansive soil.
Yes, sir.
Yeah. Please share your screen.
Yes, sir. Is it audible, sir?
Yeah, we can.
Yes, sir.
Yeah. Please share your screen.
Sir, is it visible, sir?
Yes. Screen is visible.
Yes, sir.
Please start now.
Okay, sir. Thank you.
Yeah.
Good afternoon to all. I'm Vaidehi, research scholar from NIT Warangal. And today I'm going to present my topic, compressibility characteristics of Gorgum treated expansive soil. This is my presentation outline. And coming to introduction, expansive soils exhibit high compressibility and low bearing capacity especially under saturated conditions. To address these issues, conventional stabilization techniques were available. Among those stabilization techniques, chemical stabilization is one of the effective method, which includes lime and cement and other materials used as a soil stabilizers. But recent studies identified that only cement manufacturing causes 8% of total old CO2 emissions into the environment, which causes adverse effects. So in order to overcome these problems, bioengineering methods have emerged and in this bioengineering methods, recently biopolymers that are produced by natural means are proposed as a soil stabilizer. These biopolymers are sustainable materials with low CO2 emissions when compared to existing conventional stabilizers. So in this study, these are the materials I have presented and used. Soil I collected near National Institute of Technology, Warangal. And for the present study, Gorgum, it is a natural biopolymer. Gorg seeds I am using. The dosages of Gorgum are maintained from 0.5 to 2.5% by weight of dry soil mass. And in this present study, the experiments carried out are a basic characterization of soil, also with the addition of biopolymer. and one-dimensional consolidation test. That is a conventional consolidation test I have done. This is the basic characterization of soil. Soil is low plasticity, low plastic clay, and the optimum moisture content of soil is 13.47%. The maximum dry density is 17.95 kilonewton per meter cube. Here, this result shows the variation of liquid limit and plasticity index of soil treated with guar gum. Liquid limit and plasticity index increased with the increase in gum dosage. Also, standard Proctor test results indicates that the maximum dry density decreased and optimum moisture content increased with increase in guar gum. This is due to the guar gum. It is a more hydrophilic in nature, so it absorbs water. So that's why the OMC increased and MDD decreased. And this is the compression curves here. Void ratio versus effective stress from the consolidation test results is presented. And this figure shows the compression variation of compression index with the gum dosage. Here it can be observed that with increase in guar gum dosage, the compression index value increased. Initially, with the increase in gum dosage, the initial swelling is also high. This is due to the absorption of water molecules. And with the increase in gum dosage, means actually this guar gum, it is having a hydroxyl ion as its functional group. So there exists a repulsion force between this hydroxyl group and negatively charged clay particles. That's why compressibility is increasing. And these are the scanning electron microscope images of untreated soil and the soil treated with guar gum. Here it can be clearly observed that guar gum strands surrounds the soil particles and they are sticking to the soil particles. Therefore, little binding will be there between those two. And coming to conclusions, with the increasing dosage of guar gum from 0 to 2.5%, the liquid limit value increased by 2 times, and OMC increased by 8%, and maximum dry density reduced by 2.15 kilonewton per meter cube. The hydrophilic nature of gum causes absorption of more water, leading to an increase in OMC and a corresponding reduction in maximum dry density values. And there exists a repulsion between hydroxyl group of guar gum and negatively charged clay particles. Therefore, compressibility values increased. And these are my references. With this, I am ending my presentation. Thank you.
Thank you, Ms. Vaidehi. So interesting presentation, and intention of the presentation is that reducing the carbon emission is very interesting, and the attempt what you made is very interesting and is required nowadays. Okay? Thank you very much for your presentation, and maybe more questions may come during our question and answer session. Now, I request next presenter. We have very interesting paper by Mr. Ramkrishna Raju, that is paper number 108, but others are not available today. So, but it's a real execution job in North India. So, unfortunately, we don't have the presenters, but we have the next paper, paper 110 by Mr. Suresh and Murugayan. So, influence of microstructural and geotechnical behavior of expansive soil using ultra-fine slag and calcium chloride. Now, Mr. Suresh Murugayan.
Hello. Good morning, sir.
Good morning.
Sir, my PPT is usable, sir?
Yeah, so it's is this the last slide? I could see something. Is this the 29 slides? Is it your presentation?
Yes, sir, mine only.
Yeah, can you go to first slide, please? Yeah. Yeah. So you, Mr. Suresh, you have 5 minutes time, but I'm not sure how you may conclude in 29 slides. So please plan your presentation.
Okay, sir.
Finish in 5 minutes. Okay.
Okay.
Thank you very much. Good morning.
I'm Suresh, research scholar from Pondicherry Engineering College. My topic title is Influence of Microstructure and Geotechnical Behavior of Expansive Soils using ultrafine slag and calcium chloride. My presentation outline is introduction, objective, scope, literature review, methodology, materials, experimental work, conclusions, and references. Introduction. Expansive soils are known worldwide for their volume change behavior due to moisture fluctuation and natural mineralogical behavior. This type of soils available in Australia, Canada, China, India, South Africa, and US. In India, 20% of expansive soils are available or in Andhra Pradesh, Gujarat, Karnataka, Madhya Pradesh, Maharashtra, and India, and Tamil Nadu. Expansive soils are extensively specific surface area and high cation exchange capacity. Expansive soil contains clay minerals such as monazite, which increase in volume during wetting. So expansive soils. So billions of dollars of infrastructural damage by the expansive soils. These are now exceeded than floods, hurricanes, earthquakes, and tornadoes. So the problems in expansive soils are determinantly cracking in of light loaded civil engineering structures. These are pavements, dams, embankments, residential and industrial buildings. So as per literature review in US, Vanapalli 2016 taken a graph in 1973 $2.2 billion per year, 1980 $7 billion, 1998 $10 billion, and 2009 $13 billion per year. So mechanism of clay water interaction. So you're having a clay soils having a negative charges on surface, and it absorbs the positive charges known as cations. It will absorb. Cations are known as calcium and magnesium, etc. Objectives: to study and evaluate the effectiveness of treatment of selected soils at different percentage of calcium chloride and alkofine. So study and investigate the strength and volume change behavior of expansive soils with calcium chloride 0 to 1% and alkofine 0 to 12%. Scope: identify the engineering properties of expansive soils, identify the physical and chemical properties of alkofine and calcium chloride, identify the physical and geotechnical properties. SEM and XRD analysis has to be conducted to study the microstructural properties of admixtures. These are the literature you has collected, sir. So only two base papers are taken. This point calcium chloride with Rice's cash, alkofine 1203, 369 percentages. So these are the materials I selected: alkofine 1203 and calcium chloride. So materials: expansive soil I was collected from Ariyankupam in Pondicherry. Alkofine I was collected from Ambuja cement in Goa. Calcium chloride. Calcium chloride is known as hygroscopic materials. It absorbs water from the atmosphere and release heat when it dissolved in water. I was collected calcium chloride from Rajendra Scientific in Pondicherry. So the methodology: I was collected soil sample. I was conducted the physical properties, index properties, engineering properties, mineralogical properties, and microstructural properties with all the values. So as per Indian standards, I was conducted the test in laboratory. In expansive soil, these are the parameters I was conducted for plain soil with liquid limit value 74.50%, with UCS is 109, and swelling potential is 36.86%, and swell pressure is 256 kPa. So these are physical and chemical properties of alkofine and calcium chloride. So I was prepared a total 12 specimens. Total S1 is a natural soil. So from S2 to S12, I prepared with addition of alkofine and calcium chloride, sir. Atterberg limits. Atterberg limits was conducted. So we're having a total ABC pictures. In A soil, expansive soil with alkofine. So liquid limit and plasticity is reduced. So B picture is expansive soil with 0.5% of calcium chloride with alkofine, and C picture is 1% with calcium alkofine. So liquid limit was reduced from 70 to from below 50%, and plasticity was reduced from 50 to 45%. Compaction characteristics. So maximum dry density is increased from 17.4 to 17.8, and optimum moisture content was reduced from 20 to 18. Stress strain curve. As per UCS values, I was conducted total 0, 14, and 28 days. So with soil plus alkofine is A slide, soil plus 0.5% of calcium chloride plus alkofine B slide, and 1% with alkofine is C slide. So strength is increased. So as per UCS value, this is my final picture. So I was getting from 109 kPa to 1257 kPa with addition of 8% of calcium, 8% of alkofine with 1% of calcium chloride. It is getting after 8%, I was reducing the UCS value. swell properties. So swell potential, it was reduced from 38 to 0 with addition of 8% of alkofine and 1% of calcium chloride. Swell pressure, it was reduced from 256 to 0 with addition of alkofine 8% and 1% of calcium chloride. So microstructure morphological studies of treated and untreated soils. So A picture is showing only plain soil, SEM and with EDX analysis. B picture with SEM with EDX analysis of alkofine. So after treated, after 28 days, I was taken the sample of soil plus 8% of alkofine plus 1% of calcium chloride. So it is SEM analysis we are showing. It is observed aggregation is forming with CSH gel and CH gel, cementation gel between the particles. And also from with EDS, we observe calcium content is more when comparing to normal soil. So
Mr. Suresh, you have 1 more minute.
Okay, sir.
Please arrive to conclusions.
So XRD analysis, we are taken XRD analysis with plain soil and highest value we are getting with UCS. So in XRD we are taking the samples. We are a formation of maximum peaks. It appear from 26 to 36 degrees Celsius. Conclusion. So as per my results analysis, the UCS is increased from 109 to 1257 kPa at 8% of alkofine with 1% of calcium chloride, and swelling behavior, swell potential and swell pressure is reduced from 38 to 0 and 256 kPa to 0. So XRD analysis we are getting, we observe in XRD and SEM analysis, CH and CHS peaks are appear into 26% and 28%. So this material is treated as a CNS layer, cohesion non-swelling soil. It will be useful for pavements, canal lining, sidewalks and floors. This is my references. Thank you.
Thank you, Mr. Suresh. Is this material what you used from Ambuja? Is it GGBFS or separate material?
Yes, sir. It is ultra fine GGBS material, sir.
GGBFS.
Yes, sir.
Okay. So we may have more questions at the end of the session. Thank you very much. You run fast within the 5 minutes. Thank you very much for your presentation. So we have next one very interesting presentation by Neha and Hemalata. So development of new grout mix using Kota stone slurry for sustainable development. So Ms. Neha and Hemalata, may I request you to start your presentation?
Yes, sir. Is it visible?
Yeah, your presentation I can see. Yeah, we can see. Please keep full screen mode and start your presentation.
Yes, sir.
Okay.
Good afternoon, everyone. My topic is development of new grout mix using Kota stone slurry for sustainable development. So this is my introduction. So why we choose Kota stone slurry for our project? So as we know, there is cement that is commonly used as binding material, and there is huge generation of CO2, which is not good for our environment. On the other hand, due to rapid industrialization, there is generation of huge amount of stone dust from stone industry that causes environmental and financial concerns. So we are using Kota stone dust as partial replacement with cement in our project. So our objective is mainly concerned to determine workability and preliminary strength parameter of grout mix using Kota stone slurry. This is the site that we have visited in Kota for Kota stone slurry. So basically, what is Kota stone waste? It is generated from Kota stone cutting process and the finishing process. So stone waste can be used in concrete to improve its strength and other durability parameters. This can be used as a partial replacement of cement, sand and coarse aggregate, maintaining the premium properties of concrete. And here we are using as partial replacement of sand. So this is the Kota stone waste which we have used. Now grouting, mainly we are concerned with the grouting. So what is grouting? Grouting is mainly consists of filling pores and cavity in soil or rock in a liquid form from material to decrease the permeability and improve the shear strength by increasing the cohesion when it is set. So these are some methods of grouting. Now use of Kota stone slurry in grouting. as I told that we are using Kota stone by replacing cement partially. Why we are replacing? Because Kota stone is limestone, and cement is showing binding property due to that lime presence. So we can use partially Kota stone replacing cement. These are some problem which is due to dumping of Kota stone waste, choking of drains in rainy season. It may cause dust nuisance, and it have fine particles of slurry, becomes airborne and causes air pollution. Slurry affects productivity of land due to decreased porosity, water absorption and percolation. Slurry dumped areas cannot support vegetation and remain degraded. So there are lots of problem. So that's we have to choose the Kota stone waste. These are some literature which we have gone through during the project. Now, objective, as I told, we are only concerned with the workability and preliminary strength parameters. So these are some tests which we have performed initially. We have performed sieve analysis test for the its particle size distribution. This is the curve, and this is the parameter D10, D30, D60, and CU and CC. Specific gravity 2.16, which we have get from picnometer for Kota stone. This is the calculation. And liquid limit we have found 43.4% for this. And now we are going for we have done this test. So this is the sample preparation. So we have used 5 mixes by replacing cement 0, 5, 10, 15 and 20%. So these are some weights corresponding to that. This is result for flow table test results. By replacing 0 to 20%, these were the water cement ratios. Compressive strength test results. So we can conclude from this compressive strength that this compressive strength is maximum of mix 3, and after that it will decreases. So from that we can conclude that our test results were increased up to 10% replacement of cement by Kota stone slurry. So then it will going to decrease. So it is adequate to replace cement up to 10% without any loss in strength. These are my references, and thank you.
Thank you very much, Neha and Hemalata. I really like this presentation. So we disturb the nature, and then we use the material sending back again into ground. So in terms of grouting, very interesting, and maintaining sustainability of our environment. Very good. And we in Keller also did similar trial in one of our projects. So we use bentonite and to reduce cement mix, but here you use the locally available Kota stone dust. So really interesting.
Yes,
so thank you very much.
In Rajasthan, in Rajasthan.
Correct. So that is how you are maintaining environment by maintaining sustainability. So vision is very good.
Yes, sir.
Thank you very much, and very interesting presentation.
Thank you, sir.
So now I invite next speaker, Mr. Prasad Sastry and Shivan Narayana. So paper number 117, influence of terrazine on geotechnical properties of clay soils. So Mr. Prasad. Paper number 117. So I could see they are available in this presentation, in this session. If they are not there, then I can go to next paper. Who are there? 118, paper 118. Sanket, Mr. Sanket, Ravikant, and Ashirvad. So the paper is in experimental study on waste tire chips, reinforced sand using cyclic plate load test.
Right, sir. I'm Ashirvad Satpathy. I'm present. I'll be presenting the paper.
Please. Yeah. Okay. Mr. Ashirvad, please start.
Yes, sir. I hope my screen is visible, sir.
Yes. Keep full mode.
Yeah. Yes, sir. Okay.
Yeah. You may start now. Yeah.
Okay. Good afternoon, all. This is Ashirvad Satpathy, an ME Structural Engineering student from BITS Pilani, and I'll be presenting my paper titled Experimental Study on the Waste Tire Chips Reinforced Sand using Cyclic Plate Load Tests. Now, coming to a brief introduction on the topic, as we all know that scarcity and availability of the suitable land for construction, heavy loads coming from skyscrapers, and the associated huge construction costs of deep and large foundations have compelled us all to resort to ground improvement techniques. On the other hand, there has been an emphasis worldwide on effective waste management and sustainable practices to alleviate engineering problems. On similar grounds, utilization of shredded waste tire chips as subsoil reinforcement has shown promising results in the past. Now, if we take a quick look at the current usage of waste tires, we see a whopping 40% of the waste tires are being used as tire-derived fuel, which raises environmental concerns due to air pollution. On the other hand, use of waste tires in civil engineering applications has shown a rise by almost 97% from 2013 to 2017, whereas its use as tire-derived fuel has reduced by 13%. Now, for some excerpts from the literature review, our co-author, Professor Mittal, has shown previously that utilization of various forms of waste tires has shown up to 11 times improvement in bearing capacity of the soil at different settlement ratio under static loading conditions. However, some other researchers have also shown that under dynamic loading conditions on granulated or powdered rubber reinforced sand, a decrease in stiffness of the reinforced soil has been shown. Now, coming to the present scope of the study, since previously it has been shown that substantial increase in bearing capacity and reduction in settlement has been shown under static conditions, this study intends an evaluation of improvement in mechanical properties of tire chip reinforced sand under cyclic plate loading tests. Also, effect of larger size of tire chips, that is 12 mm to 14 mm size, and their random continuous distribution within the soil layers are being studied. Coming to materials and test setup, the waste tire chips of 12 mm to 14 mm size and poorly graded sand was locally available at Pilani, Rajasthan. This was the test setup for the experiment. A mechanical jack, hand operated, of 50 kilonewton capacity, and the footing was machined to a size of 75 mm by 75 mm, taking into account the zone of influence of the footing. Now, as per the methodology, the unreinforced sand was loosely placed inside the tank to achieve a relative density of 30% at first. Afterwards, the desired amount of tire chip content was thoroughly hand mixed with the calculated amount of sand and placed over the unreinforced sand layers and compacted using a wooden rammer to achieve a relative density of 70%. The top of the soil was leveled and the footing was placed. Now the load was increased to a certain value and then brought down to zero to simulate the cyclic loading conditions. The tool dial gauge readings were noted, and then the average elastic settlement or the recoverable settlement was separated out for the calculation of the coefficient of elastic uniform compression. Pressure versus settlement ratio graphs were plotted, and these tests were repeatedly conducted for a varying percentage of tire chips from 0%, that is the unreinforced soil sample, to 40% of tire chip content. Now, it was observed that with the increase in tire chip contents, there was a huge improvement, there was significant improvement in the pressure carrying capacity of the soil. Also, it was seen that at 40% tire chip content, major difficulty in mixing and compaction was experienced. This could be due to absorption of compactive energy by high amount of rubber content. Hence, 40% content tire chip is not recommended for field applications and hence not shown in our test results. Now, coming to the effect on bearing capacity ratio, the rise in BCR was not that significant at 5 chip content, but there is a whopping increase of about 2.5 times in the inclusion of tire chip content, and the maximum increase in BCR was at 30% tire chip content, was up to the degree of 8.5 times of improvement. Coming to the coefficient of elastic uniform compression, it can be seen that with the increase in tire chip content, the slope of the pressure versus elastic settlement goes steeper, which indicates that higher CU values at higher tire chip content. Also, as per the shear modulus ratio, tire chip addition can lead to an increase in shear modulus of up to 1.5 times at 30% tire chip content. This could be attributed to the establishment of greater contact area and hence greater friction between the tire chip and the soil grains, which in turn leads to increase in the stiffness of the mixture. Earlier, as per the previous researchers, reduction in shear modulus in case of granulated or powdered rubber soil mixture could possibly be attributed to similar size of the both rubber and soil grain, hence hindering the proper interparticle friction and bonding. So to conclude, it was observed that tire chip addition significantly increases BCR up to 8.5 times at 30% tire chip content under dynamic loading or cyclic loading. And the optimum tire chip content was limited to 30%, beyond which difficulty in mixing and compaction was observed. Contrary to the existing results, on granulated or powdered rubber sand mixture, addition of tire chips can lead to an increase in CU and G values up to 1.5 times at 30% tire chip content. And hence, use of tire chips of size 12 mm to 14 mm average size at 30% by weight addition of the soil can be applied in field applications. However, further accurate evaluation of rise and shear modulus can be conducted using dynamic block vibration tests. So I conclude my presentation here. Thank you all.
Thank you. Thank you, Mr. Prasad, Ms. Sastry, and Satyanarayana for Mr. Ashirwad for giving for making an interesting presentation using tire chips. So, is this? I have one simple question: is this practically applicable and implemented elsewhere?
Yes, sir. It has been practically, implemented in countries, Middle East countries. Like our literature review suggests that Professor Tafreshi has done some tests and implemented it. Also, other researchers have shown promising results regarding this project. But
we may be having more questions. Right. We are running out of time. So we may be having more questions, as this being a very interesting topic and encouraging for researchers.
Thank you.
Thank you very much, Mr. Ashirwad, for your presentation, for your paper.
Thank you for the opportunity, sir. I'll stop sharing my screen.
Yeah. So we have next presenter, Mr. Vineet Reddy, Abhishek, and Saujanya. So paper number 119, influence of crumb rubber and polypropylene fiber on behavior of cemented black cotton soil. Paper 119, Vineet Reddy, Abhishek, and Saujanya.
Yes, sir. Good afternoon, sir. I'm there, sir.
Yeah, please.
Yes, sir.
Please share your screen.
Yes, sir. Good afternoon, sir. Good afternoon, everyone.
Good afternoon. We couldn't see your screen.
Yes, sir.
Yeah. Now it's getting loaded.
Yes, sir.
We could see. Please start.
Sir. Can I start now, sir?
Yeah, we could see. Please start.
Good afternoon, everyone. Today I'm going to present about influence of crumb rubber and polypropylene fiber on the behavior of cemented black cotton soils. And contents of my topic are introduction, materials, experimental methodology, results and discussions, and finally conclusions. Coming to the introduction, we know that black cotton soils are mainly known for their expansive behavior, and these are problematic soils because they show volume change behavior due to change in moisture content. Many research has been conducted to improve the properties of black cotton soils by mixing various chemicals and other admixtures. And in today's days, usage of plastic and rubber is increased. By utilizing rubber waste, we can improve the ground. Also, it can be worked as effective disposal for the waste, and it has a lightweight material, but also it has high damping efficiency, which can be used in earthquake engineering applications. And lime, as we know, lime is a traditional material which is coming from the past years, and it is increasing the strength of soil more accurately than any other material. But so here in this study we have attempted to check the effect of blended polypropylene fibers with crumb rubber on the compaction and strength behavior of lime cemented black cotton soils. And the materials we have used in this study are lime, mainly soil, lime, polypropylene fibers, and crumb rubber. And the test we have divided the test into 4 categories. First, we have treated the soil with crumb rubber reinforcement, and it has added in various percentages by weight of soil. And then again, we have treated the soils with the lime treatment to find out the optimum lime content. After that, finding optimum lime content, we have treated the soils with lime. And after that, we have treated the soil with lime, both lime and crumb rubber reinforcement. And then we have treated the soils with lime, polypropylene and crumb rubber reinforcement. Here we have taken the crumb rubber percentages by various percentages, and lime content we have kept it at optimum content, and polypropylene fiber we have chosen 0.25% as optimum from the past literature review, and length is also taken 12 mm. It is also from the past literature reviews. And these are the properties of our soil which we have collected. And from this we can see that percentage of it contains 65% fines, and it is also have high free swell index 65%. And from the IS classification, we have classified the soil as CH soil. And from the lime treatment, we can see from the graph that first the graph is drawn between lime content and pH soil. First, the soil is added at 0%, then we have increased it 1%, 2%, 3%, and up to the 4% lime content, the pH of soil is increasing. But after the addition of after the 4% lime content, with the increasing lime content, pH value is not changing. So from this lime content is here from this lime content has come as a 4%. And we have conducted Atterberg limits also with a varying percentage of hydrated lime. And from the graph we can see that after the addition of 4% lime, the liquid limit and plastic limits are also not showing any change in their values. After the 4% lime, the material is becoming non-plastic. And for the black cotton soils with crumb rubber mixtures, we have drawn stress strain curves. And from the curves we can see that at the 5% black cotton soil with mixed with 5% crumb rubber is showing highest strength but not only highest strength, but it is also showing the ductility behavior, which is very good which is very good for the soils. And from the graph which is drawn between crumb rubber percent and UCS, we can see that with the increase in the crumb rubber percent, strength of soil also increasing up to 5%. But with the after the addition of 5%, the UCS value is decreasing with further increase in the crumb rubber amount. And again we have treated the samples with both lime and crumb rubber reinforcement. And from the stress strain curves we can observe that for natural soils it is showing ductility behavior, but it has poor strength. But with after treating with both lime and crumb rubber, we can see that increase in the both strength and ductility behavior. And the samples which is mixed with 4% lime and 5% crumb rubber is showing highest strength. And we have kept it curing for 7 days, 14 days and 28 days. And we can observe from the graphs that with the increasing the curing period, the strength of soil also increasing. And after 28 days we got highest strength for the 4% lime and 5% crumb rubber mixtures. And we have drawn the stress strain curves for the soils mixed with 4% lime or 0.25% polypropylene and crumb rubber mixtures with varying percentages. From the stress strain curves we can see that with the addition of polypropylene fiber, the ductility behavior of soil is increasing. It's showing very ductile behavior, and also not only ductility, but it is also increasing their strength. And at soils mixed with 4% lime, 0.25% polypropylene and 5% crumb rubber is showing highest strength and also showing extremely ductile behavior, which is a good sign for the soil. And for the from here we can see the curing effect on the samples. And at 5% crumb rubber for 5% mixtures, it is after 28 days it is showing highest strength coming to the conclusion, as we have shown that seen that the UCS value is increasing up to 5% after the increasing the crumb rubber percentages. The strength of soil is decreasing. So we have concluded that from the results, crumb rubber percentage, optimum content of crumb rubber is 5%, and the polypropylene mixed with the crumb rubber is also showing the similar trend. The bridging effect which is created by the fibers is also impede the tension cracks, and with the addition of hydraulic lime, the black cotton soil is almost behaving non-plastic soil after the 4%. So it is, and also it is offering highest strength by addition of fibers. And from the results, it is showing that with the addition of 5% crumb rubber, the soil strength is increasing 1.4 times and 7 times the strength of lime modified soil and virgin soils. And further addition of 0.25% polypropylene, the strength is increasing about 1.3 times and 1.9 times and 9 times the strength of polypropylene reinforced lime modified soil and virgin soils. So from these we have concluded that by treating the soils with 5% crumb rubber and 4% lime and 0.25% polypropylene will give highest strength.
Thank you.
Tactile behavior.
Yeah, thank you, Saujanya. You took 8 minutes. It was interesting, and I continued listening. So anyhow, you try to arrive some optimum rubber content, something like 4 to 5%, which can yield good UCS values and strength by mixing polypropylene as well as using some cement. So interesting. Maybe we can have few more questions during discussion. But your presentation is very interesting, encouraging.
Thank you.
Yeah, thank you. And we have one more paper in the list here. So paper number 122. So others are Mr. Reddy, Professor Reddy, and Tabitha, Srikanth Reddy, and Chandranna. So paper name, effect of addition of scrap tire chips in stabilization of clay. So
yes, sir. I'm present, sir.
So Ms. Tabitha, yeah.
Yes, sir. I'm present, sir.
Yeah, please share your screen.
Yes, sir. Yes. Sir, good afternoon, sir.
Good afternoon. Please start.
Good afternoon, everyone. I'm Tabitha. I'm a scholar from Andhra University. My paper presentation is on effect of addition of scrap tire chips in stabilization of clay soils, clay sand. Contents are introduction, details of sand, details of study on soil tire chips mix, and conclusions. Introduction, cohesive soils are construction of embankments for canal beds, earth dams, and highway and railway bridges approaches. Impervious non-swelling clays are performed in clay beds and inner shells of the earth dams, whereas clay sands and clay gravels are preferred in highway, railway embankments for strength. In bridge approaches, as required, height of embankments is more. The use of clays is permitted, expected to top of 1 to 2 meters portion is filled with soils of higher strength. As the stability of embankment depends on the shear strength of a material to prevent slope failures, it is essential for the strength. It is essential to improve the strength of the cohesive soils to avoid slip failures in highway embankments. In the present study, an attempt is made to improve CBR of clay sand to make it suitable for use in construction of moderate to high embankments by stabilizing with addition of studded scrap tire chips of 10 mm and 20 mm size in portion of 5, 10, 15, and 20% by weight of soil. Details of the study. These are the properties of the soil. With the help of plasticity characteristics, it is classified as a SE sample, that is a clay sand. When coming to the bearing, the CBR value is 3.2 meters. When the CBR value is 3.2, clay sand is suitable for construction of highway embankments at the height of up to 3 to 9 meters. Up to height of 3 to 9 meters. And the soil is classified as CLs based on the gradation of plasticity characters. The soil has fine excess of 40% and poor drainage and low CBR valley soaked condition. The soil has a significant swelling as free swell index of 20%. The clay sand is suitable for construction of highway embankments up to height of 3 to 9 meters. And these are the properties of tire chips with a minimum density of 0.57 and maximum dry density of 0.64. The specific gravity of the tire chips is 1.02. The capacity of water absorption is 2.02. These are the studies of the soil tire chips mix compaction characteristics. The clay sand under study is mixed with the shredded tire chips of 10 mm and 20 mm in portion of 5 to 20% by weight of soil in increment of 5%. These are the for a 10 mm size graph and 20 mm size, where graph is drawn between dry density and water content. In both the conditions, OMC and MDD values of tire chips mix decrease with the increase of addition of tire chips. This is due to it is attributed to the lower water absorption and lower density of tire chips compared to the soil. At a given percentage of tire chips, 10 mm tire chips result is relatively higher MDD compared to 20 mm tire chip due to the better mixing of tire chip due to the smaller size of tire chip. Strength characteristics: the shear parameters of soil tire chip mixes are determined by testing parameters of 50 mm diameter and 100 mm length prepared for compaction of OMC and respective of MDDs in triaxial test apparatus. The shear strength parameters are also determined on saturated specimens is undrained condition. These are the values of the mixing from 5% to 20%. It indicates that the angle of internal friction of tire chips stabilized with the soil increased and cohesive strength decreased with the addition of percentage of tire chips. The increased angle of internal flexion is due to inclusion of coarse-grained tire chip, which are relatively tougher compared to soil. And when there is a decrease in cohesion, is resulting from a decrease in heterogeneity of a tire chip with the soil mix, increase in tire chips addition. These are coming to the CBR values. In addition of shear parameters, the CBR values of the soil tire chips are important in highway embankments application. Hence, CBR tests are performed on the soil tire chips specimen prepared at OMCs and MDs after soaking for 96 hours. These are the two graphs for the drawn at a load and penetration for 10 mm and 20 mm. Soaked for CBR values of soil increased with attained maximum values of 50. These are the values.
Ms. Tabitha, can you please come to conclusion in next 1 minute time?
Yes. The permeability of the soil tire chips, the permeability of clay sands increase. There is an increase in permeability, sir. It will perform better values. It is performed to the semi-pervious soils for nearly impervious soils. These are the coefficient of small scale addition of tire chips. The values of CO of clay sands. These are the values. Sand increase with increase in tire chips content with the 10 mm size tire chip, resulting in slightly higher values. These are the values. The results reveals that addition of 50 to 20% of tire chips are 10 mm size clay sand CU by 35 to 65%, whereas addition of 15 to 20% of the tire chips of 20 mm size resulting is increasing CU of 25 to 35% only. These are the conclusions. Optimum percentage of tire chips for stabilizing clay sand under study is 15% by weight of soil. 10 mm size tire chips exhibit better stabilization effort in clay sand under study compared to 20 mm size tire chip. The percentage improved in CBR values of clay sand under study at optimum percentage addition of 10 mm size tire chip is 65%. The clay soil under study stabilized by addition of 15% to 10 mm size tire chips by weight of soil is suitable for use in construction of embankments of 9 to 15 meters as CBR value is 5.3%. The permeability of a clay sand stabilized with optimum content of 15%. 10 mm tire chips improved by about 85%. The permeability of untreated soil. The coefficient of elastic uniform compression of clay sand under study increased by 35 to 65% by stabilizing with addition of 10 mm tire chips. Hence, the stabilization of clay sand with the 10 mm tire scrap tire chips may be considered for use as construction material in highway embankments of higher heights and also as improved foundation bed for supporting mission foundations. And these are the some references, sir, I taken. Thank you, sir.
Thank you very much, Tabitha. A very interesting presentation. So, did you have any cost comparison or constructability point of view? This particular study.
Cost is
Means,
very low. Sir.
No, 65% increase of CBR is very interesting to reduce foundation thickness. So, but construction aspect and implication of cost. So, means the thickness of CBR, thickness of foundation versus using of 15% of rubber tire chips. So, which is the better? So that you may need to think into that line maybe next time future. Anyhow, thank you very much for interesting presentation. So as of now, we have completed about 10 presentations. So we missed a few of others. So paper 108, paper 117, paper 121, 125, and 127. If any other is there, I can encourage. Otherwise, we can start.
Sir, paper ID 121 is here.
Okay, so very good. So Mr. Roy Bahadur, Sujit Kumar, and Sanjay Paul.
Yes, sir.
Please welcome. Your paper is importance of verticality of PVD in consolidation settlement of PVDs.
Yes, sir.
So,
yes, sir.
Yeah. So Mr. Bahadur, Mr. Roy Bahadur.
Sir.
Yeah. Please.
Good afternoon, sir.
Yeah.
I'm Rai Bahadur from NIT Agartala, Tripura. So today's topic is importance of verticality of PVD in consolidation settlement of prefabricated vertical drain improved subsoil.
So, Mr. Bahadur, we can't hear your voice.
These are the content.
Yeah.
So here is the geosynthetics made up of 2 by geotextile, and the structure of the core are different. So types of PVDs are made. So in the left figure, what we have seen is without vertical drain, movement of pore water is only in vertical direction. But when we provide PVD, movement of water occurs in both directions, horizontal as well as vertical direction. So here was the PVD I bought from the market. And here is the typical cross section, Agartala Dhaka railway connection embankment. So here, spacing, depth, length, and construction periods are different for different projects. Here is the picture I bought from a field, Agartala Dhaka railway connection. Here I have observed that verticality cannot be maintained properly. This may be due to faulty machines or other manually default. So I thought we should go for a laboratory experiment to check whether the verticality of the PVD has the effect on consolidation or not. So here is the objectives: adverse effect of inclination and time effect on consolidation settlement of silty clay soil. This is my model setup. Height is 60 cm, diameter 452 mm. Materials are only two: silty clay soil and PVD. So here are the properties of soil, and this is for PVD. My PVD is corrugated group PVD. So here we can see I have dislocated the PVD from the center line as X, and the test procedure is load was imposed with 10 kilopascal, and time interval is 7 days up to 63 days. So test was conducted on two conditions. One is vertical PVD and the other was tilted or inclined PVD. And results were compared. This is the figure where we can see that I have shifted the PVD 5 centimeter away from the center line. So the ratio of height to shifted distance is 12.
మంచి టాపిక్ తీసుకున్నారు బట్ టైం లేదు మనకి క్వశ్చన్స్ ఎక్కువ అడగడానికి టైం ఉంటే అడిగేవాడిని అన్నాడేనా డిస్కస్ చేసే వాళ్ళం కొంచెం టాపిక్ గురించి బట్
may I suggest somebody please mute who are not there in the presentation.
Here in my study constant. So result of consulted PVDs are compared. We can see from figure 7, the upper graph is curve is for untreated soil. It doesn't have shown tremendous settlement, but for tilted PVD and vertical PVD has greater settlement, where we can see that tilted PVD has greater rate of settlement at the very beginning, but ultimately vertical PVD has shown the maximum settlement compared to tilted PVD. So the reason may be the action of force. From the figure we can see that flux of force is greater in front side compared to back side. So due to this, pressure will be more in front side. So movement of pore water also will be more in this side. So at the very beginning, movement occurs very rapidly. But after a few days, due to this rapidness, that clogging occurs in the upper portion of the PVD. So this clogging is for due to entrance of the particles of silty soil. Also, we can see buckling occurs in the upper portion. So ultimately, movement of pore water rendered. So here is my conclusion that we should maintain the verticality of the PVD during the construction of PVD in the field. This is more important in the case of high budget project. However, for small budget projects, it may not be a big concern. These are my references. So I conclude my PPT here. Thank you, sir.
Thank you, Mr. Rai Bahadur. Interesting and it's a laboratory study. So we may need to have more discussions. Yeah. So, Mr. Murthy garu, so we have two more requests, but we have session need to close at 1 o'clock. But I got two more requests, two more papers. Shall I allow two papers?
3 minutes we can allow, sir. 3 minutes we will allow them.
Yeah. So then I have highlights. Thank you, sir. Thank you. So I got request from paper 125 and 127. So ground modification techniques for deep soft soil sites in Goa region, Roshni and Purnanam sir. And then paper 127, strength characteristics of Kuttinadu soil stabilized using biopolymer. So Mr. Mohan and others. So these two others, may I request you to conclude your papers within 3 minutes so that we can have another 10 minutes discussions on these interesting papers. So first I can invite paper 125, Roshni.
Yes, sir.
Yeah, your screen is seen. You can keep in PowerPoint present mode and then you start and keep time very tight because you have 16 slides.
Okay, sir.
Yeah, please start.
Good afternoon, everyone. My name is Roshni. I'm a postgraduate student studying in Goa College of Engineering. So the topic of my presentation is ground modification techniques for deep soft soil sites in Goa region. So one second. So as we know that the world is witnessing an escalated rate of infrastructure development, hence it is very much necessary for ground modification where we encounter soils having low bearing capacity. And also the soil in its natural state may not always be suitable for construction. It is highly inadvisable to carry out construction activities on soft soils as it often leads to failure of the structure caused by inability of the soils to hold the loads of heavy structure. So this is my literature review. I'll as there's time limit, I'll come to my main work. So this is a map showing different sites in Goa, and the borlogs are marked in red. So case study, site 1. This site is in North Goa, which is located right next to a lake. So here a G+1 RCC structure is proposed to be built over an existing platform which was built previously, and the borehole was drilled up to a depth of 19.5 meter from the ground level, considering the fact that the site is right next to a lake. So the safe bearing capacity of the soil was found to be 285 kilonewton per meter square. This is a pictorial view of the building where two columns, or as in where two rows of columns are proposed. The first row of the column rests on the platform itself, whereas the second row of the column rests on the in the sloping portion where the lake is adjacent to the structure. So the ground modification recommended over here is to stabilize the soil beneath the footings of G+1 RCC structure. The soil should be excavated up to a depth of 3.5 meter, and a layer of hard lateritic soil of 60 centimeter should be placed and well compacted below each footing. Also, a plain cement concrete layer of 20 centimeter thick of grade M10 is recommended to be placed over the 60 centimeter of hard lateritic soil. All the columns should be connected to the plinth beams once the footings are completed. Secondly, considering the fact that the second row of the columns is right next to the lake and also in the sloping portion, it is advisable to construct a cut-off wall extending the plinth beam connecting to the column by about 0.8 meter, and also providing a vertical small RCC wall which goes into the soil existing in the sloping portion by a meter. Coming to site 2, which is located in South Goa. Here a mid-rise building was proposed to be built at this site, and the soil encountered here is soft silty sand. This is a bore log which shows that soft silty sand is encountered. There was no hard rock stratum encountered beneath, and also water table was encountered at a depth of 1 meter, hence dewatering was also carried out. So I would like to highlight that these are the existing real sites where the work is already being implemented and it is also functioning well. So here the ground modification recommended was ground modification using sand compaction piles was recommended. It was also recommended to use a non-vibratory sand compaction pile as the vibratory equipment causes vibrations and noise pollution. Also, effectiveness of this technique was measured by carrying out standard penetration test and dynamic penetrometer test. So, cohesive soils can be effectively densified using sand compaction piles. And the basic principle of this method is that it causes lateral deformation of the soil, displacement of the soil, which results in densification. Coming to site 3, this is located in North Goa, and here a low-rise building was proposed. So the borehole was terminated at a depth of 15.2 meter. Since low-rise building was proposed, we need not go for deep ground modification. Only shallow ground modification will be sufficient.
So the safe bearing capacity here was found to be 150 kilonewton per meter square. The ground modification recommended here was, it was recommended to install wooden piles of 15 centimeter diameter and 3 meter long to be driven at 1.5 meter center to center both ways, and where there are more heavy loads, the spacing can be reduced. The effectiveness of this technique could be measured using plate load test. Coming to site 4. So this is in North Goa at Vasco. Here a high-rise building was proposed and the groundwater was encountered at a depth of 2.5 meter. Clayey sandy silts were encountered. The borehole was drilled up to a depth of 40 meter, but still there was no hard stratum found. And the safe bearing capacity of this site was 150 kilonewton per meter square. Hence, ground modification recommended was a combination of ground improvement technique of deep soil mixing supplementing vibrostone columns could be an effective solution for improving ground conditions. So by evaluating the subsurface stratum, it is suggested to opt for deep soil mixing for a length of 8 meters to 15 meter. And over this, it was suggested to after the deep soil mixing, a firm base was created for the stone columns to rest over it. And over the deep soil mixing, which was done from 8 meters to 15 meters, over that the stone columns were placed from 1.5 meter to 8 meter. And over that, a raft foundation was placed for the structure to rest. Coming to site 5. Here, a mid-rise building is proposed to be built, and the borehole was terminated at a depth of 10.12 meter. So, groundwater was encountered. This is a marshy land, and here the groundwater was encountered from 3.5 meter to 4.5 meter depth. So, the calculated bearing capacity found here was 7.9 tons per meter square. The footing was proposed to be built at 2 meters, and here the isolated footings were proposed to be built. Ground modification recommended was a composite hybrid system of ground modification was recommended, which was a combination of vibro stone columns and also dynamic consolidation. So providing stone columns in the entire area could be an uneconomical solution. Hence, it was proposed to concentrate the stone columns only under the footings to control the differential settlement at a depth up to which hard stratum was encountered. The stone columns were supplemented with dynamic consolidation to densify the remaining area surrounding this site. So after the completion of stone columns, dynamic consolidation was performed over the entire treatment zone in a grid pattern. So dynamic consolidation is an instantaneous process and occurs faster as compared to static consolidation. So coming to the conclusion, these ground modification techniques were recommended for different sites depending on the type of soil encountered, like silt, clay, also the position of groundwater table and depth of soft soil layers. In addition to standard methods like vibrocompaction, dynamic compaction, newer techniques like microbial induced carbonate precipitation was also studied. So I'll just tell in brief about microbial induced carbonate precipitation. Hence, we know that microorganisms reproduce. It forms minerals. So, okay, sir. It forms minerals. So,
Roshni, others have already covered those aspects. Please limit your presentation. And anyway, you have already explained the different techniques suitable for different site conditions.
પ્રોપર્ટી છે ને એના પર આધાર રાખે જનરલી 10% થી લઈ એટલે 85% થી લઈને 90% સુધી લોકો કરે આમ તો કેવી કેવી પ્રોપર્ટી એના પર આધાર રાખે એવી પ્રોપર્ટી હોય કે મેં ધારો કે આખું મેલ બનાવી દીધો હોય તો મેલ ખરીદનાર કોઈ નહીં મળે તો એની વેલ્યુ એ ઓછી પણ લેવાય એમ
Mr. Vikesh Vimala, can you mute your mic, Mr. Vikesh?
So Roshni, your presentation is very good, Roshni, and is all case studies. I am really impressed as a practitioner. So let us
thank you, sir.
Move to the last presenter, Mr. Mohan or others.
Yes, sir.
Paper number 127.
Sir, am I
Please
audible?
restrict yourself. Yes.
Okay, sir. Good afternoon to all.
પણ એના કરતા
Sir,
ફરી
my
છે ને
screen
તાર થોડી
visible?
કિંમત જ વધારે દેવી હારી પડે રિયોઝેબલ 5% તો કોઈ નહીં આપશે લોકો ફરી
Is it
પાછળથી
visible,
5%
sir?
ની કરો તો એમ 10% કરાવશે 5%
think
તો રિયલાઇઝેબલ વેલ્યુ લખવામાં તો
Vikeshજી,
ફૂલ બી લખી શકાય
somebody-
એમ છે કે નહીં મારા હિસાબે આ જ વેલ્યુ એ છે
Mr. Yeah.
Can I start, sir?
Please.
Okay.
Please, you start, please. Yeah.
Okay, sir. So good afternoon to all. Myself Raji P. Mohan and my co-author is Adarsh P. And we are here to present on topic strength characteristics of Cottonade soil stabilized with a biopolymer guar gum. And this is the presentation outline. So coming to introduction, so Cottonade soils are soft organic clays or clay or silt deposits found in the Cottonade areas of the Alappuzha district and it's having low strength and high deformation characteristics. So it has reported so many failures in the past. So treating this soil with using stabilizing agents is the economical solution that is available and that can reduce the construction cost and improve the performance. But the production of cementitious materials, which is used as a traditional stabilizing agents like cement, lime, fly ash, rice ash, etc., involves high carbon footprint and high energy demand, and that can lead to global warming. So the research has led to development and usage of non-traditional additives like bioenzymes, nanomaterials, biopolymers, etc. So these are the literatures which I have reviewed. So the previous studies have shown that Cottonade soil is having high clay and or silt contents and having liquid limits very high, and which indicates that the soil is having high expansive or shrinkage characteristics with low shear strength. So studies are being conducted for effective stabilization of Cottonade soils by imparting some desired characteristics, but they are not conclusive as the technologies are not that they have not done the all the studies, that is durability studies, microstructural studies, etc. So the results are not yet conclusive. The objective of this study is to determine the strength characteristics of Cottonade clay soil treated with varying contents of biopolymer for varying curing periods, and to find the optimum percentage of the additive which can give maximum compressive and CBR strength. So this is a methodology adopted. The biopolymer which is used in the study is guar gum. It is a galactomannan polysaccharide extracted from guar beans, and it forms a viscous colloidal solution when mixed with water. The dosage which is used in the study is 0.5, 1%, 1.5, 2, and 2.5% of dry weight of soil. This is an untreated soil characterization. The soil was collected from Champakulam area of Cottonade region, and is having UC strength of 93 kilonewton per meter square, and CBR strength also low, and it is classified as CH according to class T chart. Now the soil has been treated with the different percentage of biopolymer. It is cured and tested for finding the compaction characteristics after 7 days of curing, and UC strength characteristics after 14 and 28 days of curing, and CBR strength after 14 and 28 days of curing. So first one, the influence on compaction characteristics. And as we can see, as the guar gum content increases, the maximum dry density decreases and optimum moisture content is found to be increasing. Increasing the solution concentration of guar gum increases the viscosity, and thus it fills the space between the grains, the soil grains, and this inhibits the particle interaction, and these soil grains will move away from each other, thereby increasing the overall pore volume, decreasing the dry density of the modified soil. The optimum moisture content increase can be attributed to the increase of absorbed water consumed by the increased biopolymer. Now coming to influence on UC strength characteristics, it can be seen that as the guar gum content increases, the UC strength also increases, and it has after 28 days of curing, it has reached to even 2.8 times the untreated UC strength value, and the optimum dosage of guar gum is found to be 1.5% of dry weight of soil. The biopolymer is directly bonded to these clay particles via cation bridging and hydrogen bonding, which leads to higher strength enhancement with less aggregation and fewer voids. But beyond the optimal dosage, the UC value decreases due to higher viscosity, which results in lack of bonding between clay, guar gum, and water mixtures. Now coming to influence on CBR strength, here also as the guar gum content increases, the CBR strength is found to be increasing, and the value increased till optimum content of 1.5%. Both soaked and unsoaked CBR strength increased by about 5 times the untreated strength values.
Now coming to conclusion, the soil is taken from Kuttanad region, the Sambakulam area of Kuttanad region, and it is classified as clay of high plasticity, and the optimum dosage is found to be 1.5%, which gave maximum UC strength and CBR strength. With the addition of biopolymer guargum, the maximum dry density decreases and optimum moisture content is found to be increasing. The UC strength improved by about 2.8 times the untreated strength, and CBR strength increased by about 5 times the untreated CBR strength. So hence, guargum is found to be an environmentally friendly additive which can be used as a soil stabilizing agent. Though further studies are needed to be conducted on the and durability characteristics of treated soil. So these are my references.
Thank you, Ms. Regi. Interesting presentation, and once again, thanks for respecting our request for maintaining time. So thank you very much for your presentation. So coming to now, we already overshoot by 20 minutes, and we need to close the session in another less than 10 minutes because we have to have another session at 2 o'clock. So, Mr. Murthy, we can encourage audience. There are about 60, 70 audience are there. They can interact with the presenters. So
at least one or two questions.
Yes. So I congratulate first the others who came forward to make these presentations, and papers are very well prepared and very well delivered. So total 13 papers we delivered today, and intention of every other, maybe the professors who are behind the research, environmental protection and sustainability is very well respected, and so this is the importance of the hour. So ground improvement technologies and all, and also, so I was very much impressed that to respect our environment. So locally utilized materials are being used and utilized in research and development. So that is very well taken care. So Ramanamurthy Garu, please take over now.
Yeah, if there is anybody who can ask one or two questions, we can encourage so that it will give completeness.
So any questions from audience, participants? So I have one question for Roshni. So is Roshni available?
Yes, sir.
Yeah. So Roshni, your presentation I like very well, being a practitioner. So you presented total 5 case studies in very short time. We requested 3 minutes by you presented almost like 8 minutes. I continued listening. So only one question from my side. So you used wooden piles, okay, like timber piles as one of the technique. So other one is sand compaction piles using non-vibratory technique. So these are real case studies, and did you see any time visiting sites, or did you see what are the troubles faced at site?
So yes, the wooden piles which were installed, it is practically done, but the other technique, that is sand compaction piles, it is not yet done. The work is going on.
Okay.
Yes, so it's not yet being executed.
So only one query from my side is that so you have water table, high water table, and
Yes, sir.
and you are going to use sand. So flowability of sand and the compactability of sand is definitely a challenge. So
Yes,
that need to be addressed. So the moment when you presented that particular technique, I got that particular this one. Otherwise, I like your presentation. Thank you very much.
Okay, thank you, sir.
Okay, sir. If there are no questions, we will summarize them.
Yeah.
In fact, if at all we can summarize the whole works, it is very interesting that everybody is enthusiastic to present. Based on my observations, most of the people have tried to utilize alternative materials like marble dust pine needles, geopolymer, terrazil, gum, ultrafine slag, then quota stone dust, waste tire chips, crumb rubber, polypropylene fibers. All these are alternatives to the traditional materials. The only observation I could make is that none of them could come out with the mechanism of the stabilization. If at all they could concentrate on that, and again, in civil engineering, after doing research, we have to establish the cost effectiveness of the technique. That is also almost missed by the authors. If at all these two aspects are added, these works can be very appealing to the society. So I suggest the authors, it seems most of them are young students, they can concentrate in this direction also to add few lines so that the technical presentations become more attractive. And of course, the case studies presented by Roshni are very interesting. And again, Rai Bahadur, verticality of PVD presentation, that is also interesting. Of course, kinking of the drains was already there. In literature says kinking effect is limited, but however, he says there is some effect. More study is required. Okay, with this, I am concluding and handovering the session to the organizers.
Thank you, Professor Ramanamurthy Garu, and thank you, Madan Kumar Garu.
Welcome, Andy. Thank you.
Very well coordinating the session and organizing the session. I understand total out of 15 papers, 13 papers were presented. Am I right, Madan Garu?
Correct. You are correct.
I think 108 and 120, 108 and what others were missed? 117.
117. So two papers are not presented. Yeah.
Yes.
108 and 117. Two
correct.
are not presented. Okay. Thank you very much. And yeah, I appreciate Professor Ramanamurthy's point that financial things and practical mechanism aspects, I think these to be focused. And very interesting papers to a lot of good presentations we can see. Okay, with this, I conclude. Thank you very much for organizing the session. Formally, I applaud to both the chairs and co-chair and also all the speakers who presented their works and maintained the time. That is one good thing. I appreciate all others. With this, I announce the end of the session. So we'll meet again in the next session. I think Professor Satyanarayana Reddy would like to add some comments. He is also there. Satyanarayana, over to you.
Okay. Yeah. Thank you, Professor Murali, for effectively coordinating the session. So not only for this, you have been helping me a lot, right, for organizing this event. I thank Professor Ramanamurthy for sparing his time and chairing this session, and Sri Madan Kumar from Kellar for supporting us as co-chair for this session. So both chair and co-chair have effectively managed the time, though many papers are there. So with their good remarks and all. So I thank you all for everything. I thank all the participants for attending this technical session. I congratulate the others for their good works and presentations. So thank you all. Now we'll break for lunch, and again the next session commences at 2 o'clock. Anything to say, sir? Professor Murali?
I'm just asking what time is it? 2 o'clock or is little?
No, 2 o'clock only, sir.
Okay, fine.
So that
we can come at 2 o'clock.
Okay, sir. Thank you.
Bye bye. Thank you.
Thank you very much. Thank you very much, Professor Reddy Garu.
Bye bye.
Thank you. Thank you very much.
Thank you. Thank you for your wonderful support.
Thank you.
Reddy Garu.
Sir.
Full meals. It 10 half an hour surplus, sir.
This is what we can do.
వరంగల్ కి పంపించండి సార్, మీరు కొట్టండి, మేము క్యాచ్ పడతాము.
వెరీ గుడ్, మీరు డైలీ మాత్రం మెనూ మాత్రం బాగా పెడుతున్నారు. వెరీ గుడ్.
రోజు అసలు అది చూస్తే ఆకలి మాకు దంచేస్తుంది ఇక్కడ ఆకలి.
ఓకే సార్, సీ యూ ఇన్ హాఫ్ అన్ అవర్.
ఓకే సార్, ఉంటాను సార్.
థ్యాంక్ యూ.
చేశారా? షేర్ మీరు విండో పెట్టారు, షేర్ స్క్రీన్ చేయలేదు. మీరు మామూలుగా పీపీటీ షేర్ చేస్తారు కదా, అది షేర్ చేసేయండి. ఒక్క నిమిషం ఆగు. స్లైడ్ పెట్టండి, స్లైడ్ పెడితే వస్తుంది, ఇది రాదు. దీంట్లో లేదా స్లైడ్? అదే అదే అవును.
ఎందుకంటే ఇంకా బోల్డ్ టైం ఉంది కదా 2 o'clock కదా మేము ఎవరో ప్రిపేర్ అడ్మిట్లే కదా మీరు చేస్తాను త్వరగా తినేసినండి అంతా
ఈరోజు ఏం తినకపోతే ఏం నష్టం లేదు. మీరేం చేస్తారు?
Good afternoon, Sai Babu garu. Good afternoon, sir. You are on mute.
గుడ్ ఆఫ్టర్నూన్ మాస్టర్ గుడ్ ఆఫ్టర్నూన్
గుడ్ ఆఫ్టర్నూన్ గుడ్ ఆఫ్టర్నూన్
బాగున్నారా
బాగున్నాం సార్ మీరు బాగున్నారండి
బాగున్నానండి బాగున్నాను
ఓకే ఓకే So our session starts at 14 hours and closes at 15:45.
Yeah.
We have 1, 2, 3, 4, 5, 6, 7.
12 ఉన్నాయండి 12 పేపర్స్ ఉన్నాయి
12 papers are there, yeah.
అది వాట్ వి థింక్ ఈజ్ 15 minutes ఒకదానికి సరిపోతుంది కానీ విల్ గివ్ 12 minutes ఫర్ దెమ్ 2 to 3 minutes ఫర్ ది క్వశ్చన్ అండ్ ఆన్సర్స్ ఎందుకంటే ఒకరి నుంచి చేంజ్ కావడానికి ఒక నిమిషం పడుతుంది కదా
Sure.
So we'll say that 12 minutes is at your disposal.
Yeah.
ఏమంటారు సార్
Yeah, maybe actually
10 పెడతామంటారా హౌ డు యు సే 10 పెడతామా
హలో అండి గుడ్ ఆఫ్టర్నూన్ యు ఆల్
గుడ్ ఆఫ్టర్నూన్
మురళీకృష్ణ గారు
గుడ్ ఆఫ్టర్నూన్ అండి
గుడ్ ఆఫ్టర్నూన్ ఐ థింక్ మీరు ఇంతకు ముందు సెషన్స్ చేసినారు కాబట్టి ఇలా ఎలాగ 10 minutes ఇద్దామా 12 minutes ఇస్తామంటారా
లేదండి 5 minutes ఇచ్చి విల్ టేక్
అంటే వీళ్ళు 1.5 hour ఉంది కదా 180 minutes ఉన్నాయి
అవునండి అంటే
12 ఉంటే 12 తో డివైడ్ చేస్తే మనకు 15 minutes వస్తుంది అట్లీస్ట్ 10 minutes ఇవ్వచ్చేమో అని అనుకుంటున్నాను
10 minutes ఇస్తా అంటారా
అంటే యూ జస్ట్ థింక్ ఓవర్
అంటే తర్వాత డిస్కషన్స్ ఏమైనా పెట్టొచ్చు
ఓకే
we are maybe you can just think of we are giving to other people
5 minutes
6 alaga
okay we will continue that let us not have a special privilege to our
sir good afternoon to all of you
good afternoon Satnarayan Reddy garu
since we'll be giving prizes so better let us stick to more or less uniform time sir so the extra discussion we can allow as Murli
okay we'll go with the 5 minutes only sir
okay 6 minutes you can say no problem
6 minutes yeah
anyway they will take 5 to 6 so 6 minutes
yeah we will mention 5 to 6 మీరు అన్నట్టు 5 to 6 అని చెప్దాం right అది ఆ టైం కాగానే shall I announce that time is getting up
so time I will manage sir I will invite
Madan Kumar garu please do that
yeah I'll invite and then I will coordinate timing and all I will keep on inviting papers and then before that we request participants who are available and they can text
exactly
availability so that's what previously Mr. Professor Murali did I think that is a good idea so participant please text your availability with the paper number so it is easy for us to coordinate and inviting you for like delivering your papers and then what we do I will keep on watching time and then I will conclude that particular paper and then invite the next paper so that protocol I will follow and then end of the session we will invite discussions any questions and all and then we can hand over to Professor Murali.
Fine.
Okay. Reddy garu, you want to make any announcement?
What could be my job?
So you will watch everything and then you have to conclude.
So seriously watch and observe it. Huh? Very good, sir.
Yeah, can you hear me?
Yeah, I can hear, sir.
Reddy garu, you want to make any announcements, any starting things, so that I will take up the.
You can proceed, sir. No problem.
Okay.
Yeah. Fine.
Okay. So good afternoon, you all. Welcome back to the last technical session of the conference. So after this, we will be having the valedictory session. So we are here for the theme number 8 and session 5. The last session of the theme number 8. We already completed one session on the first day and 2 sessions on the second day. And today morning we completed one session and this is the 5th session on theme number 8. This is the theme number 8 on development in ground improvement. Is the largest theme in the whole conference. We have many papers in this one, so it's spread across the whole conference event. There's one big active theme of this conference. So I am the session coordinator as the Murali Krishna from IT Tirupati. So we have as a chairman Professor Sai Baba Reddy from Hyderabad and Sri Madan Kumar from Keller. So these are the papers scheduled in this particular session. Total 12 papers are there, right? I request others, whoever are available for presenting their paper, please type your paper number in the chat box. And also, if possible, you can also rename yourself with reference to your paper theme paper number. So it will be good to identify also, that is also possible. So please key in your paper number, whoever is available for presentation. So let me welcome our chairman, Dr. E. Sai Baba Reddy Garu. He's from Hyderabad. Let me, it's my pleasure to give a formal introduction to him. Professor Sai Baba Reddy, he's a professor of civil engineering and also he served as a principal in DNTU Hyderabad College of Engineering. He retired and he's having a vast teaching experience of about 34 years of teaching experience. He obtained his ME honors from IIT Roorkee and PhD from UK from Nottingham University. And he also had a couple of postdocs, one from Canada and another from UK. We can see his international exposure from his doctoral study and postdoctoral study. He is a dedicated teacher, active researcher, consultant, and eminent administrator, and proven in all roles. And he has served in various academic and administrative positions, including as a vice chancellor of Veer Surendra Sai University of Technology in Odisha. He has guided about 9 PhD students already, and 3 are in progress. And he has published about 150 plus technical papers in national and international journals and conferences. He also authored 5 books. He received several awards. A few are listed here, particularly UGC scholarship, and he received Commonwealth Scholarship for UK, Commonwealth Fellowship UK, and Postdoctoral Fellowship. And one good thing, notable achievement from him is the ASTM Award for Outstanding Research Paper published for the year 1998 is a outstanding thing, is outstanding contribution, we should say. And he also received the Samsher Pekas Research Award in 2002. And he is a Engineer of the Year Award from Government of AP, Institute of Engineers for the year 2009. He also received as a Best Teacher Award from Government of Andhra Pradesh for the year 2012. So with this, I welcome you, Professor Sai Baba Reddy Garu, to chair the session. Let me, yeah.
Thank you very much, Murali Krishna Garu. Thank you.
Let me invite Sri Madan Kumar as a co-chairman of this session. Now, he is having a vast professional experience working with the Keller Group from the last 10 years. And before that, he had worked 16 years at various levels in different agencies, including L&T and DAR Group in Dubai, Covi Consultants in India and Denmark, etc., with a total experience of 26 years. His areas of interest include heavy foundations, especially board cast in situ piles, diaphragm walls, and deep foundations. He has handled many complex geotechnical engineering challenges, and he is a very good motivational and themes maker, particularly in various conferences. He has also delivered a number of industry lectures in several esteemed institutions. He is a fellow of Institute of Engineers and fellow of Indian Engineering Society and member of GFI. With this introduction, I invite again Sri Madan Kumar to take over the session as a co-chairman, and I hand over the session to both the chair and co-chairs for conducting the session. Thank you.
Thank you, Professor Murali. Thank you. Thanks for the introduction. So here we have 12 papers out of 12. So we got responses from participants, almost like 11 responses I got So except paper number 147. So it's a very good response. So all presenters, paper presenters are available, others are available. So I'll invite one by one, means in the order. So shall we start now? Inviting.
Yeah, you can just give the time scale also, sir.
Yeah. So others, please, as Professor Murali explained, I will be maintaining time. So you are given 6 minutes time. After completion of 5 minutes, I will give you an indication that in next 1 minute you need to close your presentation. So after that, I will go to next paper. So question and answers we shall keep at the end of the session. So please keep whatever the questions you have, please keep with yourself, and then we can have discussions. Okay. So with this background, shall I invite paper number 128, Mr. Vijay Kumar and Ganesh Kumar. Paper, yeah, Mr. Vijay Kumar.
Sir, shall I share the screen, sir?
Yeah, please share your screen.
Yes, sir.
So this paper is on confined reinforcement barrier system for mitigating generated ground motions in liquefiable soils. So Mr.
Yes,
Vijay Kumar, please.
Sir?
Yeah.
Sir, is the screen visible?
I can't see Mr. Vijay Kumar. Yeah.
Is it visible now?
Yes, yes. We can see. We can see, and you please.
Yeah, is it visible, sir?
Visible. It is visible. Perfect.
Yeah.
Please
Yeah.
start.
Okay, sir. So, good afternoon. Good afternoon, everyone. This is Vijay Kumar, MTech Earthquake Engineering from IIT ISM Dhanbad. I was guided by scientist Dr. S. Ganesh Kumar from CSIR CBRI Roorkee. I would like to present the paper on the topic confined reinforcement barrier system for mitigation of ground motions in liquefiable soils. Sir, as we know, earthquake-induced ground motions leads to liquefaction in loose saturated soil deposits, and as a result, many catastrophic damages have been caused to infrastructures located in near-fault regions, particularly in saturated cohesionless soils. So, as far as now, stone column reinforcement have been widely used in this liquefaction mitigation, which basically use the principle of effective drainage and densification to strengthen the saturated loose soil deposits. But the attenuation of seismic ground motions is least considered in stone column reinforcement. Mainly the stability is of main concern, whereas the attenuation of seismic ground motions is least considered. And also the sustainability of this stone column reinforcement under repeated earthquake loading is highly challengeable, because there are not been that much studies in under repeated undrained loading. So we thought to develop an alternative reinforcement system which is more renewable and more sustainable as compared to stone column reinforcement in liquefaction mitigation. So, sir, just think, what if we can develop a reinforcement system that can effectively offer soil densification, confinement, vibration isolation, foundation stability, seismic energy dissipation, pore water drainage, and also the enhanced sustainability and renewability of reinforcement system. So, for this purpose, we thought to introduce an alternative reinforcement system made of polyurethane foams. Polyurethane foam is highly known for its resilience and vibration absorption characteristics. We created a polyurethane foam barrier, and we placed in a liquefiable soil ground model, and we tested for its efficiency in liquefaction mitigation. The primary objective of this study is to compare the performance of both PU foam barrier reinforcement and conventionally used stone column reinforcement when they are subjected to repeated undrained loading condition in liquefiable soils. So, the preparation of PU foam barrier. We procured the PU foam. We actually procured a polyurethane foam liquid for the construction of PU foam barrier. The liquid consisted of resin and hardener. We mixed it in ratio of 1:1. It had a volume expansion factor of 30 times. The foam barrier was casted in a T-shaped molds, and in order to prevent soil after casting the barrier, in order to prevent the soil intrusion during the dynamic loading, we just covered the PE foam barrier surface with geotextile material, which just prevents the intrusion of soil and foam. Two inverted T-shaped anchor barrier models were prepared, and the prepared model was in the form of inverted T-shaped inverted T shape in order to provide effective anchorage and in order to resist the vertical uplift motions during the dynamic shaking. The dimensions of the dimensions of stem, heel, and toe the dimensions of stem, heel, and toe was 300. 300, 200, and 100 respectively, with uniform thickness of 50 mm all over and a length of 500 mm. So basically, we just conducted experimental test in we just conducted experimental laboratory test in shaking table facility at CSIR CBR Roorkee, sir. The soil selected for this study was Solani River soil from Solani River soil from Roorkee, Uttarakhand. The basic laboratory experiments were conducted, such as specific gravity, sieve analysis, etc. And based on that results, the soil was classified as poorly graded sand as per IS classification 2720. And the gradation curve for this soil was found to fall within the potential liquefiable limits as proposed by Suchida, which further verifies that the soil is potentially liquefiable. So basically, sir, the experimental tests were performed in three schedules. The first schedule was with unreinforced model ground. The second schedule was the model ground reinforced with stone columns. And the third schedule was the model ground reinforced with PE foam barriers. So let's see the first schedule, sir. We just conducted the tests in uniaxial shaking table. Uniaxial shaking table, that is, the shaking was provided in only one direction. And the laboratory model tests were performed. The of 1.4 by 1 by 1 meter. The saturated ground model was prepared for a height of 600 mm in that rectangular tank. The method we adopted was wet sedimentation technique, that is, or sand fluviation technique, in which the relative density of soil can be achieved by pouring the soil from a calculated height, the height of unreinforced and reinforced condition. So the saturated soil ground bed, as I said, the ground bed model was prepared for 600 mm height. Reduce the efficiency of PE foam barrier slightly. So here also the PE foam barrier was found more efficient, and it offered better de-amplification, and sustained efficiencies was found in PE foam barrier. So the effect of pore water pressure ratio. The pore water pressure ratio, sir, as you know, here stone column reinforcement took the lead, because stone column reinforcement is highly efficient, because the basic principle involved in stone column reinforcement is drainage. So as compared to PE foam barrier reinforcement, stone column reinforcement was well ahead in resisting the pore water pressure developed. But however, PE foam barrier reinforcement resisted the pore water pressure better than the unreinforced ground. So finally, the foundation settlement, sir. So when the foundation settlement after each acceleration loading was manually measured, and it was found that after initial loading, the stone column performed exceedingly well because it reduced the pore water pressure buildup. But at continuous loading, the reduction in stone column reinforcement found to decay. Whereas in PE foam barrier reinforcement, the sustained efficiency was good. But however, in high intensity loading, the PE foam barrier observed slight tilt and deformation due to the high water pressure, high water uplift pressure. The average reduction in stone column reinforcement was 48%, and in PE foam barrier reinforcement was 45%. So I would like to conclude, sir, the confined PE foam reinforcement performs well in mitigating the incoming ground motions and also the pore water pressure buildup. But due to the absence of effective drainage, the performance of PE foam barriers slightly reduces at high intensity loading. Stone column reinforcement is very good in providing densification and drainage. But under repeated undrained loading, due to the clogging effect in stone column, due to the possibility of clogging in stone column, the liquefaction mitigation efficiency is reduced. So, I can conclude there, sir. In order to extract the highest possible efficiency, we should just combine both reinforcement system if possible, and we are just working on that right now, sir. And the paper is in process.
Yeah, good. Yeah, thanks, Vijay. I think you took more than 10 minutes.
Sorry,
But anyhow. So your intention of making ground improvement confinement. So confinement of ground improvement with stone column against PE. Yeah.
PU foam barrier.
Attempt is good, but only thing is how to mix and how to install. So how to confine, what is the stiffness you are going to increase. So how to address the settlement. So settlement point of view, you could able to show both are almost equal. Okay. So cost point of view and then installation point of view, improvement of stiffness point of view, we may need to look into. Okay. Anyhow,
actually
thanks for
serviceability is good in PU foam barrier under sustained efficiency.
yeah, good and good attempt and best wishes to you. Yeah.
Thank you.
So I'll invite next other Grishma and Anjana. So paper 131. You can de-share, Mr. Vijay. Yeah.
Thank you, sir. Thank you.
Swell consolidation characteristics of fiber reinforced expansive soils. So Grishma or Anjana? So is this presentation through phone or I could see my video?
Hello, sir.
My image. Yeah. Is it the Grishma or Anjana?
It's Grishma, sir.
Yeah. So
Sir,
is it possible? Is it possible to keep full screen mode? I could see very small icon. Are you using phone or?
Yes, sir. I'm
tab?
using my mobile phone.
Yeah. So because it's a phone only, we could able to see. Is it possible to make it landscape mode?
Yes, sir.
Rotate.
Sir, is it okay?
Yes.
Yeah.
Perfect.
Can I start, sir?
Yeah, please.
Okay. Good afternoon, everyone. My topic is swell consolidation characteristics of fiber reinforced expansive soil. As we know, expansive soils are the soils which swells when they absorb water and shrink when water evaporates from them. Due to this alternating swelling and shrinkage, lightly loaded civil engineering structures which are founded on these soils are severely distressed. So many innovative techniques have been devised in order to counteract the problems posed by expansive soils. Physical alteration, belt piers, and granular pile anchors, etc., are some of the innovative foundation techniques adopted for expansive soils. The chemical stabilization of expansive soils using lime and fly ash has also been found very effective in controlling the volumetric changes in expansive soils. Apart from the above techniques, geosynthetic inclusions as a technique of random reinforcement have also been found quite effective in controlling swell and shrinkage. The main objective of this study are to study the swell consolidation characteristics of fiber reinforced expansive soils, to determine the compressibility characteristics of soil sample with the addition of various percentage of fiber content, to determine the optimum percentage of fiber required for improvement of the soil. And next, here comes the literature review. The first paper is use of coir fiber for improving the engineering properties of expansive soil, and the major findings from them are this paper is swell potential and compression index are reduced due to the fiber inclusion. And the second paper is swelling behavior of a geofiber reinforced expansive soil. And from this paper, it is found that the heave is reduced more at lower aspect ratios, and swelling pressure with increasing fiber content for all aspect ratios, and swelling pressure also decreased in the case of fiber reinforced samples. And the next paper is effect of polypropylene fiber on mechanical behavior of expansive soils. And from this paper, it is find that one-dimensional swell is decreased considerably with the fiber addition. And next paper is swelling resistant geogrid, a new approach for the treatment of expansive soil. And the findings are a significant reduction in the swell due to the reinforcement is found, and the reduction is increased with the increasing in the stiffness of the geogrid. And the last paper is consolidation characteristics of fiber reinforced expansive soil. And from this, the compression index and the coefficient of volume change is decreases with the inclusion of polypropylene fiber or coir fiber in the soil up to a certain fiber content. And after that, there is an increase in these values, and the coefficient of consolidation is increased with the increase in fiber content and fiber length. And here is the methodology. First, the literature review is done. After that, the soil sample and the fiber are collected. Here, black cotton soil is used, and the fiber used is polypropylene fiber. And preliminary tests are conducted on these samples. The main test is consolidation test. It is conducted on the sample and fiber reinforced samples. And finally, the results are analyzed. And here comes the consolidation test results, and this figure shows the consolidation test apparatus. And here we can see this is the variation in coefficient of consolidation with different percentage of fiber content. From this figure, the coefficient of consolidation is increased from 0.009 centimeter square per minute to 0.01 centimeter square per minute, and it is clear that the coefficient of consolidation is increasing with the inclusion of polypropylene fiber with increase in the percentage of polypropylene fiber. And next is variation in void ratio. That is from this figure, it is clear that on adding polypropylene fiber, the void ratio is decreased. For unreinforced soil samples, the initial void ratio is obtained as 1.04, and there is a decrease in the value of void ratio on adding different loads. Also, the void ratio decreases with the increase in the percentage of polypropylene fiber, and void ratio become a constant for higher percentage of polypropylene fiber and increases as the load increments. And next is the variation in variation of compression index. From this figure, it is clear that on adding polypropylene fiber up to 0.75%, the compression index decreases, and thereafter with addition of polypropylene fiber, the compression index value increases, and optimum percentage of polypropylene fiber is obtained as 0.75%. And next is the variation in swell index. From the figure, on adding polypropylene fiber up to 0.075% of fiber percentage, the swell index value decreases, and after this percentage, there is an increase in the value of swell index. And from the above test results, as a percentage of polypropylene fiber increases, the compression index and swell index value decreases. For unreinforced soil, the compression index value is obtained as 0.37 and swell index value is 0.027. From the above figures, it is clear that on adding polypropylene fiber up to 0.75%, both these swell index and compression index values are decreasing, and thereafter with the addition of polypropylene fiber, both these values are increasing, and the optimum percentage of fiber is obtained as 0.75%. And the soil here, next is the conclusions. The soil was classified as CH soil, and it has been found that the inclusion of fibers, namely polypropylene fiber, have sufficiently improved the compressibility characteristics and the swell behavior of the soil, and the consolidation parameter, namely compression index, decreases with the inclusion of polypropylene fiber in the soil up to 0.75% of fiber content, and thereafter on adding polypropylene fiber, the compression index value increases, and the minimum value of compression index is observed at fiber content of 0.75% for soil reinforced with polypropylene fiber, and the compression index is decreased by 53%, and the swell index value decreases with inclusion of polypropylene fiber in the soil up to 0.75% of fiber content, and thereafter on adding polypropylene fiber, the swell index value increases, and minimum CS swell index value is observed at fiber content of 0.75% of for soil reinforced with polypropylene fiber, and the swell index is decreased by 48%. And based on these results obtained, it is recommended that the polypropylene fiber can be used as a reinforcing material for mitigating the volume change of expansive soils. And these are the references. Thank you.
Thank you, Grishma. Is this practically applicable, or is there any cases that like any foundations, say residential buildings or such foundations, is there any applicability to control variation of moisture?
Yes, sir. I have done a typical example using this.
Okay, good. So thank you very much. You maintained time very well, 6 minutes, and your conclusions are very clear. And,
thank you, sir.
Thank you very much. Thank you very much for sharing your experimental study to IGC 2020. So thank you very much. So now I invite Mr. Aish Mittal, paper 132. So soil stabilization using bioenzyme, a review.
Okay.
So, Mr. Mittal?
Yes, sir.
Yeah, please start sharing your presentation.
Sir, is it visible?
Yeah, it is visible.
Okay. Good afternoon to all of you. My topic of presentation is soil stabilization using bioenzyme review. This is basically a review paper. So the introduction. First of all, roads are the most vital component for the economic and social development of any country. And as you all know, India has a total road network of around more than 6 million kilometers, of which around 79% consists of rural roads. Out of which around 20% land area of India is covered with soils having low CBR and shear strength values. And the performance of pavement depends mainly on the properties of soil separate. Okay, so if the soil is poor, it will deteriorate. So in order to overcome such situations, some soil enforcement techniques have to be adopted. Otherwise, there will be much increase in the cost of construction and maintenance. So the enforcement can be in the form of metal strips, synthetic and natural geotextiles, some chemical treatments, geogrid sheets, randomly distributed synthetic and natural fibers. Now this figure shows the soil map of India. As you can see, in the central and the southern parts of India containing states of Madhya Pradesh, Rajasthan, Gujarat, western parts of Uttar Pradesh, and Bihar, consist of fine, expansive soils, which when it comes in contact with water, loses its strength significantly. So the pavement constructed over such soils deteriorates. Now, an ideal stabilizer is one which should be easily available, economical, eco-friendly, and effective for a longer period of time, or make soil permanently stable. Now, the idea of using enzyme as a soil stabilizing agent came after the effective application in the horticultural field. In this study, we have reviewed about the Terra enzyme, which is a bioenzyme, is a natural product which is formulated by fermentation of vegetable extracts. It is a natural product, non-toxic liquid material, and it is diluted before being applied to the soil, and it significantly improves the bearing capacity and strength of the soil. Now this figure shows the Terra enzyme. Now coming to the stabilizing mechanism, the Terra enzyme reacts with the absorbed layer of clay and reduces the thickness around the soil particles, due to which void spaces between the soil particles reduces and the soil gets compacted with minimal effects. And its applicability is basically on more effective on fine grained soils as compared to coarser soils. Now, these are some properties of Terra enzyme. Its specific gravity is 1.05, its pH value is in the range of 3.5. It is dark brown in color, and it is non-harmful, natural, non-inflammable, biodegradable. Okay. Now coming to some literature use, some of the studies which have already used this Terra enzyme in soils, they have concluded that the study revealed that the effectiveness of enzymes-based stabilizers depends upon the percentage of fines and the clay content in soil. This is the findings of the one paper. Another paper shows the formation of cross-linking and bonding structure in enzyme clay brick is the main cause for strength improvement. Another shows the conclusion that the use of enzyme in lime is not only have environmental benefits but reduces the project cost considerably. So these are some of the conclusions of this. Now coming to case studies, the Terra enzyme is used in the Odisha region in the Andhra Pradhan Mantri Gram Sadak Yojana (PMGSY) roads. A stretch of 1.92 kilometer road has been taken and it has been reinforced with Terra enzyme. Okay, the dilution ratio is kept around 200 ml of Terra enzyme for 2.8 cubic meter of soil for first layer, and second layer is reinforced with 200 ml using 3 cubic meter of soil, in 3 cubic meter of soil. And this is the photograph after 3 years of application, and there are no possible signs of undulations, potholes, depressions, deformations are there. No signs of this. Similar, another study was this. Similar in the state of Odisha only, they have reinforced the soil, and there is also one benefit that the dust reduction of over 75% is reported in these rural roads. Similar, one more example is this. 2-kilometer road stretch is taken in the state of Odisha. Now, Terra enzyme is also applied in foreign countries also. They have used in Canada. They have used in the 2 stretch, they have taken 350-meter road stretch. And there is significant improvement in the CBR value. Initially, for an enforced soil, it is around 20%, and which has increased from 100 to 17%. More than 6 times in improvement. And you can see, as you can see, the figures before reinforcement and condition of road after reinforcement. So in all the above cases, the aggregate saving of more than 70% is reported, and there is significant reduction in cost of pavement. And more than this, 15 kilometer of road have already been constructed in Odisha, having no granular sub-base cores, and there is no possible signs of distress after 2 years of construction. Now coming to conclusion, found that bioenzyme in soil leads to formation of calcium silicate hydrate compound, which have cementitious properties, due to which there significant improvement is seen. Now, application of enzyme in expansive soil, it significantly reduces its plasticity characteristics and provides volumetric stability. So, its applicability in subgrades significantly reduces the thickness of pavement, and this that the aggregate materials are very costly and they are depleting day by day, and they're also causing this carbon emission problem was also there. So, in order to overcome all these problems, we can use this compound also. So thank you. This is my presentation. Thank you.
Thank you, Dr. Aish. A very interesting presentation and using bioenzyme. And you illustrated that there is 1.5 lakhs reduction per kilometer. So can you please let me know what is actually means percentage wise how much reduction?
In cost reduction, sir?
Yeah, cost reduction. You said 1.5 lakhs reduction.
Sir, it will be around. Sir, these are in the rural roads, but I think more than 15 to 20% reduction will be there in cost.
Okay, so yes, 15% reduction is very good saving.
Very good, yes, sir. And also the saving of aggregates also, sir. That is more important because the good aggregates are depleting in India. They are not available in India. Quarry sites are very far away from the actual construction site, so the conveyance cost was very much high, and lot of carbon dioxide liberation and diesel consumption was there. So in taking all these aspects into consideration, we can use that.
Yeah, maybe we may be having more discussions on this during question and answers. So thank you very much, your paper, and I have a few more questions. Maybe we can discuss later at the end of session. Can we proceed, Professor Sai Baba Reddy garu, for next paper? So I can invite now Ms. Kirtimayi, paper number 134, performance of vertically confined shallow foundation on reinforced sand under concentric loading. Ms. Kirtimayi. I can't hear your voice, Kirtimayi. I can see presentation, but I can't hear your voice. Is it only for me or others also? Ms. Kirtimayi, you start now.
Hello.
Yeah, you start now. I can hear your voice. Please start.
Hello. So kindly ensure me the audibility of my voice.
It is clear now. Your voice is very clear. You start now. But I could see you have 23 slides. You have 23 slides. Please confine yourself. Time pressure. So there is 6 minutes time for you.
Okay, sir. Okay, sir. Good afternoon, everyone. This is P. Kirtimai from IIT Roorkee, and the topic of my presentation is performance of vertically confined shallow foundation on concentric loading, supervised by Professor N.K. Samagia. These are the outline of my presentation, that is following introduction, experimental details, and in methodology, I'll be discussing about the experimental method that I've adopted and the numerical study that has been conducted by using Plaxis 3D, followed by results and discussion, finally the conclusion. And as we know, bearing capacity and settlement are the two most important and essential criteria considered during foundation designs. And in this regard, several methods have been devised by researchers to enhance the soil characteristics, out of which soil confinement is one of the suitably applicable methods which is accepted in the geotechnical field. Several, as I said, there are so many work that has been done in the field of confinement, and mostly the researchers have used different materials, especially starting from UPVC to semi-flexible vertical confinements to timber box. They have tried all those materials to check out the enhancement in the bearing capacity. So in my case, sir, I have used biaxial geogrid as the confiner as well as the horizontal reinforcement. Basically, this is a 4-plate of biaxial geogrid which are assembled together by the use of some thick webs. And this is the horizontal same biaxial geogrid which is used as the horizontal reinforcement. And the test has been carried out in 3 test series with the 3 foundation configuration. In the first, only footing is used as the surface footing which is acted upon by the vertical loading. Then in the second series, footing with confiner is used, in which the top surface dimension, which is designated as capital D, is varied as 1B, 1.5B, and 2B with a constant depth to width ratio as 1. In the third test series, footing with confiner as well as the vertical as well as the horizontal reinforcement has been introduced with a spacing gap of 0.25 to 1B at an increment of 0.25B. And the same D by B ratio variation has been observed here simultaneously with a variation of L by B ratio was 1, 1.5 and 2B. Basically, in 3 stage of test series, we have seen the enhancement in the bearing capacity and the reduction in settlement. So these are the property of the sand that I have used and property of biaxial geogrid. In the methodology, that this is the test tank having dimension 1 meter by 1 meter of depth 0.8 meter, and which a 20 centimeter by 20 centimeter or the square footing is used, with B is the depth of the width of the footing. And basically the test, the sand bed was prepared maintaining a relative density of 50% throughout with a fixed height of fall, which was decided by several trial and error method. Lateral confinement confiner was placed after filling the tank to a certain desired height, followed by the placement of horizontal reinforcement. And every time the concentricity of the tank was given utmost priority by using plumb bob. After the combined entity of the whole confiner and the horizontal reinforcement was placed inside the tank, the rest of the tank was filled completely, mounting the footing on the top of the tank, maintaining the same concentricity with the tank, and with 4 dial gauges having accuracy 0.01 mm, giving the average of which provides the settlement and the 25 mm settlement is considered as the settlement of the footing, which is later on validated with the Plaxis result. So as I said, this small d is the depth of the confiner that is used, and capital D is the surface dimension. And one thing is that for the first top layer of spacing, top layer of the reinforcement, a constant 0.1B spacing has been maintained throughout. And this is the numerical study which is carried out using Plaxis 3D, in which the non-linearity of sand is modeled as a hardening of soil model, and the footing which is modeled as the plate element, and the confiner as well as the horizontal reinforcement placed is modeled as a isotropic elastic material. And all the parameters like the second modulus of stiffness, loading and unloading stiffness are found out by using the correlation between angle of shearing resistance and the relative density value with the SP correlation with SPTN value, and a prescribed settlement of 25 mm is applied, so that directly we have obtained the load bearing capacity at 25 mm settlement. So these are the parameters which are considered in the Plaxis analysis. This is the geometry which is modeled, and this is the connectivity plot showing the confiner as well as the reinforcement. In the first figure 5, I have incorporated all the 3 confiner dimensions having the variation of top surface dimension 1, 1.5B in the one graph. Here in the table we can see for the surface footing, this load intensity value was found to be 35.9 kilonewton per meter square, and after using this confiner, this value is found to be 59.5 kilonewton per meter square, 50.3 and 42.7, which is a quite which is a quite good increment. But as the one information that we can draw from here, as we are increasing the top surface dimension from here, the load intensity value is decreasing. So it is recommended to keep the top surface dimension as minimum 2, d by b equals to 1. And here this is the 3 foundation configurations with footing with confiner and variation of reinforcement as 0.25 to 1b at an increment of 0.25b, in which the bearing capacity ratios are found out with the ultimate load bearing corresponding to 25 mm settlement for reinforced condition to the ultimate load bearing capacity for unreinforced conditions. And in this case, we have seen for minimum spacing of 0.25b, always it gives the maximum value, and it started increasing as the L by B value is also increasing. It's provided a large area to accommodate more quantity of load, ascertaining the increment in load intensity. And we can see a significant variation of 81 to 138.2 and 143.1 kilonewton per meter square increment. So in the comparative study, we have picked out all the magnitude of load which is applied in the experimental work. The particular magnitude of load has been taken from Plaxis data sheet, and that has been plotted in one graph for all the three foundation configuration that was discussed in table 1. And
Kirtimayi, please arrive to conclusions.
Yes, sir.
We crossed more than 7-8 minutes.
Yes, sir. The total displacement occur for individual footing, and here we can see, as I said in the experimental work, with increment of d by b value, this value is value is decreasing. That we can see here from the plots for individual spacing. These are the plots for individual spacings. And finally, we can bring the information that for d by b value equals to 2, and for minimum spacing value, we can get the ultimum load intensity, that is 143.1 kilonewton per meter square, which is obtained experimentally and well validated with the Praxis result of 158.75 kilonewton per meter square. And for confiner size, it is advised to keep the confiner size less, the top surface dimension less, so that we can get optimum result. And the placement of confiner and geogrid should always be placed with utmost priority, so that better performance can be obtained. And aperture size also plays an important role in finding out the results. So these are the few references I have used. Thank you.
Thank you very much, Kirtimayi. You did a good study that confining the shallow foundations using is it something like Gabion boxes sort of thing you did this study?
No, sir, not Gabion. We can consider it as a loosely skirted foundation. So as I have used, I'm not monolithically, haven't attached the confiner monolithically with the footing. So we can consider it as a loosely skirted foundation, which is increasing the load intensity, as we saw from 35.9 to increase to 143.1 kilonewton per meter square, which is a quite good numeric number to find.
Okay. So thank you very much. Anyhow, we can have more discussions at the end of the session. Thank you very much. So now I can invite Srujana, Hemna, Ravikumar, Preeti, or Srinivas. Paper number 135, study on the performance of marine clay stabilized with waste materials. Who are going to present in this session? Srujana? Yeah, we can see PowerPoint presentation. You also have 25 slides. Please respect the time.
Yes, sir. Good afternoon, sir.
Keep full slide mode, presentation mode.
That is full screen. You can make it on.
Yeah. Good afternoon, sir. Good afternoon, everyone. My name is Rujana. I have completed my bachelor's degree in civil engineering at Gayatri Vidya Parishad College of Engineering. Here are the co-authors. Of this study: a study on the performance of the marine clay stabilized with the waste materials. And the co-authors are M. Hemna, K. Ravikumar, S. Preeti, and Manchkanti Srinivas from Department of Civil Engineering, Gayatri Vidya Parishad College of Engineering. And here, coming to our content, this presentation covers the main theme, objectives, introduction, methodology, results, conclusions, and references. Coming to our main theme, to improve the properties of marine clay using waste materials is our main theme. And the materials are GGBS, fly ash, sewage sludge, and lime. And objectives are to find the index properties and engineering properties of marine clay, and to find index and engineering properties of treated clay, and to identify the best among us the ones used. Coming to introduction, to fulfill the needs of an ever-increasing population, the infrastructure development activity on marine clay deposits can be done economically using this stabilization. This stabilization on soft soil is necessary before any construction, like pavement structures, roadways, and etc. to avoid failure due to settlements. And this stabilization improves the properties of soil with respect to shear strength, bearing capacity, and etc. And this presentation is represents the investigation on stabilization of marine clay using waste materials like GGBS, fly ash, and a mixture of sewage, sludge, and lime. Coming to our waste materials, GGBS, that is ground granulated blast furnace slag, is a byproduct of iron and steel industry which is used with the replacement of marine clay in 10, 20, 30, and 40 percentages. Similarly, fly ash, which is a byproduct of thermal power plant which is used in with replacement of marine clay in 10, 20, 30, and 40 percentages. A mixture of sewage, sludge, and lime is used as a third additive, that is which is used with the replacement of marine clay in 15, 20, 25, and 30 percentages by keeping 10% sewage sludge constant and by varying the lime at a rate of 5%. Coming to methodology, we followed the methodology of procurement of materials like marine clay, additives like GGBS, fly ash, and sewage sludge and lime, and we have found out the index properties and engineering properties of marine clay which is treated and which is untreated, and we come to the conclusion of finding the optimum additive which is used for stabilizing a marine clay. Coming to results, these are the properties of untreated marine clay. Like let me tell you a brief some important properties like specific gravity which is 2.68 and liquid limit which is 68% and plastic limit which is 21% and plasticity index 47%, and coming to CBR value which is very low, that is 1.12 and 2.02 for soaked and unsoaked respectively. These are the marine clay, this is the untreated marine clay properties. Coming to next, that is a particle size distribution curve. That is, here is the particle size distribution curve which indicates the how the marine clay is distributed for the taken marine clay. And this is for this the CU and CC values are 5 and 2.67 respectively. This is the index properties of a clay treated with a GGBS, that is liquid. Here you can see the GGBS, that is treated clay, GGBS treated clay graph, that is a liquid limit and plasticity index which is decreased gradually, coming to plastic limit which is increased gradually. Similar trend is followed by both fly ash as well as sewage sludge and lime, but whereas comparing the sewage sludge and lime with the GGBS and fly ash, this is very less decrease, very less amount of decreasing trend is observed. Coming to next, this is compaction curve of a clay treated with GGBS. Here, with the increase in replacement of GGBS, the corresponding dry density got increased and the water content got decreased. Similar trend is followed when we added fly ash with a marine clay, but on comparing with GGBS, this is very less. And coming to compaction test results, this is of sewage sludge and lime mixture. Sewage sludge and lime mixture, the maximum dry density got increased with the increase in optimum moisture content, which is very rare and which is very dangerous. Coming to next, this is unsoaked CBR results values of a different additives. Here also the GGBS got a very highest value with the replacement of 30% GGBS, and after that it got decreased. Similar trend is followed for a soaked condition, and this is for unsoaked condition. Coming to UCS values, the GGBS treated clay with the increase in replacement of GGBS, the corresponding UCS values got increased with the increase in the time period, that is from 0, 7, 14 for every 14 and 28 days. Similar trend is followed when added with the fly ash as well as with the sewage sludge and lime. Coming to conclusions, these are the conclusions we have drawn from our study. We have coming to first point. First point is whereas comparing the all type of admixtures, the liquid limit and plasticity index got gradually decreased for all the additives, whereas for the GGBS, the appreciable amount of decrease in the liquid limit and plasticity index was observed, that is 42.6% and 76.5% respectively when compared with the untreated clay. Coming to second point, that is a plastic limit. The plastic limit got increased for all the admixtures we have used in various percentages, but compared to all the additives, amongst all, the performance of a sewage sludge lime combination was the best, and the appreciable increase is 71% in plastic limit value when compared with the untreated clay. Whereas coming to the OMC and MDD values, the GGBS with the replacement of GGBS, the corresponding OMC values got decreased with the increase in MDD values. Whereas coming to sewage sludge and lime, the drastic increase in OMC values was observed, which is very dangerous. Hence, the sewage sludge and lime combination is not suitable for additive to improve marine clay. And coming to next point, that is shear strength values. We observed the shear strength values for GGBS is that 340 kPa for 30% replacement, and then it got decreased. Similarly, 350 kPa for fly ash replacement and 770 kPa for sewage sludge and lime replacement. And coming to a California bearing ratio values, with the replacement of GGBS, we got 11.80 in soaked condition with the replacement of 30% soil, 30% GGBS. After that, it got decreased. Similarly, fly ash was observed 7.04 percentage for 30% replacement. Coming to sewage sludge and lime, we got 8.12% with the replacement of 10% sewage sludge and 15% lime. Whereas compared to untreated clay, which is 1.12% in soaked condition and 2.02 in unsoaked condition. Coming to a conclusion, that is the last point, we have concluded that the CBR value of 30% GGBS as replacement is more than when compared to 30% fly ash replacement, 30% replacement of fly ash. Thus, we concluded that the performance of GGBS is better. But when compared to cost of bituminous road constructed using fly ash treated marine clay is more economical than GGBS. So, by considering these 2 points, we concluded that according to performance aspect, GGBS is better, but fly ash is better from an economical standpoint. These are the references we have taken.
Thank you very much, Sujana. Very nice attempt. Appreciate using mixing of these materials with marine clay. So, did you and your team ever thought practical aspects of how to mix in a large projects such materials? So, please have, because this is not easy mixing of such materials.
Yes, sir. These are the waste materials which are increasing day by day. So we thought of replacing in a construction industry.
We also bother about the properties of that waste material because they will not be consistent from one to the other. You have to go for some designing. But anyway, it's a good attempt at your level.
Yes.
Yeah.
Okay.
So 30% GGBFS is very good, and so it gives long-term strength also.
Yes, sir.
So long-term we get more strength when we mix with cement. So, but anyhow, is a good attempt, and CBR values is getting improved.
Yes, sir.
So good information. So how other materials like fly ash and GGBFS or sludge waste or something, so we still can use.
Yes,
good.
Sir.
Thank you very much. So now I invite Jahnavi, Vikas or Saloni. So paper number 137. So the paper is influence of biopolymer treatment on suction characteristics of Bhavnagar expansive soil.
May I know the slide is visible?
Srijana, can you please de-share?
Hello, sir. May I know the screen is visible?
No, not yet. Srijana, need to de-share the screen.
Sujana, you have to
stop sharing.
Link up so that the author can come.
Yeah.
Stop sharing the screen.
Yeah. Srijana need to de-share. Yeah. Now it's okay. Jahnavi, you can present now.
Yes, sir. May I start?
Yeah, please.
Good afternoon, everyone. Topic of today's presentation in IGC Conference 2020 is influence of biopolymer treatment on suction characteristics of Bhavnagar expansive soil. Expansive soils in unsaturated state are considered to be the most problematic soil in world owing to its swelling and shrinkage characteristics. Such type of soils is usually encountered in arid and semi-arid regions where water table lies at a greater depth in Veddos zone layer. Such type of soils in unsaturated state possess negative pore water pressure, which is commonly referred to as suction. The suction comprises of two components, that is metric suction and osmotic suction. Metric suction would arise due to capillary action and surface tension phenomena, which acts against the gravity, and the osmotic suction occurs due to concentration of solutes, that is the presence of salts in soil. From the soil map of India, we can see that 20% of Indian soil mass comprises of expansive soils, causing hazardous issues such as enormous cracks, damaged flow levels, pavement upheaving, and much more. Out of the two components of suction, metric suction governs the entire mechanical response of soil in unsaturated state. Many researchers in the past have found out various methods for the treatment of expansive soils, but were only respect to strength and swelling pressure of soils. Any method to reduce metric suction, which governs both the strength and the swell pressure, remains unexplored. The soil was collected from the village Madia, Bhavnagar district of Gujarat, which was purely dedicated for the salt production works. From the obtained geotechnical properties of free swell index, liquid limit, plastic limit, electrical conductivity, and grain size distribution, the soil was found to be highly expansive and extreme saline in nature. In this research, xanthan gum, guar gum, and chitosan biopolymers were considered as mode of treatment as they are natural, environment-friendly, and non-toxic, as they have been already used to improve the strength of the soil. The corresponding percentages of biopolymers added to soil by weight are specified in the table. In order to evaluate total suction, non-contact filter paper method was used, and to evaluate metric suction, in-contact filter paper method was used at 1.58 gram per cc. For soil preparation, moist damping method was considered in evaluation of suction, strength, swell pressure test. This is the sequential of sample preparation procedure for filter paper test method to evaluate the suction. We can see that highest amount of suction was found at lowest water content at 10%. Thus, it was selected and kept constant in the biopolymer treatment. The optimum percentages of biopolymer treatment were obtained from the filter paper method. Unconfined compression test, swell pressure, and electrical conductivity were performed at dry density at 1.58 gram per cc at obtained percentages of biopolymers. Coming to the results and discussion section of the study, from the suction test, it was observed that guar gum treatment, total suction and osmotic suction was found to decrease. However, metric suction increased as compared to the untreated specimen. Guar gum tends to possess high specific surface area and forms hydrogel with the soil particles, which would tend to increase the adhesive forces and specific surface area of soil. As a result, the metric suction of the soil was observed to be more. From the chitosan treatment, total metric and osmotic suction was observed to reduce considerably. Chitosan treatment would lead to the formation of soil gel around soil particles. This would cause generation of thick gel around the clay particles. This causes enhanced true cohesion amongst the particles, which would lead to the restricted development of air-water interface at lower water content in saturated soil. Hence, the suction of the soil reduces. From the xanthan gum treatment, significant reduction in the total metric and osmotic suction was observed. Xanthan gum monomers would form hydrogen or electrostatic bond with the clay particles, which causes flocculation of particles, which induces reduction in the surface area of the soil, and hence the metric suction reduces. From the UC test results, it was identified that xanthan gum and guar gum significantly increased the strength of the soil. However, the chitosan led to the reduction in the strength of the soil. From the swell pressure test, it was observed that xanthan gum chitosan treatment led to the significant decrease in the swell pressure of the expansive soil. However, guar gum addition led to the increase in the swell pressure. From electrical conductivity test results, it was identified that all the biopolymer treatment led to significant decrease in the electrical conductivity of the saline soil. The possible reason of the observed behavior could be identified that xanthan and guargum treatment led to the permanent sedimentation within soil particles due to formation of H-bond and the hydrogel development respectively. However, chitosan led to the development of soil gel. The soil gel development would result into brittle soil structure and hence reduce the load carrying capacity of the soil as seen in the UC test results. However, hydrogel development by guargum could dilate in the presence of water and hence would lead to increase in the swelling pressure of the soil. Hence, treatment of guargum and chitosan was not found to be effective. Therefore, from the study, it could be concluded that suction, UC test, and swell pressure test, xanthan gum biopolymer was found the most effective in overall treatment of Bhavnagar expansive soil as it improved salinity, suction, swelling, and strength characteristics of the soil. These are references we have used during our research. I thank the whole IGS team for giving me this platform and wonderful opportunity.
Thank you, Jahnavi. Appreciate you maintain perfect time. First thing. Second thing, a very detailed laboratory testing and photographs and the command what you have shown and results what you presented. I really appreciate your effort, your team effort.
Thank you.
And we can have more question and answers during end of the session. Right now, we will continue for the next paper presenter. May I request you to de-share and allow other presenter to project. So next paper 143, paper number 143, authors Mr. Varprasad, Sudhakar Babu and Appanna. So the paper title is Evaluation of Efficacy of Nylon Fibers and Lime in Improving Metakaolin Modified Expansive Soil. So who are going to present? Mr. Varprasad, Dayakar Babu and Appanna. If father is not available, then we can move to next paper. So next paper, paper number 148. Professor Vishwanathan and his student Manaswini. Yes. So paper number 148, title is Analytical Studies on the Use of Stiffer Drains for Soft Soil Improvement. Manaswini, can you please project
yes, sir.
Presentation?
Yes. Is it visible?
Yeah, it is visible and yeah, keep PowerPoint mode. Yeah, please start.
Yeah, so a very good afternoon to everyone. I'm Manaswini. I'm here to present a paper, Analytical Studies of, on the use of stiffer drains for soft soil improvement. So as you all know, rapid urbanization and development strategies have created huge demand for infrastructure, which gradually decrease the amount of competent land available for construction. So either we have to bypass a problematic site or use the incompetent land filled with soft soils as a thrifty measure by implementing proper ground improvement techniques. And also India, being a peninsular region, has a long coastline of about 7,500 kilometers filled with marine clays, which are mostly normally consolidated or lightly over-consolidated in nature. So construction on these thick clay layers is quite challenging. And needless to say, stone columns have gained importance throughout the world as a popular ground improvement technique for soft clay, which helps to increase bearing capacity and accelerate the process of consolidation by providing an additional drainage path. But construction of a stone column involves creation of a hole in the ground, which is later filled with granular material. So the strength and stiffness of stone columns depends on the lateral confinement offered by the surrounding soil. Usually long stone columns with firm or floating support fail in bulging. But if stone columns are installed in very soft soils with CU almost less than 15 kPa, then even short columns fail in bulging due to lack of lateral support. So this concern was answered to some extent by geosynthetic encased stone columns, but the encasement of stone column by geosynthetic is modeled as a thin cylinder subjected to internal pressure caused due to vertical loading called hoop stress.
So when it's subjected to compressive load, the stone column tends to bulge, causing hoop tension in the geosynthetic. So if the load coming out of this is very extensive, and if the hoop tension exceeds the tensile strength of geosynthetic, then it results in tearing of the geosynthetic. So also the construction process is very tedious. So this raises a need to develop stiffer stone columns. And so we tried to study the use of stiffer columns, and the main concern being consolidation. We tried to study the effect of rate of consolidation using stiffer drains, that is drains with increased modular ratio analytically. Modular ratio here gives the ratio of modulus of stone column, ratio of modulus of stone column to the modulus of soil. And the closed form solutions developed by Han and Gay were used here. And they have portrayed the dissipation of excess pore water pressure as a sum of pore water pressure dissipated due to drainage and vertical stress reduction on the soil. And the modified coefficients of consolidation were used here, which results in modified time factors. So I have considered a modular ratio of 30, and which gives a steady state concentration ratio of almost 8.34. And the Poisson ratios and diameter ratio were taken from Han and Game. And the results of the considered steady state concentration ratio were compared with a steady state concentration of 5, which was analyzed by Han and Game. So assumptions here are equal strain approach, and we are neglecting smear and clogging effects. So when it comes to the results, so this formula gives us the increase in effective vertical stress in the surrounding soil. So in this figure, we have plotted normalized average total vertical stress with time factor. And total vertical stress increases on columns and decreases on soil. And this stress transfer is called as stress concentration. Also, we can see that as modular ratio increases, that is the steady state concentration ratio increases, the stress concentration process is more pronounced. And here the stress transfer process is shown in terms of stress concentration ratio. The stress concentration ratio will reach a steady state concentration ratio as consolidation ceases. This is the excess pore water pressure. Here UT is the excess pore water pressure at any time, U0 is the initial excess pore water pressure, and delta U sigma V is reduction in excess pore water pressure due to reduction in vertical stress, and delta UD is reduction in excess pore water pressure through drainage. So for NS equal to 5, almost 40% dissipation of excess pore water pressure was due to vertical stress reduction. And the higher the stress concentration ratio, the more the dissipation of excess pore water pressure occurred through vertical stress reduction, as the final pore pressure dissipation due to drainage should remain same. Though we still did not explore the reasons for the difference in the pore water pressure dissipation due to drainage at the beginning. So coming to conclusions, you can see that stress transfer is higher if the stress concentration ratio is higher. The stiffer drains will relieve more stress on soil. And the contribution of stress transfer in dissipation of excess pore water pressure increases with the increase in stress concentration ratio. So we further hope to conduct experimental investigations on how to develop stiffer columns to properly study the consolidation characteristics and various other parameters, so that this can become an established field practice in future. Thank you. Sir, you are on mute.
Yeah. Thank you.
Thank you, Manaswini. You've given a very good indication that stiffer columns definitely improve, will provide good ground improvement, especially in stone columns. And how to make stiffer columns, that is the next target. It may not be mixed with cement or rigid concrete columns. So this is a challenge definitely, and we can have more discussions. And thank you very much for maintaining time also.
Thank you, sir.
From our side, from IGC. So now I have one more request here, paper number 147. Previously he was not here. Now he came here, he joined. Yes, I invite Mahendra Pradeep Chaudhary or Charan Viswajit.
Sir.
The novel method of on-site biochar production from crop residues and for improvement in soil characteristics.
Yes, sir. Good afternoon, sir. I am here.
Yeah.
Am I audible, sir?
Yeah, you are audible.
Thank you,
Your good
sir.
name, please. Your good name, please.
I'm MP Chaudhary, sir.
Yeah. Mr. Chaudhary, please start your presentation.
Thank you, sir. Good afternoon to everyone. My paper is entitled as A Novel Method of On-Site Biochar Production from Crop Residues and its further application to soils for improvement in soil characteristics. My co-authors are Professor H.D. Charan and Dr. Biswajit Acharya. The contents are as follows: introduction, then about biochar, materials and methods, results and discussion, and conclusions. Coming to introduction, as we all know that India is an agricultural country and a large amount of crop residues are generated every year, and out of those, many of the crop residues are burned by the farmers in their field. So stubble burning is a big threat to the environment. And we know that there is an annual incidence of outburst of smog in Delhi, and presently it is also there. So this open and direct burning of agricultural crop residues by the farmers of nearby states of Delhi is presumed to be one of the responsible factors for this incidence because of the emission of greenhouse gases during the burning. And Honorable Supreme Court of India and National Green Tribunal have also issued directions for controlling this stubble burning. So you can see these photographs which I have taken from the Kota, Rajasthan, where the mustard crops after harvesting, they are set to fire and the fields are looking very where fire is after the soil is deteriorated, and the farmers practice this due to so as to prepare their fields for the next next crops in early time. So a study has been carried out to find out an economic and optimal solution of this problem. A novel method of on-site conversion of converting the residues into a product called biochar has been developed. And this method is based on thermal conversion, in which the crop residues are subjected to pyrolysis, means in the absence or a little presence of oxygen at low temperatures, they are burned or heated. See, the most important feature of this method is its feasibility, because in terms of economical and technical, it does not require much technical skill and it is very economical also. The only thing is to create awareness among the farmers so that they can adopt this method, convert the crop residue into biochar and use in their fields also. So from an engineering point of view, first, let's come to our biochar. Biochar is a fine-grained, carbon-rich, porous product which remains after the plant biomass is subjected to thermochemical conversion, that is pyrolysis at low temperature. It is actually not a pure carbon, but a mixture of carbon, hydrogen, oxygen, nitrogen, sulfur, and ash. The most important characteristics of this biochar is its highly porous structure, which is responsible for improved water retention in the soil, as well as the soil surface area is also increased. These are the a picture of maize stalks, biochar which is made from maize stalk. And what I have done in the field on site, that is I have used the diesel drums, empty diesel drums supported on bricks, and the biochar from different agricultural crops, say mustard, then bajra, millet, then cotton, they are used for converting it to biochar. After some compacting and settling in the drum, the fire is set on the bottom, and after 2-3 minutes, when the fire starts burning in the drum, the bricks are removed and the top is also covered so that the oxygen availability is reduced and the heating process takes inside the place. After 10 to 15 minutes, the biochar is produced, which is further crushed to small pieces, and now it is suitable to apply to the fields, or in laboratory we can consider the mixing of this biochar with soil. So soil samples of some expansive soils were used to conduct the test. These are some characteristics of biochar itself.
So, Mr. Chaudhary, sorry to interrupt you. We scheduled 6 minutes for each presentation.
Okay, sir.
So you may please see how fast you can, because I forgotten to inform you.
Okay, sir. I will just hurry up, sir.
Yeah.
So similarly, the soil samples were collected from the site and they were tested in the laboratory. All the consistency limits and that's classification was done. This was CH type of soil as per UCS. And other engineering properties you can see in the table. All the experiments were conducted in the soil engineering laboratory of Rajasthan Technical University, Kota. And these biochar was mixed in the ratio of percent by weights from 5 to 5, 10, 15, 20 and 25%. So otherwise, the researchers have earlier used lime, rice husk, fly ash and other conventional materials for stabilization, but much reference is not available in literature about using biochar for soil stabilization and especially in India. Therefore, this study was conducted. And these are the results and discussion in which the consistency limits, I will say that liquid limit is reduced from 58 to say around 50 or 40, and the reduction is up to 15%. And the plastic limit is increased up to say 24%. Similarly, the other characteristics, say compaction, the maximum dry density is decreased, the OMC is increased, and the swelling pressure characteristics, free swell index, all these characteristics have been analyzed in the laboratory. Then the compressive strength UCS, then CBR characteristics. The CBR value has increased from 1.55 to 2.46, and then direct shear test in which cohesive and characteristics means the shear strength has improved from 20.065 kg per centimeter square, means the percentage ratio, if we say it is a 150% increase in the shear strength of the expansive soils. So this is the summary of all the results. Major characteristics have improved. So finally we can say that applying biochar in soils for improvement of soil properties have shown very positive results. And these major engineering characteristics, they have all improved with the use of biochar. So biochar production and application has a very promising perspective for resolving the problem of air pollution due to stubble burning in northern India, especially in New Delhi. And it can be called as a multi-benefit method in which 3 types of benefits are there, that agriculture waste is utilized, then soil amendment is achieved, as well as air pollution is controlled. So this is all about my presentation. Thank you very much, sir.
Thank you very much, Mr. Chaudhary. First time I could see such innovative method what you practiced and tested. So with patient, with very much patience. So I'm not sure. I never aware of this such product. But anyhow, intentions are very clear. That you want to utilize the waste product instead of creating carbon monoxide. You want to reduce it. So that is the best one. That is the best choice.
This biochar also acts as a carbon sequestration, sir.
Exactly. So that is the best choice. So we can
actually I belong to environmental specialization.
Yeah.
I have already a PhD in environmental engineering, and I am doing PhD now in geotechnical engineering.
So I think so we can make environmental sustainability with such applications. So we can have more discussions during question and answer, and very interesting presentation.
Thank you very much.
Now I will move to next presenter, paper number 149 by Manas Chandran, Hanumanta Rao and Swagatika. Paper number 149, Advances in Bioremediation of Extremely Alkaline Bauxite Residue.
Good afternoon, sir. Am I audible, sir?
Good afternoon. Yeah, good afternoon, Mr. Manas.
Sir, are the slides visible, sir?
Yeah, your presentation is visible and you can start, and please respect time. So next 6 minutes, try to finish.
Okay, sir.
Yeah,
So,
thank you.
Thank you, sir. Good afternoon, everyone. I am Manas Chandan Mishra, and I'm going to present a short review about advances in bioremediation of extremely alkaline bauxite residue. And I have done this work under the supervision of Dr. B. Hanumantrao at IIT Bhubaneswar. Basically, bauxite residue is nothing but an insoluble byproduct of aluminum extraction during the bare process of extraction. And it is a staggering amount of 1 to 2 tons of bauxite residue or red mud is produced per alumina generated during this process, whereas the utilization has been limited to just 2 to 3% because of various problems faced in handling and utilizing red mud or bauxite residue. So initially about discussing about some few problems. The first one is the impoundment construction has to be very specific, and the designs are to be made the designs and the maintenance design and maintenance is to be done very regularly, so that such catastrophes as in we had witnessed during ASCA in Hungary 2010 were not witnessed. So for this, lots of area is required, for which legal and financial issues are there being faced by the industry. So they are not able to dispose it well as well. And about the utilization, utilization is limited due to many associated geo-environmental problems. First one is its high pH of 11 to 13, and there is a threat of groundwater and soil nearby soil pollution. Apart from that, in the red mud or the bauxite residue poses few eminent threats like dusting, leaching, seepage, and the geotechnical issues such as low strength, erratic compatibility, and the behavior is not predictable because the typical minerals present in sand or clay or the virgin soil are absent in this. Still, even without the absence of clay minerals, red mud exhibits a lot of plasticity. Talking about coming back to the actual topic of bioremediation of bauxite residue, many people, in this study, we are first going to address the pH issue. So during pH, the challenges faced by previous researchers is the first challenge is the complex composition. It has got plethora of oxides and minerals, which react with the additive or the reagent or the technique that we use are not very efficient in reducing the pH. And even if the pH is reduced, a pH rebound is witnessed, as reported by few researchers in the recent times. The pH goes back to the initial pH or nearby to the initial pH in a duration of 6 months to 1 year. And apart from that, that pH rebound causes an issue during the utilization, as we can all understand. And this bioremediation of bauxite residue is not explored as much in depth till now. So the identification of suitable microbes will be an issue for us, will be a challenge for us during this study. But if we are considering the native microorganisms as they are present everywhere in this world, there might be some native microorganisms present. If we can identify them and determine their nutritional requirement and the remediation mechanism, then we can do contribute something in this field. About the advantages of bioremediation, we can say that we all know that bioremediation is a very eco-friendly and sustainable method. It is cost-effective, it is energy efficient, and moreover, it does not cause any harm to the environment as such. If we are introducing some external microbes, which it might help in increasing the biodiversity of the red mud or the nearby soil, which might be able to address some other issues apart from just the salinity and pH of bauxite residue. These microorganisms are known to adapt. They are one of the most adaptive living beings in this world. So they adapt, and in this extremely alkaline condition, they might be able to adapt by synthesizing some acidic secretions. And these acidic secretions, due to their nature and origin, they are not very harmful or toxic. So the end products or the compounds formed after the secretion might not also be that toxic. So coming back to the important contributions by previous researchers, many people have suggested reported the production of EPS and microbial acidic secretions by fermentation of available organic residues of plants and insects and others. And A couple of studies have also reported the production of sulfuric acid by autotrophic and heterotrophic metabolisms of microorganisms.
So, Mr. Manas.
Yes, sir.
So you almost finished the time and you are still at literature review. I can extend another 2 minutes. So can you please make it quick?
Sure, sir.
You should jump fast, okay?
Yes, sir. So let's come back. Let's come down to the need for the present study. It is the available treatment methods have not addressed the major issue of pH rebound. As we can see, the long-term pH issues are not yet resolved, and they have not yet been able to reduce it to a very acceptable limits. As our IRC suggests a pH scale of 8.5 for constructional purposes, we have not yet been able to produce for a long term. And the impact of the treated sample on geotechnical in the geotechnical and geoenvironmental aspects are not yet explored as well. In the present study, we have procured the bauxite residue from Vedanta Aluminium Limited in Orissa, and the citric acid was a commercially procured one. The characterization of the oven-dried sample were done according to ASTM standards, and it was found that 71% of the bauxite residue taken for this study comprised of sill-sized particles. The USCS classification was done as ML type soil, and the pH came out to be 11.4. So for further experimental investigations, cylindrical samples were prepared using moist tamping method and using the optimum moisture content and dry density conditions, and the samples were preserved in Ziploc pouches in humidity chambers. As we can see in the pH study was done up to 180 days, and the pH is constantly increasing for all the sample, all the combinations of citric acid. In the mineralogical characteristics, we can see that most of these minerals are of the iron family, with hematite dominating the mineralogical composition, whereas we can see sodalite and cancrinite, which might be able to help us in further stabilization of the treated red mud soils. In the morphological findings, after 45 days of curing at constant or maintained temperature and humidity, we can see aggregation on the red mud particles. And apart from aggregations, calcareous aggregations, we can also see that some microbial growth is found. So as we had not introduced any external microbes, these must be the proliferation of native microbes after the change in pH conditions and intrinsic chemical reactions undergoing. So major conclusions of this study done till now are the microbial bioremediation might be able to produce a good alternative for pH reduction as well as enhancement of geotechnical behavior. But the implementation of the recommended treatment method might require a specific consideration of variations in the origin, source, and generation and disposal of bauxite residue. The microbial pH abatement of bauxite residue can be augmented further by improving the geotechnical properties by aggregation of such calcareous precipitates using EPS synthesis. So this concludes the present paper, and some more relevant studies are going on in our lab under the able supervision of our Dr. Rao regarding the leaching behavior and the leaching, dusting, sedimentation analysis as well. Thank you.
Yeah. Thank you. Thank you, Mr. Manas. You did a good study, but you need to make it fast next time. Maybe this is a good experience. So I go to next presentation. We have one presentation here, paper number 152. So that is by Ramakrishna and Professor Tyagaraja. So review of osmotic and mechanical loading on the behavior of soft clays. Mr. Ramakrishna? Is Mr. Ramakrishna present here? Yeah. So, Mr. Ramakrishna, we can't hear your voice. We can't hear your voice.
Can you hear me now, sir?
Yeah. Yeah, we can hear your voice now. Please share and make it fast. We have to close session in another. You will be having 5 minutes time, and we need to have 10 minutes discussion. Please respect your time.
Sure, sir.
Yeah.
So good afternoon to one and all. This is Paranit Ramakrishna from IIT Madras, guided by Dr. T. Tyagaraja. I'm going to discuss about a review of mechanical and osmotic loading on the behavior of soft clays. So these are the contents of my today's presentation. Introduction to soft clays. So soft clays are those which possess the low strength and high compressibility characteristics. There are basically two problems in soft clays. First is excessive settlement behavior, and second is the bearing capacity failure. To treat these problems, we have got three major modification techniques. That is a mechanical modification, chemical modification, and hydraulic modification. Coming to the first technique, that is a preloading method. There is a soft ground which is problematic in nature. We are going to construct an embankment or dead load, which leads to mitigation of settlements. Once the settlements are mitigated, we are going to remove the dead load, and the final structure is constructed. Coming to the studies on preloading, the earliest recorded use of preloading technique was given by Tomlinson in 1956, and the embankment which we are going to construct must be done in a stage-wise fashion so that there won't be build-up of the excess pore water pressure, as given by Jamilovsky in 1983. This technique of preloading is suitable for all kinds of soil, but it is especially suited for the soft cohesive soils. Stamatopoulos and Aniorostis in 2002, they conducted some dynamic studies on preloading, and they found that due to the use of preloading, the surface acceleration actually decreased in the soil deposit. Coming to the prefabricated vertical drains, PVDs, they consist of an inner plastic core, and the outer covering is made up of a synthetic jacket material. And there are two major functions of PVDs. First is they must inlet the pore water flow into them, and second is they must transmit the collected pore water. Now coming to the studies on PVDs, we all know that when the PVDs are installed, there will be disturbance on the surrounding soil mass, leading to the formation of smear zone. So Gandhiuran et al. In 2010, he developed an elliptical cavity expansion theory to study this disturbance. And Parsapojov et al. In 2014, he concluded that when the consolidation reached 33%, that is when we can accurately predict these smear zone properties. And Bo et al. In 2016, he concluded that the critical factor for the decrease in the discharge capacity of a PVD is the deformation of the PVD under the folded conditions. And Guyen et al. In 2020, he made an innovative method, like he found a new prefabricated vertical drains known as biodegradable prefabricated vertical drains. He compared this with the standard PVDs available in the market, and he got some comparable results. Coming to the vacuum preloading method, vacuum preloading method is very simple. Here we are going to apply the atmospheric pressure as a temporary surcharge, and due to which there will be isotropic consolidation through the soil mass, leading to the improvement of the soil deposit. Studies on vacuum preloading. For Chai and Carter in 2013, they proposed a combined vacuum and surcharge preloading method, like they proposed a theory for it. And Chai and Radonov, for the case of vacuum and surcharge preloading, they found a new method for the surcharge loading rate. And Lam et al. In 2015, he conducted some numeric analysis, and he concluded that in comparison to the conventional preloading method, the vacuum PVD method had a higher settlement rate. Wang et al. In 2017, he combined the vacuum preloading method with the lime treatment, and he was able to improve the soft clay deposit. Zhu et al. In 2017, they combined the surcharge and vacuum preloading, and they found that the surcharge and vacuum preloading method combination increase effective stress, but they have little influence on the rate of consolidation. Now coming to the electroosmotic consolidation, we all know that the clay particles, they are negatively charged. So when an electrical potential is applied, these positive ions, they move towards the cathode. So in this process, they drag the free water as well as the bond water along with them, leading to the consolidation of the soil mass. Coming to the studies on electroosmosis, Peng et al. In 2013, he conducted some experimental investigation to study the behavior, the mechanism, and also the effectiveness of electroosmosis in combination with vacuum preloading method. Liu et al. In 2014, he combined all the three major methods of the hydraulic modification technique, that is the surcharge preloading and vacuum preloading and electroosmosis, and he was able to...
Thank you, Mr. Ramakrishna.
Sir? Sir, I'm going to finish, sir, in 2 minutes. So, Sun et al. In 2015, he made a comparison between the vacuum preloading method and the vacuum preloading in combination with electroosmosis on a test site in China, and they were able to get a good result because of that. Hu et al. In 2019, they actually studied the effects of pH and the sodium and calcium ions on the electroosmotic consolidation of kaolin soil. Now, coming to the final osmotic effects on soils. So when clay specimen is inundated with electrolytic solutions, there will be some flow of water from the clay deposit leading to the volume change in the soil. So this is because of the decrease in the diffuse double layer. Studies on osmotic effects on soils.
So Ramakrishna, can you please come to conclusions? Why we have to have discussions?
Sure, sir. Actually, I'm doing a review paper. This is the last one I'm going to do. After that, I'm going to conclude it. So some of the studies on osmotic effects on soils have been presented here. Now coming to the need for study, the need for study is that there are a lot of methods available to study the soft clay, like to improve the soft clay deposit. So along with that, we can combine the surcharge preloading and PVDs and also introduce osmotic flows in the soil. And this can be done by conducting a series of laboratory experiments, which is what I'm going to work out. This is a review paper what I did, and thankful for that. Thank you.
Thank you very much, Ramakrishna, and thanks all others who presented the papers. So we have 13 papers, and last minute one more other also requested, but we are running out of time, and we have only 5 minutes time now.
Yeah.
So Reddy Garu, please take lead from now, and please conclude, sir.
Yeah, thank
and
you.
I congratulate all others who come forward, prepared very nice presentations, and the motive is very clear. And maybe few of the others may need to confine time limits. Few others well prepared time pressures. So maybe this may be a good example. Next sessions you may take this experience. Thank you very much. Congratulations to all.
Dr. Madan Kumar Garu, do we have any questions to take before we go for discussion?
Yes. So we have 5 minutes time. So participants may raise a few questions, and others may respond to.
Maybe I will do one thing, Madan Kumar. I just give some comments, then we go with the left out the questions.
Sure.
As you said, we congratulate all the authors who has had a very good presentation. Topics are there, very varied topics, apart from the experimentation, analytical modeling, laboratory modeling. Some are basic sciences application, some are applied one. One point which I would like to mention in general for all the researchers, because the youngsters you are going to take over the coming generation, how the questions research has to go in. We have to focus on few things. One is go to the basics of the subject, what exactly we were trying to investigate. That is one aspect. Few things you go to the literature. For example, a paper called Soil Consolidation Characteristic of Fiber Reinforced to Expansive Soil. There are a lot of literature is there. Number of MTech projects are there on this area. Probably we need to try to have a look into that. Similarly, we are going to have the influence of biopolymer treatment. There are all some chemical way of treating. It's good. The new concepts has to get into that. And industrial waste, when we are mentioning anything, we are modifying it. We need to have a design concept to be given so that field engineer in a position to take it up, how they are going to execute it. So that is one aspect we need to look in. And the bioremediation, this is given by Manas Chandan. Let me give that a lot of geoenvironmental studies are going on. There's a different field has been already initiated. Most of the geotechnical engineers now are working on geoenvironmental engineering. The bioremediation is meant for a small diluted chemicals only can treat. Extremely alkaline bioremediation is not practicable because the bio enzymes are going to die for extreme environment. Just try to look into that. And the osmosis mechanism loading Ramakrishna has given. I think he has given a general application, general theory. I can say most of the things are the textbook material. I request that just to add some papers, let us not go on. Focus on the work. Maybe you have a small contribution. Don't bother to have a very big contribution. And we are engineers. We should not just do a few experiments and give results. Let us focus on what is that we are trying to achieve upon. Okay. With this, I once again appreciate all the youngsters because the professors are left alone. The students are presenting. That one thing I appreciate it. And I look forward for the questions that is coming from you, because you're from the way of questioning also we understand your understanding of the subject. Okay, thank you, Master Madan Kumar Garu. Please take over for the questions.
Yeah. So, any questions? Please unmute yourself and raise question. You can state particular question and who is the author to respond. So then we can request.
You can mention paper number. You mention.
Yeah. So I can't I can't hear any from anyone.
Fine. Yeah. This is one more thing, Madan Kumar. This is we should have an open discussion. Yeah. Let us not take as examination. We finish our paper and gone out. This is an occasion where we have a discussion. So seriously understanding the other paper. Yeah. I finished my paper. I'm going home. No, this is our occasion where we have the interaction, have good friends. Areas of action. Okay, the culture we need to develop, because you are the future engineers here.
Okay? Maybe on behalf of participants, maybe I can ask a few questions. I like Mr. Chaudhary's presentation, maybe because it is entirely new to me, and he also environmental specialist, and he like geotechnology, and he is looking into geotechnology now. So, Mr. Chaudhary, please let me know. So once you create biocar, so then you are reducing emission. So that is the best way of looking environmental protection. The second thing is the same biocar you are going to use for crops, or I could engineering properties. You said they are going to get improved. I mean, in the long run, or
I am working on both the aspects, sir. The first one is from engineering point of view to prove how we can amend the soil properties.
Yeah.
And the second one I'm also working is how to increase the crop yield, whether it has any effect on the fertility of the soil or not. So I'm working on both the aspects, sir. And the literature review also suggests, but I haven't seen any more papers from India where they have used this concept.
Can you please let me know why crops are after harvesting, after taking of the crop, why people burn it? Is there any logic, or simply they want to burn and then get fuel from that, or what is the reason?
Sir, the reason is simply, sir, that these days the farmers are using mechanical equipments for the harvesting. And they simply, after harvesting, whatever is left in the fields, they do not want to invest money to collect or cut that waste material from the fields. So they simply burn it so that it goes on clearing the fields in a very soon, and they can sow their next crops. So it is only according to the saving the money only. This is their point of view. So it's going to be changed.
So I think it is also the idea that burning the ashes will be coming and mixing into the ground. That may add some sort of a fertility aspect. That also probably one of the reasons.
Sir, yes, yes, sir.
Yeah. Another point is, as where Madan Kumar sir was asking, what engineering properties of soil is going to improve upon by using this one?
Sir, that I have shown in my presentation that majorly from the liquid, the consistency limits, then as well as the moisture contained, water is retained in the soil through this, and soil surface area is increased. So the water retention capacity of soil is increased through the use of biochar. So it increases the yield also, sir, of the crops.
Yeah,
and in expensive soils.
Agriculture material, what you call agriculture waste, it is, or organic matter, isn't it?
Sir.
So organic matter generally increases the compressibility of soil.
Okay, sir.
How do you think? I mean, just the sake of analysis only. That's why, since we got interested in that, we are trying to inquire into that. Generally, we consider organic soils are considered to be more compressible compared to the non-organic soils. That's by adding this, we are making the soil to be organic. Can you think over onto this?
I will try, sir.
Yeah, compressibility probably as per existing theories, it increases.
Okay,
Yeah.
okay, sir.
Go
I
ahead.
will. I will.
Please go ahead with the other questions.
Thank you, sir.
If there is no other questions, sir, we can hand over to our session chair.
Yeah, I think
coordinator.
I will just, on behalf of V2, I thank the organizers for inviting us to chair and co-chair the session, and especially Satyanarayan Reddy Garu and his team for wonderfully organizing the IGC 2020. First of its kind, be online. It is a very good experiment. I think they are very successful in this. We thank and appreciate and congratulate the whole IGS 2020 team on behalf of us.
And also one more thing, sir. We were given the session need to closed by 15:45, so we are 6-minute delay.
Yeah.
But that too, I think we learned COVID teachers taught us.
So when our people are not really COVID, authors are very enthusiastic. They are getting it later. Yes, sir?
Good. So thank you very much, sir. Thank you very much. Thank you very much to all IGC.
After a long time. Thank you. Thank you.
Thank you.
So thank you very much, Professor Sai Baba Reddy Garu and Sri Madan Kumar Garu for excellently conducting the session. And very happy to see that almost, I think, all papers presented, right? 11, how many, Madan Garu?
150 as missing.
How many papers presented?
No, only one paper left, but one more paper actually last minute they came, but we don't have time at that time. So almost only one paper missed. Yeah.
Okay. So 11 papers were presented.
Yeah.
So thank you very much, and I appreciate all the others who has prepared the paper and also came for presentations. Appreciated their efforts. Once again, from my side, I congratulate all the others for presenting the papers and also publishing the proceedings. I thank Sai Baba Reddy Garu and Madan Kumar Garu in this regard. So just to give a summary of theme 8 total, we had out of that, it's remarkably 72 papers have been presented by the authors. In the physical mode of conference, this would not have happened.
Yeah.
Okay, so many people they'll be there, and out of the 10-12 papers, maybe 6-7 would be there. This is the experience what we had, and this is really great that people could enthusiastically participate and present the thing. Only the issue is due to the time limitations, we would not be allowed them to present as per their thing. But I think reasonably effectively they made an effective presentation with the time given with this one. Okay. So with that remarks, I just close the session. Thank you all. Thank you very much.
Thank you.
Okay. So valedictory function not as per the schedule, and I request all the participants to join the valedictory function at as per the scheduled time. Thank you.
Thank you very much. Thank you very much.
Thank you. Thanks, everybody. Thank
you. Thank you very much.
Yeah, we'll discuss.
May I know what time the validity function is?
We can discuss, and then I will take you.
Sure.
Yeah. Hello. మురళీకృష్ణ గారు అది ఈరోజు ఆ రెండు ఫైనల్ చేద్దామా? ఓకే ఓకే సారీ.
Stop the presentation audio. Can you please stop the presentation audio? Stop that. Stop presentation audio. Don't select. Don't select. No, actually, don't select the presentation audio. Please click on the presentation audio.
Murli sir, are you there? Murli garu, are you there?
Yeah, I am here. I am here.
Yeah. Actually, one candidate has sent PDF format of your presentation as he is in hospital and he cannot make presentation.
Okay.
Can we just present those papers because presentation is required for Springer, no?
It's not
Can
necessary.
we allow or will not?
What is which number? Others are there?
Others are not there. Co-others are not here, it seems.
Which number? What is that paper number, sir?
It is in mail and find out.
143, huh?
1 minute, 1 minute. They are in other themes, sir. Theme 913, 924, 13.2 and 1339. Since here session is completed early.
Which session? Some other session, huh?
Some other session. Theme 13 and 9. 13, I think it is going on there. Ramesh, I'll get these things presented there if they permit. Team 9, can we do here? Modeling, because already that test is over in the morning.
Over. Oh, okay.
Candidate is not there.
Then okay, you can leave it, sir.
We'll leave it. Okay, sir.
You can leave it.
Okay.
You can inform the particular session chair.
Okay, sir.
I think we need to inform this. Somebody is asking what time the valedictory. So
4:30, sir. 4:30.
4:30, no? We can start at 4:30. Maybe.
Thank you.
We can display that one now.
Yeah.
Maybe valedictory.
We'll display that, sir. Okay.
The banner. At the next session at 4:30, valedictory and display.
Let me put this. So thank you for wonderfully conducting the session, 2 sessions you have organized today. Thank you very much for effective organization.
Excitedly looking for the validation.
Yeah.
Hello. Tech support, can you hear me?
Madam, yes, please tell me.
Can you hear me? Can you hear
Yes,
me?
yes, ma'am.
Thank you.
हेलो सावन जी, नमस्कार।
हेलो, हाँ आ रही है आवाज?
हाँ नमस्कार, आ रही है।
अच्छा,
नाइस टू सी यू थ्रो ऑनलाइन और थ्रो आईजीसी।
अच्छा अच्छा अच्छा।
एक मीटिंग कर लें क्या?
अरे वाह समाधि जी, नमस्कार।
नमस्कार।
प्रेसिडेंट साहब आ गए।
एक मीटिंग कर लेते हैं।
मीटिंग में हूँ मैं, जरा थोड़ा
इसमें बाकी कैसे करते हैं?
क्या
IIT Roorkee internal meeting is going on.
नमस्कार Ramaria sir, नमस्कार.
हाँ नमस्कार नमस्कार.
Respected professors, namaskaram.
Namaskar everybody.
Satish.
Arey Murli, how are you?
I'm good.
Satish.
Arey, nice to see
How are you, sir?
Satish is also there. Satish Pisni.
Hello, Professor Babu.
नीचे वाला नहीं.
Sir, how are you, sir?
Fine, sir.
नहीं, उसके ऊपर एक है ना open room का.
Good evening, Babu sir.
Good evening, Professor Raman. It's so nice.
Babu sir, you should be very happy today. Very good
Yeah,
conference.
correct. Yeah, I'm very happy.
Yeah.
And,
Sir, I am lot of nostalgic feeling will be there.
Kulkarni
Yes,
sahab,
sir.
namaskar.
Professor Babu, Professor Samadia, Professor Mahendra Singh.
Namaskar sir.
Love you.
Bagli sahab, namaskar.
Sir, namaskar.
Bagli sahab,
Good evening, good evening.
थोड़ा सा कैमरा एडजस्ट करिए बागली साहब.
मेरा वो चला गया वहाँ पे. एक बता दो आपको.
बागली साहब थोड़ा सा कैमरा. Yeah, it's okay now.
नमस्ते सर.
Hello.
Hello, Sundaram साहब, नमस्कार.
नमस्कार सर, कैसे हैं?
हेलो सतीश.
सबके नमस्कार सर.
नमस्कार.
संजय
अरोड़ा जी नमस्कार.
नमस्कार सर, नमस्कार. Everybody नमस्कार.
Everybody namaskar.
Everybody namaskar. Everybody namaskar, sir.
It's good.
We have 110 people in the last session, which is very good, unusual. Because that's why, that awards we kept it to last, no? That was a trick. Otherwise, it was, normally all the awards were given in the beginning itself. Now we shifted most of them towards the close. So,
Sahuji, namaskar.
Namaskar, everyone. Namaskar, Professor Babu.
Professor Sahu, namaskar.
नमस्कार सर.
संजय गुप्ता जी.
डॉक्टर एपी सिंह जी नमस्कार.
सर नमस्कार. सर IGS की मीटिंग ही कर लेते हैं. एक्स प्रेसिडेंट, सेक्रेटरी, एवरीबॉडी is there.
It's 116.
Including the non-EC member.
फिर उससे हो जाएगा. अभी हो जाएगा.
Sir, your advisor.
Launch meeting हो जाएगा.
किसी ने बोला नॉन EC मेंबर.
मैंने बोला.
Sir, you are above the above the EC members.
So nice of you. So nice.
I agree. Sanjay is something a veteran.
I'm very happy to see beyond any nomination.
So nice of you. Thank you.
Thank you, sir.
Officer Solanki, hello.
Hello, good evening, sir. Good evening.
Good evening, calm and quiet.
Good evening to all of you, sir.
How are you?
Good evening to all of you.
Good evening.
Good evening, Kulkarni sahab.
Okay, yeah, I think time to start, Professor Satnan Reddy.
Yeah.
4:30. Yeah.
We'll start, sir.
Good evening to all.
Dr. Adilakshmi.
Hello, sir.
Lakshmi can start.
Hello, sir. Yeah. So, good evening to you all. And sorry for disturbing the heavy traffic of namaskars, namastes, good evenings, and all. It's such a pleasant thing to see here.
Everybody is very happy.
Yeah. But I'm forced to say a few words, welcome words to you. So, kindly permit me to go ahead. Yes. Satyanarayana Reddy garu, do I take off? Yes.
Okay,
please.
Yeah, time fleets, and here we are on the third day, rather the closing day of the 3-day Indian Geotechnical Conference 2020. I'm very much honored to be here to welcome the distinguished delegates to the valedictory ceremony of Indian Geotechnical Conference 2020, focusing on the developments in geotechnical engineering for a sustainable tomorrow digest. Organized by, may I request all others to kindly mute so that it doesn't disturb the proceedings. Thank you. So this has been organized by the Indian Geotechnical Society Visakhapatnam in association with the Department of Civil Engineering, Andhra University College of Engineering, Visakhapatnam, under the stewardship of a chairman, Professor Sachinand Reddy Garu. A team IGC has taken every care to see that this virtual conference will be a memorable one. Personally, I'm very proud to be a part of this geotechnical fraternity where theory and practice go hand in hand. They're like two eyes here. I'm very sure that both the experienced and budding engineers would have been benefited from the conference. Literally, this conference has showcased the entire spectrum of geotechnical research from all over the world. We have also made our efforts in treating you with a rich cultural feast yesterday, which was Kuchipudi Kadambam, and I hope you all appreciate our efforts. Except for the dinner or the banquet dinner, we could do all that is possible virtually. So on the first hand, I request Professor CNV Sachinand Reddy Garu, organizing chairman of IGC 2020, to give his report on IGC 2020.
Thank you, Dr. Rajalakshmi. Good evening to all of you. On behalf of IGS Visakhapatnam chapter and Department of Civil Engineering, Andhra University College of Engineering, I invite you all to the valedictory function of the prestigious Indian Geotechnical Conference 2020. So I'm happy to inform you that all the 14 keynote lectures that have been printed in the brochure and posted on the website have been delivered by the experts from India and abroad. And also coming to theme lectures, all the 12 lectures have been delivered. And out of the 327 camera-ready papers received by the organizing committee, 305 papers have been presented by the authors. I think this is the maximum number of presentations that took place in any of the IGCs. It was possible because of this online conference. And we have tried to make this virtual conference to more nearer to the real event. We have tried our best to bring this virtual one into a reality. I hope all of you might have enjoyed the 3 days of this conference. So I take this opportunity to thank Charles Ng, President of International Society for Soil Mechanics and Geotechnical Engineering, Professor E.C. Shin, Vice President Asia, International Society for Soil Mechanics and Geotechnical Engineering, for gracing the occasion and for delivering keynote lectures. I also thank Professor Jihan, Professor Gopal Madabushi, Professor Poppala Anand, Professor Sai Vanapalli. So in spite of their local times, they were present here to deliver their keynote lectures for the benefit of the delegates of this conference. So on behalf of the organizing committee, I thank them. So this particular conference is very important to Andhra University also, because the Andhra University is presently in its 95th year of its service. We are proud that we are able to organize this important event in this particular year. And our IGS Visakhapatnam chapter is proud to host this conference for the second time. First time IGC was held in 1989. So we are happy for that. I would like to thank Professor Sirish of IIT Hyderabad, Professor A. Murali Krishna of IIT Tirupati, Dr. Nilma of IIT Indore, Dr. Sumanta Haldar of IIT Bhubaneswar, Professor Muthukumaran of NIT Trichy, and Sri Ravikiran Vaidya, Geodynamics, Vadodara, for their help in planning the various activities related to reviewing the papers, taking decision on whether to reject or accept, and then again for assigning reviewers for full-length papers, going through the reviews, and finally selecting the papers. So throughout the period of this COVID-19 affected period, I was disturbing them through WhatsApp or through phone calls, even midnights also. They responded and helped me to a lot. So that is the reason why we could do reasonably good job. And also they are putting in their best efforts to screen the papers further for finalizing the papers for Springer volumes. So thank you very much. Not only that, they have also acted as coordinators for technical sessions. And within this short time, though it is online event, they helped me in finalizing even the prize winners for Springer Best Paper Awards. So I thank them. Without their help, I would not have done all this. And in addition to that, I thank Professor B.V. Shishwanathan, Professor Mahendra Singh, Dr. G.V. Ramana of NIT Warangal, and Professor M. Ramarao for helping us in organizing the technical sessions. I take this opportunity to thank all the 75 reviewers. I cannot read out the names because list is exhaustive. So they have done an excellent job. We have troubled them during initial COVID lockdown period. In spite of that, I don't know whether many of them are having systems at their home or not, but still they have reviewed in time and provided valuable reviews. So I thank all the reviewers for their effective evaluation. Not only that, after that, full-length papers also, they have given not only comment, they have also uploaded the annotated file for the benefit of participants. So thank you very much, sir, for your excellent support to our organizing committee. And we could prepare, as usual, the 42nd IGS annual lecture volume. In addition to that, we have brought out abstracts, IGC 2020 abstracts volume separately, proceedings volume with page numbering for papers in each of the teams, so that even if some papers are not going to appear in Springer also, those others can cite their papers. So that is also done. And also souvenir has been brought out. So all these things we could bring out as per the schedule. So I hope all of you might have gone through these things, which are shared through emails. Links have been sent, so you can go through them. I hope all of you will see what specialty we have shown there. So if any further suggestions are there, you can tell, because souvenir printing we need to do, and we need to circulate it to sponsors and other local bodies who have supported us for IGS headquarters for our Andhra University reference. So printing will be done. Next. I thank Swati Maharshi, Editorial Director, Applied Science and Engineering at Springer Nature, for agreeing to bring out the Springer Proceedings volume in 5 books, and also for sponsoring prizes for best papers to the authors presented in various themes. So we are very much thankful to Springer. And on behalf of organizing committee, I thank all the sponsors, co-sponsors and supporters, because we know that business are down for them. But in spite of that, some of the firms have come forward and supported us. And we thank all our other IGS local chapters who have extended their support as sponsors, co-sponsors, and supporters. Particularly IGS Pune, they have come forward as sponsor. So special thanks to them. And coming to preparation of these proceedings volumes and abstracts besides our technical team, so irrespective of templates that are given, we found that some of the others could not do it properly. So I had to trouble my students, and in this particular direction, in proceedings volume preparation, I took the help of Miss A. Harika, Miss Akila, and Miss Raj Priyanka. So they have gone through all the papers. They have checked for the formatting, and finally Harika has done the entire page numbering, preparation of proceedings with appropriate page covers and all. She was with me for the last more than 1 month. And abstracts volume also, I got it compiled through her only. And I have one more scholar of mine, Vishwateja. He was instrumental in preparing the souvenir. So I was guiding, and he was doing whatever souvenir you are seeing in the present form. That is done by him. I thank him very much. Almost he spent me many nights beyond 12 o'clock. I thank him. And one more research scholar of the department, Mr. Srikanth Reddy. He has been helping me in several ways. Being a relative of mine, my sister's son, I troubled him a lot. Whatever scheduling, many revisions, whatever we were doing, I was doing right with his help. Not only that, my son is there studying 9th standard. So since I was working for the most of the time from home, I troubled him a lot. He likes working on computer, and he helped me like anything. Particularly initially for online activities, we are not well versed. So initial 1-2 seminars, whatever I was organizing, he used to help me. And later on, myself, Teja and all, we took over. I hope whatever form you have enjoyed IGC 2020 is the effort of, I can say, Vishwateja, my research scholar, faculty member from Manits, and my son, Krishna Srikar. So I take this opportunity to thank President Shivkumar Babu sir and Secretary J.T. Shahu sir for their continuous monitoring and guiding in planning and organization of this mega event, Indian Geotechnical Conference 2020. I thank the EC members for reviewing the situation from time to time and providing the guidelines, how to go about it, and all at different stages they were giving useful suggestions. I thank them. And also we have a separate committee for organizing this IGC 2020 constituted by IGS, and they have given me also very important inputs, and I was seeking for some corrections or advice, and they were always readily available and helped me a lot. So I thank all the geotechnical good friends of mine, EC members, my department colleagues, particularly my organizing secretaries, organizing committee. Coming to organizing secretaries, we have Professor P.V. Satyanarayana, my colleague from Geotechnical Engineering, Professor Aramsati Abulu, another colleague of mine, and then we have Professor B.N. Narasimha, Professor and Head of Civil Engineering Department ANITS, and Dr. Rajalakshmi is co-organizing secretary, and one more co-organizing secretary is Dr. ACSV Prasad from SRKR College. So all the organizing committee members have supported me well from time to time. So that is the reason why we could organize an event without any schedule, in spite of the most difficult conditions which you are facing. Whatever I was proposing, they were readily accepting, and they were providing me the required approvals and suggestions. I thank them very much for their continued support. I thank my departmental colleagues, and particularly my head of the department, for his constant support and encouragement. So I thank our university administration, particularly Vice Chancellor, Professor PVGD Prasad Reddy, Registrar, Professor Krishna Mohan, and Principal, Professor Per Srinivasarao Garu, for supporting right from day one of starting of the events and providing all the required facilities. So I'm very happy that we could do IGC 2020 given to us without any delay, in best possible manner, with the participation of more number of participants, and also having more presentations by the others. So I thank you all for taking interest and participating in this event for the last 3 days and actively participating in the event. So if we have taken extreme care in doing our best, but in spite of that, if there are any mistakes or errors happen from our side, kindly excuse. So with this, I thank you all.
Thank you, Professor Satyan Reddy, for a very elaborate reporting on the way that it is the IGC 2020 is conducted. We'd like to have some feedback from the the attendees, please. Can I have feedback? Some, the feedback is, it can be what are the lacuna we observed. Let me be very clear, because the online mode has been the first experience, first time in India, perhaps. I'm not sure about any other conference. At least in our own community, we have been, this is the first time. So kindly give your feedback. Maybe it will help many of us to really plan this type of events in the coming future. Please let us know your, some feedback, please.
So, Magli here.
Yeah.
Last October, just 3 months back, there was a conference, Geo Americas.
Yeah.
It was organized by the Brazil International Geosynthetic Society. That also, like this conference, was on the web.
Yeah.
I'm proud to tell you that this Indian conference, a local conference, was far better than Geo Americas. Better organized and definitely better in content. That's my reaction.
Okay.
Professor Babu, I also have the same view. It is excellent. It has been an excellent conference as far as dissemination of knowledge is concerned.
Right.
So excellent. I don't find any lacuna. Means everything was well planned. The sessions were conducted in time. Everybody was there in time. So I don't find anything which I should say that okay, you improve here or there. It was excellent. Means from technical point of view, I should say it was excellent.
Right.
Yeah.
Anybody from youngsters or somebody, like we know veterans are able to speak, but would like to see from youngsters, can we improve in any way, or any new introductions are possible?
Yeah. Good evening, sir. This is Atashi Das. I just wanted to mention that except that Dr. Rajalakshmi already mentioned that except the gala dinner, but the other thing that we missed definitely were the technical booths and the showcase of the sponsors. So that one thing, maybe in the near future, as I know that TRB in America, they are going to organize one. Even the technical booths, they are going to do it somehow. So maybe in the near future, we can plan if again another, abnormal conference like on the web platform arrives, then we can do it as well. Think in those lines also.
Yeah, it is actually an excellent suggestion, because I think, see, the practice-oriented certain things like what you're mentioning, it could be additional to what we have already been doing, because it may need a different kind of setup. Thank you very much. Very wonderful suggestion. Yes. Any more suggestions, please? Yeah.
Professor, I would like to make. Come in.
Yeah.
Hello,
Sir.
Professor
Yeah.
Babu.
Hello, sir. Yes,
Sitaram here.
Sitaram, please. Welcome, sir. Great. Yeah.
Namaskar.
Yeah.
So let me first of all congratulate the IGC team 2020 because I logged in once in a while in between, many on all the 3 days. Okay. I found it very, very timely. They have maintained the timing.
Yes.
And very clarity was there. Not many people were disturbing online. Many of the other events, as Mr. Bagli was highlighting, a lot of noises and other things used to come. Here, it has been professionally done. Let me congratulate the Visakhapatnam chapter. Only we miss going to Visakhapatnam. See, that is the one thing. Otherwise it would have been a lovely experience meeting personally everyone. Other than that, it's fantastically organized. That too, when they were deciding to go offline, that is a regular conference, and only in the last minute they changed. Otherwise, even the exhibition, everything could be done online also. It is not a big deal. So first, I think we should congratulate the entire team who has worked very hard in putting up. Even the cultural evening was online, was almost like real.
Yes.
Almost like real. So we actually sitting in our own bedrooms, we can watch that, which is fantastic. So great. So good. IGCs are going in a big way. We should go further like this, reach out and have large number of membership, large number of activities. One beautiful thing I heard this today morning lectures is, even the testing by the geotechnical companies are also, the quality is increasing. See, I heard Kumar Pichumani today morning, and after that there was one more person who gave that talk, that is our G.V. Ramana on the Polavaram dam. I think the investigations are also going in a very quality investigations are happening, which is a good signal. I think it's a good time for geotechnical engineering in the country. Wish you all the best.
Thank you, Professor. Any more, please? We need to have, because they're all they help all of us. It's
Yeah.
Can I say one word? Only one word?
Yes, sir. Yeah, Ramesh, you can. Yes.
Excellent and excellent in all. I will say only excellent and excellent. And all the best for the chapter for conducting many more incidents and events like this. Thank you to all. Thank you.
Thank you.
Dr. Balkumar here.
Yes, sir.
Sir, in fact, I find that attending the online conference is more comfortable than trying to go in person. Because, see, the question is, there are a lot of clarity, there is a lot of comfort level is much more in online conference than you are coming there, traveling all the way, and then trying to, most important thing is, we always think how to carry the proceeding volume. It's so big. Now you see the volume is in the form of we could store it in a laptop, or you can just USB, and whenever we want we can read it, we can pick it up, we can prepare notes and go about like that. So I think in future we should try to encourage more on online conferences rather than trying to come and attend in the place and then spend time, money and everything. And you see, if there is any inconvenience, we can just 2 minutes you can go out and come back. There is no problem, right? So personally, I feel that the online conference, and it had been done extremely well. Yes, absolutely, there is no lacuna, there is no inconvenience as what I could see. So I think we will have to congratulate Professor Satyanarayana Reddy. They won't mistake me, because at that time I'm congratulating you. But it has been an excellent job that has been done by Professor Satyanarayana Reddy and his team. So we have to congratulate as a whole, and sir, as a chairman, as past president, who had been instrumental in doing this, I think you deserve much bigger congratulations, I would say. Right, sir? So the whole IG is organizing this conference. They have to be totally congratulated, and it's a very comfortable way of attending the conference. We never felt the strain of attending this, standing in a long queue, and all those things have been avoided. Excellent, sir. Thank you.
So let me just
add a couple of things.
One more.
Yes, sir. All
the recordings are also available. See, for the young ones, all the recordings are available so that they can go back and see these lectures. This is a fantastic thing. Anyway, only miss the food, the hot food of Visakhapatnam. Good luck.
So, I want to share a couple of things, sir. This is Murali Krishna.
Yes,
So I coordinated with the help of other co-chair and chairs and other coordinators for one theme, that is theme 8 of ground improvement. That's 75 papers got accepted. Out of that, 69%, 69 papers were presented. This would not have happened if it is in the physical conference. Obviously, 40 to 50% of people would be absent in the physical conference. A lot of vacancies would be there. That is one good thing what I could see here. All people participated actively and they presented and they maintained the time short also. That's one good thing what we achieved. I think considering this one, I think we should relook into the way of organizing the IGC also. Maybe one day completely physical thing with the formal meetings and keynotes will be there, and then other parallel sessions can be of virtual where the different people from different agency, different regions can participate. That's what coming to my mind. But it's a wonderful experience, really. All people there. Thank you, and particularly the president and executive committee and organizing team. They took a strong decision. I think initially it came announcement that it is postponed to after June or something. But again, you looked into the practical situation and again took a strong decision. And finally, great success that is a applause to whole IGS EC team and also organizing team. Thank you.
Thank you very much. Actually, I should say that we have been interacting on a daily basis, particularly the moment we start, we'll do it in June, but then we realized that it is also not possible because it's going to affect the organization of future IGCs and fund mobilization. There are many points. Then we could really, I think, full credit to Professor Satyanarayana and team. We were really wondering, we asked him how to present. Then we had a lot of discussions. And the result is today. And not only that, this opens up number of possibilities of further innovations, because our objective is to, give the technologies, knowledge, and all that. The kind of response we had for this conference is amazing. You have seen that. So I think we'll go ahead with the awards function now. Satyanarayana, is it okay?
I may add a small thing.
Yeah.
For future events, you may consider having a sort of a mixed, physical as well as online, where whoever would like to attend online can attend online, and those who would like to be physically present, they can come.
Yes,
that may be a good model.
Yeah. Even in valedictory, sir, there are 169 participants.
See, one important thing now in India, we have so many TC committees. In fact, we had about more than nearly 100 people appointed to various TCs. Many of the TCs now can conduct technical events. They can get in touch with their experts and have online events. Not only that, you can have online IGC, offline IGC if you want. I mean, it opens up a lot of possibilities. I think we should take advantage of this things, even demonstration of technology in geotechnical testing. Like there are a lot of things that one can be shown using videos and all that. I think we'll take this as a good blessing for all of us. Let us move forward. I think if any other further inputs are there, it's fine. Otherwise, we'll go ahead with the rest of the function.
Sir, I strongly agree with the previous speakers what they have spoken about the virtual, conferencing. Because the thing is, I am from Fiji at the moment. So likewise, even the participants from internationally, those who wants to participate for IGC, it's cost effective if we can conduct the sessions in virtual mode. So it is always good, as the previous speakers suggested. Whenever we are going for IGC face to face, there would be a session for face to face as well. There will be a session for virtual also. So even in domestic and internationally, the participants who wish to participate virtual mode, it's their choice, it's their wish. It will cut off and it will reduce the international, especially for international participants. It will be, saving of time, saving of money, everything. I think it's a good suggestion, sir.
Thank you. Thank you very much. So, Professor Reddy, shall we go ahead with the rest of the program now?
We can. Rajalakshmi?
Yes, sir. Yes, sir. We could feel the vibes of excitement from all the participants, and the response was overwhelming. But still, it feels so good to listen to all of them giving their wonderful feedback, sir. And all this was possible only because of the efforts of the president of IGS, Professor G.L. Shivakumar Babu Garu, Professor J.T. Shahu, and their team. So may I request Professor G.L. Shivakumar Babu Garu, president of IGS, to give his invaluable address.
Yeah, I've been talking already. I should say that this has been a valuable experience to IGS, particularly hosting this event. And we could have the ISSMJ president, which is not normally possible. He could immediately readily agree. In fact, I was in touch with him by WhatsApp as well because he had some communication issues. It was amazing that everybody was able to respond in time in a matter of a minute. And this is the way to go forward. And I think, I know how I interacted with Satyan Reddy myself. Every time, every 2 days, it was amazing. The moment we postponed, we gave a notice to postponement. Again, we have retracted the whole thing, and then we reworked, we did rehearsal. I know how much time we have put in, and how much background work was put in. So I think without any further information, anything, I would like to congratulate all of you, and let us take all the lessons from this program. Thank you very much. Let us go ahead with the rest of the program.
Yes, sir. It was absolutely consistent, I can say, sir.
Yeah, consistent.
Absolutely consistent. Thank you for that. I now request Professor J.T. Shahu, Secretary IGS, to give his address.
Thank you, Professor Rajalakshmi. Dear Professor Babu, President IGS, Professor Satyanarayan Reddy, Organizing Chair IGC 2020, esteemed guests, delegates, participants, awardees, students and volunteers, it gives me immense pleasure to address this August gathering and present much awaited awards. I hope that you have had past 3 days of great interaction and fruitful knowledge sharing in broad field of geotechnical engineering. Now we have come to the end of IGC 2020. As you are aware, IGS has shifted the presentation of Best Paper Awards, Young Engineers Award, Journal Awards, and Appreciation Awards in this valedictory function. And it is my proud privilege to announce recipient of these awards. After I announce the award, I would request the awardee who are getting this award to show their face, if possible, and may express few words if they wish before I proceed to the next award. So, allow me to share the screen. I will share my screen. Is it okay?
Doing, sir. We are doing.
You want to do that? Okay, great.
Yeah,
okay.
we will put the slides.
Okay, great. Okay, so next, I will announce first 3 awards related to review and editorial work of Indian Geotechnical Journal. So next, please. Okay, awards related to Indian Geotechnical Journal. Next. So EBM of the year 2019 award, the first award goes to okay, it goes to me only for contribution to Indian Geotechnical Journal. Okay, next, the second award, second journal award is the Reviewer of the Year 2019 EBM award, and this award goes to Professor Maheshwari. Is he there?
Yeah.
Yes, in recognition to his outstanding contribution to the Indian Geotechnical Journal. Professor Maheshwari. Yeah, you want to say something? Okay.
Hello.
Yeah.
Hello.
Yeah, tell me.
Good evening, sir.
Yeah, tell me.
Sir, you had messaged me.
You are not there for IGS award?
No, sir.
Why?
Oh,
Yeah.
he's mute.
He's unmuted now.
Yeah, Professor Maheshwari.
Yes, sir. Am I audible, sir, now?
Yes, yes.
Okay, thank you very much. First of all, I will like to thank to the organizing committee of this conference, as well as the chief editor of this journal. And let me put this award is not to me, rather it is a recognition of the work, and it encourages to have the further, good review work. And thank you very much with that.
Thank you. The third award of the journal is the Reviewer of the Year 2019 Non-EBM Award. And this award goes to Dr. Amarnath Hegde. So Amarnath Hegde, you are there? I saw you.
Yes, I am here, so I am audible, I hope.
Yeah, you are audible.
Yes, thank you, sir. So first of all, I thank IGS and also Editor-in-Chief of Indian Geotechnical Journal and also all the selection committee members for selecting me for this award. And I'm very delighted to receive this award, and I dedicate this award to all my students who helped me in reviewing those papers on time. Thank you. Thank you.
Thank you. Thank you. Now I will announce the 12 Best Paper Awards. Now I will announce 12 Best Paper Awards. These awards are given biennially. When an award-winning paper is authored by more than one author, any of the authors may show their face and they may express their feeling on behalf of all the authors. So the first award is IGS Emil Biennial Award for the best paper published in Indian Geotechnical Journal. So this award goes to Amar Shankar Pal and Dilip Kumar Vaidya. And the paper was Effect of Soil Layering on Coupled Dynamic Response and Active Length of Piles Embedded in Layered Soil using Cone Model. So Amar Shankar Pal or Professor, yeah, he's there. You want to say something, Amar Shankar?
Yes, myself, Amar Shankar Pal. I'm very happy to receive the award. I want to actually very much thank you to selection committee and Indian Geotechnical Society for choosing me and my paper for this award. Thank you. I want to thank you also my guide and Professor Dilip Kumar Vaidya, and that's all.
Thank you. Thank you. The second award is IGS Emil Biennial Award for the best paper on instrumentation. And this award goes to Vinil Kumar Gade and SM Dasakamurthy from IIT Bombay.
Thank you, sir. Myself, Vinil Kumar Gade. Thank Indigenous Society, Editorial Committee and Selection Committee, and I also thank my professor, H. Nanamurthy Dasaka from IIT Bombay. So with his continuous support and guidance only, we achieved this award. And thank everyone for awarding this Best Paper Award on Instrumentation.
Thank you, Vinil. Thank you, Vinil. The next award is IGS FCON's Biennial Award for the best paper on case histories. This award goes to Professor BVS Viswanatham and Pankaj Kumar. So Viswanatham or Pankaj Kumar is there? Okay. The authors are not there, seems. So we can go to the next award. IGS Srimati Indra Joshi Biennial Award for the best paper on environmental geotechnology. And the award goes to Garima Gupta, Manoj Datta, GV Ramna, and BJ Alapat. So
thank you, sir. I'm highly grateful to IGC for selecting me for this award and to my professors for being a constant support. Thank you so much.
Thank you, Garima. Thank you, Garima. The next award is IGS ONGC Biennial Award. Next. IGS ONGC Biennial Award for the best paper on marine geotechnical engineering. And this award goes to S. Vibha, S. P. Srinivas, and GL Sivkumar Babu.
Thank you very much. So thank you very much, Prof. Sahu. Yeah.
Okay.
Thank you very much, Prof. Sahu. Yeah. Thank you.
The next award is IGS Geotechnical Biennial Award for the best paper on innovations in field exploration. And this award goes to Janmeet Singh and Sanjay Kumar Singh. Janmeet Singh, SK Singh, anyone? Okay, so we go to the next award. IGS Professor C.S. Desai Biennial Prize for the best paper on constitutive modeling for geologic material. And this award goes to Rahul Singh, Aragya Das, and Rajesh Satyamurthy from IIT Kanpur. Yes, anyone from this group? Okay. So next award is IGS Sri A.G. Dastidar Biennial Prize for the best paper on ground improvement. And there were a lot of entries in this category. And the best paper award goes to Sandeep Bandipalli, Chinchu Cherian, and Dali Naidu Arnepalli from IIT Madras. Anyone? Sorry, the names are not visible probably in this screen. Anyway, so anyone there from this group?
Yeah, good evening, sir. This is Sandeep Bandipalli. I would like to thank IGF committee as well as my guide, Dr. Dalinaidu Arnepalli, and my co-author Chinchu Chetian for their esteemed guidance. Thank you, sir.
Thank you, Sandeep. Thank you, Sandeep. The next award is IGS ZTech Biennial Award for the best paper on geosynthetics and allied construction products. And this award goes to Shantanu Patra and JT Sahu. Shantanu.
Good afternoon, sir. I'm Dr. Shantanu Patra. So I would like to thank the organizing committee, the Indian Geotechnical Society, and my co-author and my supervisor for all the support and help to make this, to get this paper. Thank you all.
Thank you, Professor Patra. The next award is IGS Warangal Chapter Biennial Prize on solutions to the problems of expansive soils. And this award goes to Nigade Saha Sanjeevani D and BVS Viswanathan. Yeah, Nigade Saha.
Yes, sir. I'm here.
Yeah, you want to express?
Yes, sir. I thank IGC for selecting me for this award. I also thank my guide, Dr. Vishwanatham. I thank IIT Bombay and my parent organization, PWD Government of Maharashtra, for allowing me to pursue my PhD at IIT Bombay. Thank you very much.
Thank you, Sanjeevani. The next award is IGS Chennai Chapter Biennial Award for the best paper on deep foundation and retaining structures. And this award goes to Ashish Gupta and VA Sawant from IIT Roorkee.
Good evening, sir. Hello.
Yes,
Am I audible?
Yes.
Good evening, sir. Thanks organizing committee IGC 2020, and thanks IGS committee for selecting my paper as this best paper award. And thank you, Sawan sir. And I dedicate this award to my guide, respected Professor V.S. Sawan sir. Thank you, sir.
Thank you, Ashish. The next award is IGS PJ Rao YR Full Biennial Award for the best paper on geotechnical professional practice, and the award goes to Minali and Dipanjan Basu. Yeah, Minali, Dipanjan Basu, anyone there? Okay. If they are not there, then we go to the next category of award, that is the Young Geotechnical Engineers YG Awards, which are again given biennially. So a few years back, IGS instituted these awards to motivate and encourage young geotechnical engineers to participate in geotechnical research and fieldwork. Now I will announce 1 year Young Geotechnical Engineers Best Paper Awards, and that will be for 2020. This award carries a memento and certificate. So first award is IGS Kochi Chapter YG Award for the best paper on deep foundation. And the award goes to Kaustav Chatterjee.
Thank you, Professor Shahu. I'd like to thank the organizing committee, the selection committee, and IGS for selecting this paper of mine for the award. And also I'd like to thank my supervisor, Professor Dipankar Chaudhary from IIT Bombay, for all his support during my PhD career. Thank you. Thank you very much.
Thank you. The second award is IGS Ahmedabad Chapter YG Award for the best paper published during immediate past Indian YGE conference. And this award goes to Gopika Rajgopal.
Good evening, sir.
Yeah, go ahead.
I would like to thank the organizers of IGC 2020 as well as 7i YGC 2019. I would also like to take this opportunity to thank my guide, Dr. Sudish TK. It was a great experience. Thank you. Thank you all.
Thank you, Gopika. Thank you. The third award of the YG category is IGS Delhi Chapter YG Award for the best paper on computational geomechanics, and this award goes to Vamsi Nagaraju. Vamsi. So if Vamsi is not there, we proceed to the next award. That is the IGS MD Desai Memorial YG Award for the best paper on geosynthetics and natural fibers. And the award goes to Riya Bhaumik.
Riya Bhaumik को भेजे, salary so student को भेजे. Young geotechnical.
Riya Bhaumik, is he there? Is she there? Okay. So next category of award is next award is IGS Guwahati Chapter YG Award for the best paper on soil dynamics and earthquake engineering. And this award goes to Hasti Venkateshwarlu. Yeah, please go ahead. Venkateshwarlu, you are not audible.
Hello, sir. Am I audible?
Yeah, now you are audible.
Sir, firstly, I would like to thank IGS for selecting my paper for this award, and I would like to extend my thanks to my supervisor, Dr. Amarnath Hegde, for his esteemed guidance and support for getting this award. And I would like to dedicate this award to my parents. Thank you, sir. Thank you so much.
Thank you, Asti. Thank you. The next award is IGS Baroda Chapter YG Award for the best paper on ground improvement. And this award goes to Mr. Samsad Alam. Samsad Alam?
Yes.
Yeah, please.
Yes, I am Dr. Samsad Alam. Thank you for the Indian Geotechnical Society committee members for selecting my paper. And I would like to pay my thanks to my supervisor, Dr. Sarat Kumar Das, for his support. Thank you.
Okay. Good. Thank you, Samsad. Thank you. Finally, I will announce 3 very special appreciation awards which are being given to IGS chapters for some special work they have done during the year 2020, especially during this COVID period. So first appreciation award for 2020 is given to IGS Surat chapter for successfully organizing IGC 2019. In recognition, IGS Surat chapter will be presented with a memento and certificate. And I request Chairman and Secretary of IGS Surat chapter to please show themselves and if they want to express.
On behalf of the IGS Surat chapter, I, Professor Chandresh Solanki, thank the IGS for awarding this appreciation award. We dedicate this award to our research scholars and PhD students of SVNIT. Thank you.
Thank you, Professor Solanki. It was magnificent IGC 2019 and we still remember it and will be remembering for several years down the line. The next award is IGS Mumbai chapter conducted excellent technical activities for professional credibility. And in recognition, IGS Mumbai chapter is presented with a memento and certificate. I request the chairman and secretary of IGS Mumbai chapter to show themselves. IGS Mumbai chapter.
Yeah, Professor Sahu, thank you very much for the award given to IGS Mumbai chapter. So we are thankful to the IGS main body and all the EC members for the continued support. Thank you very much.
Thank you. Daska Murthy, right?
Daska Murthy. Yes, sir.
Okay, thank you, Daska Murthy. He is secretary of IGS Mumbai chapter. The third award is the third appreciation award is for conducting technical activities for the benefit of students and for doing a lot of work on related to student chapter. And this was done by IGS Guntur chapter. In recognition, IGS Guntur chapter is presented with this with a memento and certificate. And this is the third appreciation award. Professor Ramarao.
So, sir, is it audible, sir?
Yes, sir.
Yeah, audible.
Crystal clear.
On behalf of IGS Guntur chapter, I am thankful to speakers, participants, and IGS Guntur Executive Committee and advisors to student chapter, and IGC 2020 organizing committee, and also Indian Geotechnical Society selection committee. Thank you, one and all.
Thank you, Professor Ramarao. Thank you, Professor Ramarao. And with this, award ceremony comes to end. With this, I wish all the best to one and all present here and hope to meet you during IGC 2021 at Trichy next year. Wish you a very happy Merry Christmas and Happy New Year 2021.
Okay, Professor Sahu, can I say something?
Yeah, please.
Okay, so as we have witnessed a
very magnificent IGC 2020. So congratulations to the organizers, especially Satyanarayan Reddy, Professor Satyanarayan Reddy and his team for putting in all these efforts. Very hard work done. So I would like to appreciate from my side and on behalf of IGS and give them a big hand. And it would not have been possible if the guidance given by Professor Shivakumar Babu and his team is not available. And we have seen that in the last 4 years, there have been lot of activities and the new initiatives taken by Professor GL Shivakumar Babu and his team. So on behalf of the incoming team, I would like to place on record the efforts done by the previous team, outgoing team, and as a token of love and appreciation, I would like to present an appreciation award to Professor G.L. Shivakumar Babu, the outgoing president. Professor Babu. Professor Babu there? So the appreciation award will be sent to him. Thank you, Professor Babu, for working so hard for the growth of IGS. And as I have said in the my address, that this team has raised this bar, so we will have to work very hard, and we assure you that the new team will also be working very hard and put in all the hard work which is required for the upliftment, growth of the society.
Thank you. Thank you. Professor Reddy, you have Springer Awards? I just wanted to know. That's like some more awards. Some more awards.
Sir, we need 5 more minutes.
Okay. Okay.
Consolidating. Meanwhile, you can invite.
Okay. Then let us have some more opinions on. Because we wanted to have Springer Awards also to be completed along with this. I'm sure they will be there waiting for them. So others can express how best we can do further.
Yes, the more the merrier. It's so nice to see all the brightness. Yes, we have also awards from Springer for best papers. May I call upon Ms. Swati Maharshi, Editorial Director, Applied Sciences and Engineering at Springer Nature, to kindly join us. Ms. Swati Maharshi.
Swati is here?
Not sure, sir.
Or if possible, she will join, like that she was telling. Probably she is not there.
Okay, you can announce, I think. Yeah, you can announce.
We'll announce, just 5 minutes. Meanwhile, you can have interactions.
So, sir, can we go ahead with the interaction? Or,
yeah. Please go ahead. I mean, feedback.
Feedback from all the others, yes. We would love to have the feedback.
No, we want to know how professionals can use this platform to demonstrate new technologies. Or I think somebody can mute those people.
Tech support, I request that.
Okay. No, the question is that, say, for example, I know that, say, how do you measure SPT hammer energy? Can it be shown to all the participants? Because it has been $1 million question that we are still following the very old testing methods and practices. So does some of the experts from the group can really come up with some good videos on the best practices possible elsewhere in abroad, or how we can demonstrate here? Maybe that I think we should have some ideas on that. Otherwise, it becomes difficult. Like skill development is required in the country, and I think this is a platform that one can use. One can conduct a lot of spread the message properly. Maybe Ramesh Kulkarni is here. I hope some veterans are there in testing here. Many people are veterans are here in testing. They can throw some light on how testing and Ravi Sundaram is here, and many veterans are here. They can show some.
Sir, I'd suggest that we should select a battery of topics and technologies which need to be made popular in the country, and people who are the experts in this subject may be asked to make a video on the subject, and once the video is made, we could have an online or offline, whatever kind of an event, and people can then discuss with that expert and doubt clarifications on that. And then of course the instrumentation, the companies which sell the products, they can also be involved, so that the industry actually buys the necessary products and starts utilizing it for the benefit of the industry.
So, for example, I was just wondering, there's a lot of unlearning that has to take place first in India about SPT or something. That is
Yes.
other. So, I think we need to develop Samadja to Samadja. I think it is now we have a lot of work that one can do, like particularly videos. Professor Pichaman was able to show that on very good instrumentation of that whatever. Even Professor Ramana was able to show, like if they can give a very good, only specific, very much more clearly for a general audience, and then see that how they can be used. Particularly, I'm talking about on the instrumentation part of soft soils. I myself have come across one site where it was not really well done. So it was very difficult, after getting involved, and we find that case studies like this will be of valuable help, like using inflometers, using pore pressure sensors, and all of that. As you rightly pointed out, the companies like ML should also come out with some solid programs on instrumentation, or say, for example, excavations. We know the common failures in a ground is that excavations, we had many collapses. Like, can we make excavation monitoring beyond 10 meters should be compulsorily instrumented? There should be some law in the country. Like, there should be some stand we should take, like, looking at the consequences, for example, in a highly congested, busy area, if it is there, and excavation beyond one floor or something, 3 or 4 meters, it should be definitely instrumented. All testing has to be done, and proper methods of stabilization should be adopted. All of that has to be spread across, because we have so many youngsters receiving awards. The receiving awards is not the end, it's a beginning for them to really pick up good practices and see what can be done. We have seen examples of this many times in student chapters, that they're able to pick up. In fact, the final year students from student chapters, they have become consultants. I know 1 or 2 case studies where they have become very good consultants and working on expansion soils in some parts of Karnataka. So what I want to appeal to the audience, august audience here, that we need to really promote very good field testing and interpretation and instrumentation. It is like testing, there is no substitute for good testing. That we should realize. Any other expert on instrumentation, like Dr. A.P. Singh, would like to say something? Dr. A.P. Singh, you have something?
Yeah, good evening, sir. Actually, instrumentation and testing, that needs to be more emphasized. And whatever parameter we are getting, we should take it, whether it is a very small parameter or very useful or may not be useful, but it should be recorded very properly, very accurately. So like you were saying, this SPT, how to improve the SPT. The thing is, SPT should be properly done up to the explored depth. And there should not be any leniency, and there should be the proper empanelment of the agencies who are in this field, and some check on them also. It should be they are doing it everything properly or not. And certainly we need more design of the instruments, field instruments, and for the promotion of this instrumentation too, that is needed. So we should not take the basic investigation parameter lightly. It is like an FIR of any case. Whatever we are giving, that is really making a foundation for geotechnical investigation. So instead of going with the very advanced testing and monitoring, we should emphasize on this basic parameters, whatever we are going to get. So we need to properly monitor the field test, and proper design and fabrication of the required equipments also. Suppose we are for the very good, very accurate conducting the SPT, we need auto trip hammer and everything, all those things. If you go and see the most of the investigating agency, they are not having it. So
unless
we
you,
should motivate them.
It's not about 1 second. I'm just want to say it's not about motivation. The thing is, it's like I think it should be in the law. It should be in the code.
Yeah, exactly.
Yeah, for example,
if they are not motivated, then it should be a mandatory law for them.
Yeah,
you have to follow. Otherwise, we will not accept your any this parameters.
In fact, I was suggesting one thing. Like say for example, there are so many codes, IS codes, IRC codes. But if you look at both of them, people get confused. Whereas as IGS, we don't have our own codes. I think it's a responsibility of people like all of us, like particularly professionals, to come out with the IGS set of guidelines so that they provide a clarity on whatever are the field issues that are there. People are struggling. At least a document or explanation. If not, because IS code format is different, which will allow, or even IRC format is different. But when there is a lot of confusion about geotechnical parameters, it is our responsibility to really, consolidate all of that information, present it in a proper way. Otherwise, you are very busy in only clarifying and doing a wrong, other thing. Other thing that I was always mentioning, actually, we have experts from...
many things are like NABL accreditation, and only those agencies should be allowed who are having basic minimum facility in their laboratory and as a technical manpower.
So even NABL accreditation alone was not really helpful. That's what I said. That's why IGS has an association with NABL, and whether we have NABL association or not, we must be able to insist on the good quality testing that is supposed to be there. I just want to take another, my request to Roy Chowdhury, that she is an expert on reinforced soil. We have so many failures of RE walls in the country in spite of the technique being so successful, and we know that nothing should go wrong there. Maybe she can, Roy Chowdhury or our Bagli ji can really throw some light on how do you avoid these failures. Like what is a set of guidelines that are required? Because in fact, today only I signed one document where there was a clear failure because it was not some of the places were exposed, and the road was exposed in some places, and as a result of that, a lot of corporation development and all of that. So there are a lot of issues. So the design was also not completely presented. There are so many gaps. I see that. So maybe people like our experts from geosynthetic field should really see that they should also push it hard. Like a good technology should not get a bad name. That is where, and then they should push it hard. When there is a good technology, why they are silent in India? This is a very sad part. Like you want a good medicine, but you don't want a good product to be used in geotechnical engineering. Good technology, good product. Why are you silent? I mean, youngsters particularly, because the geotechnical role is so encompassing nowadays. Whether it is for, we need to really pick up ideas, and I think it is the youngsters who got all the awards today, I think they'll get some more awards now in Springer Awards. I think we have too many awards, but I was suggesting one buddy, it is just for encouragement. I don't think that it is not for, a completion award.
This is just a starting.
It is just to
stepping stone.
Yeah. So I think most of the youngsters, and of course, even for us, learning is a continuous process. We need to wake up even now. This time is up for us to see that better practices can be done. So anybody would like to comment?
Also, we need to fast track the updating of codes.
Yeah.
Exactly. Codes is 40 years old.
Sir, that is the reason why actually I was talking to Jay today, just now, about that. Let IGS come up with their own thing, because that how many times I spoke to that IS code, Madam Madhurima, there is no use. I must have given half a dozen mails in this 6 months alone. Talk to that Pant, he's Mr. Pant, who is in charge of IS codes. Absolutely no response from them. I am very sorry to say. If IS codes are not responsive, at least we should take our own work. I mean, I don't think we can't depend on. See, IRC also, the way IRC does the codes, though we are a part of IRC, we have to set our house in order, nothing short of. Okay.
Sir, there is no need of putting any compulsion. We should we should take the responsibility.
Yeah.
If you just see the IRC, many of the recommendations of IRC are adopted as such by the industry.
Correct.
But the same thing is not happening with the IS code for the this geotechnical.
Yeah.
So we should take them. We are going to implement those design recommendation or investigation guidelines. So we should take the moral responsibility. There is no need of any law or something or some binding thing. We should take it.
See, what can be done, written properly, we should not have a confusion. But from IGS side, at least we should be able to give a proper document. As a professional committee. Actually, I think one of the IGS is one of the best professional countries in the country, where there are so many professors, so many field engineers. You don't you go to institution of engineers and others. It's not like that. So we have a chance to do a lot of good things. This is an opportunity for us. Yes, sir.
Can I come here?
Yeah, yes, sir. Ram. Yeah, please.
You see, there is a new idea that why geotechnical codes are not being used, because many of the undergraduate students actually doesn't know anything about it. So we should introduce some codal guidelines which are available to the code undergraduate students.
Correct.
So right now, the undergraduate courses, we are not so much emphasizing, particularly for the geotechnical and other areas, and compared to structural engineering. Structural engineering, IS 456, IS 800 is been regularly used in the courses. We should also start using some of these codes.
Correct.
Then it becomes very practice, and then also there will be a reason for updating and all that, and then practicing engineers will follow.
Right.
And I think one of the earlier speaker very clearly highlighted the particularly IRC is voluntarily being followed by the people. They develop, they also use it. Similar thing here, the development is done by somebody else. Some committee members are there, but BAS, I don't know really how it functions. But finally, end of the day, if you be part of the development as well as utilization, that would be better. Thank you.
I think the people are ready for giving the Springer Awards. I just got the message.
Yes.
So I think we'll go ahead. Yeah. Thank you, Professor Sitaram, Dr. A.P. Singh, and all of you for the valuable contribution. Let us continue our discussions.
Thank
I
you,
think
sir.
we will.
Professor Babu, sir.
Yeah.
Give me 1 minute time.
Okay,
so in my inaugural report, I missed some of the names who significantly.
Please go ahead.
I would like to thank Mr. Rakesh Reddy and Nagalakshmi. They are DST Inspire fellows working for PhD under my guidance. They are working right from morning 8 to evening 8:30 at our computer center, regularly monitoring the online activity. Along with them, Tulasi, one more PhD full-time scholar of mine, is there. Similarly, Mr. Vinil, he is also one more research scholar of mine working at NITS as assistant professor. And our MTech students of Soil Mechanics and Foundation Engineering, Mr. Sai Chandu, Mr. Arun, and then Mr. Mehar and Miss Divyavani and Hemant. They are also there because 5 parallel sessions are going on. So each one is working in one link, and they have been helping the delegates and our IGS members in joining to the links and advising. So I thank them very much for helping us a lot. And I would like to thank chairman and co-chairman of plenary and technical sessions. Some of them I have requested to chair more than one session also. They have obliged, and they have conducted the sessions very effectively because more papers got presented. Patiently, beyond time also, they conducted the sessions. So I thank them for everything. Thank you. Now we will move on to the Springer Best Paper prize announcement. I request Dr. Rajalakshmi to take over.
Yes. Could you please play the awardees list, sir? And here we are with the list of Springer Best Paper Prizes 2020. IGC 2020 congratulates all the winners of the Springer Best Paper Prizes 2020. For the theme Soil Behavior and Characterizations of Ground, the first prize goes to Load Penetration Behavior of Composite Soil with Nano Alumina Material under Soaked and Unsoaked Condition. This is backed by Shivapriya SV, Madhu TR, and Sajid Ali from Springer ebook voucher of Euro 120. Is anybody? Do we request? 1 second. Is anybody available? Shivapriya, Madhu, and Sajid Ali to respond? Okay. We go to the second prize. This goes to the effect of alkali activated fly ash on shrinkage characteristics of expansive soil. This is by Vamsi Navya Krishna M and Sirish Saride. Vamsi Navya Krishna or Sirish sir, are you available to respond?
Yeah. The organizers and the selection team. I think student is not here. On behalf of him, I thank you everyone. Thank you.
Very glad for you, sir. Very glad. The next one, please. For the themes Shallow Foundations, Deep Foundations, and Forensic Geotechnical Engineering. And here's the first prize to the paper, Probabilistic Investigation on Seismic Bearing Capacity of Shallow Foundation on Unsaturated Fly Ash. This is by Abhijit Anand and Rajiv Sarkar. Abhijit Anand and Rajiv Sarkar. Kindly respond if you're available. Okay, we move on to the next prize. And here's the second prize for the paper on short piles for a solar power plant in Western Rajasthan by Mohit, Ravi Sundaram, Sanjay Gupta, and Jitendra Kumar.
Thank you very much. I'm very grateful to you for giving me this award. Really honored to receive it. Thank you.
IGC 2020 congratulates you, sir. Wish you many more. The next prize, please. Oh, we also have a consolation prize for ultimate bearing capacity of strip footing on reinforced embankment using upper bound limit analysis. This is by Debashish Manna, Santosh Kumar, and Priyanka Ghosh. Debashish Manna, Santosh Kumar, or Priyanka Ghosh. Please respond if you're available. Yes, next one, please. For the themes, environmental geotechnology and transportation geotechniques. First prize goes to the paper on development and study on the properties of eco-friendly coir latex composites. This is by CB Joy, Jayashree PK, and Balan K. CB Joy, Jayashree, and Balan K. IGC congratulates you. The next one, please. Second prize to the paper on decontamination of heavy metal contaminated soils by phytoremediation, pot experimentation. This is by Rajshekhar P. and Somnath Mondal. Request Rajshekhar P. or Somnath Mondal to kindly respond. The next one. For the themes, landslides and slope stability and tunneling and deep excavations. We have the first prize, which goes to the paper Forensic Analysis of Retaining Wall Failure. This is by Aravind PS and Neerad Mohan. Aravind PS or Neerad Mohan. The next one, please. The second prize to the paper, assessment of effect of deep excavation on adjacent structures using finite element analysis. Anand MH, Solanki CH, and Doda Border GR. Anand, yes.
Thank you, ma'am. Thank you so much, IGC 2020 team, and I'm really grateful to my Professor C.S. Solanki and Jia Dodagoda, sir. I'm really thankful to you. Thank you so much, ma'am.
Congratulations, Anand, sir. The next one, please. For the theme, developments in ground improvement. First prize to the paper, effect of lignosulfonate on strength and deformation behavior of swelling soils. This is by Richa M. and Rajesh S. Richa and Rajesh. The next one, please. The second prize to the paper, experimental study on waste tire chips reinforced sand using cyclic plate load test. This is by Sanket R, Ravikant M, and Ashirvad S. Request one of you to respond.
Ashirvad, yes, ma'am.
Yes.
Thank you so much. We are deeply grateful to IGS 2020. Thank you for the award.
We have been noting your comments in the chat box. Thanks, Ashirvad. Thank you.
Thank you. Thank you so much, ma'am.
Yeah. The next one, please. It's time for Samadhiya sir to take another consolation prize on performance of vertically confined shallow foundation on reinforced sand under concentric loading. This is by Kirtimayi B and Samadhiya NK.
I think Kirtimai is there. Okay, so I thank the jury for selecting this award. Thank you so much.
So you have a good catch, sir. You have good number of prizes. Congratulations.
Hello.
The next one, please. For the themes numerical and physical modeling and soil dynamics. Evaluation of liquefaction potential of Class C fly ash and calibration of numerical model. Sangeeta Yadav and Sumanta Haldar.
Yeah, so myself, Shamanta Haldar. I think my student is not available. Anyway, on behalf of her, I thank you, the organizing committee and the selection members. Thank you once again.
IGC 2020 congratulates you, sir. Congratulations once again, Sumanta Haldar, sir. The next one, please. Second prize to paper on studies on centrifuge modeling of rainfall-induced landslides. Deepankana Bhattacharjee and Vishwanathan BBS.
Thank you so much to the organizing committee, to the jury. This is Dr. Deepankana Bhattacharya. I am accepting the award on behalf of myself and Professor BVS Vishwanathan. Thank you.
Oh, that's wonderful, Deepankana. Congratulations once again. Wish you many more. The next one, please. For the theme, geosynthetics and reinforced soil structures. First prize to dynamic response of dry rubber tire chips and sand mixture by Amanta AS and Satyanarayan Murthy G.
Thank you, ma'am. This is Amanta A.S. Adyasha here. And it is actually very hard to express my feelings into words. But yes, I am thankful to my professor, Professor Satyanarayan Murthy Dasaka from IIT Bombay. And of course, the selection committee and IGC for considering me worth it. Thank you.
Congrats, Amanta. Congratulations.
Thank you, ma'am.
The next one. Paper, probabilistic analysis of reinforced soil retaining structures using farm and surrogate-based Monte Carlo. Ekansh, Anindya,
yes, ma'am.
and
Yes, ma'am.
Yes.
Myself, Ekansh Agarwal. I really want to thank IGC 2020 for selecting our paper for second prize. Thank you so much.
I wish you all the best, Ekansh. Congratulations.
Welcome, ma'am. Welcome.
The next one, please. For the theme scour and erosion and offshore geotechnics. The first prize goes to the paper experimental model setup of soil piping and improving piping resistance using coir geotextile. Anjana VP and Niranjana K.
Yes,
Anjana is here. Yes, yes.
Yeah, ma'am, I'm very delighted to receive this award and I'm very happy and I express my thanks to the whole IGS 2020 team and to my guide and co-author, Miss Niranjana K. Thank you.
Oh, you're literally beaming. Congratulations. Wish you many more.
Thank you, ma'am.
Next one, please. The second prize to the paper on prediction of increase in offshore pile shaft capacity following installation using the coefficient of horizontal consolidation. Ramesh G, Parthasarathy CR, and Sirish S.
Ma'am, Ramesh here. Thank you, IGC, and thank you to the jury. Congratulations to Dr. Partha and Professor Sirish. Thank you.
Oh, congrats once again, Ramesh. Wish you many more. The next one, please. Oh, we have come to the end of the award session. Just please hold on. We have just 1 point on the agenda left.
One.
Yes.
1 minute, madam.
Yes, sir.
I request all the delegates to switch on the video so that we will take some snaps. So I request all of you to keep your video on.
Oh, this is how the virtual photo session is. Yeah, we're getting used to it, sir.
All of you, please keep your video on. Harika, and Poju.
Should we smile now?
Manoj.
Yeah.
Make it fast.
Yes, sir.
So that photos will be over.
So somebody will say cheese.
Yes, sir. You got 2 awards. You should say that.
Manoj. Sharanya. Jishnu Chaudhary. Yes, no. Oh.
Hey, don't look at mobiles. You can just see, smile now.
Yeah,
this is
look
the
at
time
this
to
screen.
smile.
Keja, Mirara.
It's difficult to hold the smile for long, sir.
Yeah. You have a natural smile.
Oh, thanks, sir. Thank you.
All completed? Okay, thank you all.
Thank you. Thank you.
Thank you, IGC team.
So thank you, everybody. It's a great, grand success. Thank you, Professor Satyanarayana Reddy, for taking this responsibility on behalf of the IGS main office and all the delegates. I would like to thank you. Thank you very much.
Thank you.
See you all.
Thank you.
Wish you all a happy New Year 2021.
Sir, I request all the delegates to stay. The next item, vote of thanks, is there. After that,
We have,
yeah, that is there.
we
So
have the
request all
national
of you to
anthem as
stay
well.
for national.
Okay.
So yesterday somebody was saying that we could have a 4-day conference as well. But I think there is a grand celestial event scheduled for 21st December, the grand Jupiter-Saturn conjunction. So I think we should clear the virtual space. And so I call upon Sri Professor Yeram Seti Abulu Garu to say the vote of thanks, Organizing Secretary for IGC 2020.
Good evening to one and all.
বলো এটা এখনো চলছে তোমার কিছু তো বললো না ওয়াইজি তো দিয়েছে অনেককে
Request all others to kindly mute the tech support, kindly mute all the others. Sir, please go ahead, sir. Ablu sir, kindly.
Hello.
Yes, sir, you are heard. You are audible. Please go ahead, sir.
On behalf of IGS Visakhapatnam chapter and the Department of Civil Engineering, Andhra University College of Engineering, it is my privilege to propose vote of thanks for the valedictory function of Indian Geotechnical Conference, IGC 2020. I would like to express my deep gratitude to Professor G.L. Sivkumar Babu, President IGS, and Professor J.T. Sahu, Honorary Secretary, IGS, and the National Executive members of IGS for the opportunity to organize IGS 2020 by Andhra University College of Engineering Autonomous, Visakhapatnam. We are indeed grateful to Professor T.G. Sitaram, Director IIT Guwahati, for delivering 42nd IGS annual lecture. The organizing committee thanks the distinguished keynote speakers for accepting our invitation and sparing their valuable time for delivering the lectures. Professor Charles W.W.N.G., President ISSMGE, Dr. Yoon Chul Shin, Vice President Asia ISSMGE, Professor G.L. Sivkumar Babu, President IGS and Professor IISc Bangalore, Professor G. Han, University of Kansas, Lawrence, Professor Anand J. Puppala, University of Texas, Arlington, Professor Sai K. Vanapalli, University of Ottawa, Canada, Professor Gopal Madabhushi, University of Cambridge, Professor M.N. Viladkar, IIT Roorkee, Professor K. Rajgopal, IIT Madras, Professor Manoj Datta, IIT Delhi, Professor G.V. Ramana, IIT Delhi, Professor B.V.S. Viswanathan, IIT Bombay, Professor Deepakar Chaudhary, IIT Bombay, Dr. Kumar Pichamuni, Messrs. AECOM India Private Limited. Our sincere thanks to all the delegates, team speakers, session chairman, co-chairman, and coordinators. I take this opportunity to thank all the reviewers and technical committee members for providing their valuable comments in time and help towards the improvement of quality of papers presented in the conference. I would like to express deep gratitude for the overwhelming response from the participants. We sincerely thank the sponsors for providing the necessary funds for organizing the event. Sponsors, Messrs. HECO New Delhi, IGS Pune Chapter, Messrs. Garware Walropes Private Limited, Messrs. Emil Limited, Messrs. McAferry. Co-sponsors, IGS Kochi Chapter, IGS Roorkee Chapter, IGS Bombay Chapter, IGS Chennai Chapter, IGS Trichy Chapter, IGS Surat Chapter, IGS Delhi Chapter, Messrs. Saradhi Geotech and Engineering Services Private Limited, Bangalore, Messrs. Tankate Geosynthetics India Private Limited, Messrs. Strata Geosystems India Private Limited, Messrs. Sai Sri Constructions Vishakhapatnam, Messrs. Sarita Infra and Geostructures, Messrs. Cosex Vishakhapatnam, Messrs. JHS Consulting Vishakhapatnam. Supporters, IGS Bangalore Chapter, IGS Guntur Chapter, Messrs. Sri Sai Geotech Vishakhapatnam, Messrs. Simhadri Borewells Vishakhapatnam. Without their generous support, it would not have been possible to organize this conference successfully amidst the pandemic. I express grateful thanks to the sponsoring organizations whose wholehearted support has made this conference a reality. On behalf of the organizers and on my own behalf, a deep appreciation for the support and encouragement provided by our beloved Vice Chancellor Professor PVGD Prasad Reddy for the encouragement and providing necessary facilities for organizing the conference and for gracing the inaugural function and for his inaugural address. I sincerely thank Professor Ramasudha, Director, University Computer Center, AU, and the staff for providing our team with the timely support to successfully organize the conference virtually, and a special mention to our renowned Kuchipudi exponent, Mrs. Balakondal Rao. I am also thankful to all the research scholars and the students who have greatly helped us in organizing the conference. I thank the members of press and electronic media for providing extensive coverage of the conference vividly. Thank you, ladies and gentlemen, for making IGS 2020 successful. Thank you. Thank you, one and all.
Thanks, Professor Abulu. Request you all to kindly rise for the national anthem.
No sound.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you all, sir. I'll request you to.
Thank you.
Bye.
Bye. Sir. Thank
Bye.
you.
Bye, everybody. Thank you so much.
Bye, everybody.
Thank you.
Bye. Thank you,
Bye.
sir.
Happy New Year.
Thank you.
Bye.
Thank you, sir.
Goodbye, everybody. Happy New Year.
Happy New Year to all of you.
Thank you all of you and
Thank you all. Wish you happy Christmas.
Ah, mungkin.